as it's the first time in over 50 years that we have humans completely unreachable by anyone else on Earth. No matter how distant or secluded, we could reach anyone living on Earth, but while the crew flies behind the moon, it's simply impossible to make contact with them. And we just heard confirmation here in Mission Control Houston that we have reached the closest point of our destination to the moon at MET 5 days, 25 minutes, and 34 seconds. And we anticipate the spacecraft's altitude is approximately 4,067 statute miles above the moon. We're continuing to track what the crew is doing while around the other side of the moon. They are continuing to take pictures of the Earth, of the moon, the Earth now out of sight. What they are in right now is a crew choice event. The science team has encouraged them to find interesting features on the surface, to take photos of those, and describe why they were interesting. Something else that they'll be looking toward next, just momentarily, will be impact flashes. They've got a few minutes allotted to look at the darkest portions of the moon. They're interested in short-lived flashes on the lunar surface because these would be caused by impact bombardment. After their impact flash targeting, the team is interested in if the crew can see lofted lunar dust. This would only be visible just before Earthrise. Now 20 minutes until we expect to regain communications with Integrity and the astronauts for Artemis II. We are getting our first views from Orion after the loss of signal. Orion has come back around the other side of the moon, and that little crescent that you see is Earth, over 252,000 miles away. With this transit complete, lunar flyby continues, but Orion has also technically begun its journey home. This view from inside the Orion spacecraft, all 4 astronauts now back on the other side of the moon and in contact with us on Earth. Their tasks for lunar flyby did not stop as they went behind the moon and out of contact with us. We anticipate during that time they were attempting to image some impact flashes, short-lived flashes on the lunar surface, which would be caused by impact bombardment and potentially even a lofted lunar dust. Right now, of course, they are getting pictures of Earthrise.
Integrity, comm check.
Integrity, we have you loud and clear. How many?
Houston, we have you the same, and it is so great to hear from Earth again. To Asia, Africa, and Oceania, we are looking back at you. We hear you can look up and see the moon right now. We see you too. When we burned this burn towards the moon, I said that we do not leave Earth, but we choose it. And that is true. We will explore, we will build ships, we will visit again. We will construct science outposts, we will drive rovers, we will do radio astronomy, we will found companies, we will bolster industry, we will inspire. But ultimately, we will always choose Earth. We will always choose each other.
Integrity from Earth, our single system, fragile and interconnected. We copy. Those of us that can are looking back. Integrity, Houston, in mission control, all of your flight controllers and your flight director have flipped their Artemis II patches around. We are earthbound and ready to bring you home.
A very special moment just now in mission control ahead of the crew's flight to Kennedy Space Center, and during one of their last sims or simulations here, they visited the mission control team in Artemis Mission Control in Houston and brought us each a patch. Everyone in the flight control room has had these on their signifiers at their console. On one side of the patch that you've probably seen is the moon with the Earth behind it. Now that we've passed behind the moon and we are returning home, The flight control team has instructed everyone in the room to switch their patch around so that the Earth is closer and the moon is behind us. We are really looking forward to seeing the Artemis II crew. And the Capcom, Jenny Gibbons, did call that update up to the crew that the flight control team here has turned their patches around as was instructed by the crew during that last sim. And we are counting down the days until they get home. They are now 5 days, 1 hour, and 3 minutes mission elapsed time into the Artemis II mission. The Artemis astronauts are about to experience a solar eclipse from their capsule. And this is a solar eclipse that no one else on Earth will experience. This eclipse is about 54 minutes, and to the astronauts, it'll look a lot like a total solar eclipse on Earth, except the moon is going to be huge compared to the sun, unlike when you watch one on Earth and the moon and the sun appear about the same size in the sky. You're getting a live look from Orion as the crew observes a solar eclipse from the moon.
Science integrity in the blind. This is continues to be unreal. The sun has gone behind the moon, and the corona is still visible, and it's bright, and it creates a halo almost around the entire moon. But when you get to the Earth side, the Earth shine is already shown. I mean, almost seconds after the sun set behind the moon. You could see Earth shine. The Earth is so bright out there, and the moon is just hanging in front of us. This black orb out in front of us, in front of now, not the blackness, but the gray that blends and drifts into the blackness. We can see stars and the planets behind it. And Christina is in window 1, Reid is in window 2 with the long lens, and Jeremy is describing it in window 3, and it is quite an impressive sight. You can still see the horizon lit up brighter where the sun set on that side of the moon. It is bright, and Earthshine is very distinct, and it creates quite an impressive visual illusion. Wow, it's amazing. Let's see, not a huge change in here, just an update. The camera settings for Earthshine are challenging. This one's challenging to capture. What we're seeing, we're just not picking up on the cameras. And after all of the amazing sights that we saw earlier, we just went sci-fi. This has, it just looks unreal. You can see the surface of the moon between, I guess, the Earthshine. I guess Earthshine. You can actually see a majority of the moon. It is the strangest looking thing that you can see so much on the surface.
Integrity Science, we were loving your Science Sit Reps in the Blind, and it should come as no surprise that we have a number of follow-up questions. First, you mentioned Reid observing meteors. Can you speak to that? Were you referring to comets or impact flashes or something else?
Yeah, there was a little bit of giddiness. We have seen 3 impact flashes so far. I saw 2, and Jeremy has seen 1. Undoubtedly, Jeremy saw 2, so that's 4 total. Undoubtedly, quick impact flashes. It was not sun glint off of particulate from the thrusters or the purge tanks. It was definitely impact flashes on the moon. And Jeremy just saw another one. Go ahead with your next question.
Amazing news. I literally just looked over at the SIR and they were jumping up and down literally. If you could describe where on the moon you saw them, please.
So they've all been either on or a bit south of the equator and on the Earth side of the moon. Stand by. All right. right, so Jeremy has seen them kind of on and south of the equator, kind of spread across the moon, and mine were both south of the equator and just a little bit left of center of the moon.
Incredible news, Reid, and reminder, we have citizen scientists here on Earth looking for impact flashes, so hearing you saw them on the near side means that people saw them too.
One of the other things I wanted to describe, which was surprising to me, but the entire moon is lit up. It's glowing behind the entire moon. I thought it would look, dark against the black sky or deep space, but the sun is lighting up the entire limb of the moon. You can see the entire perimeter of it, and even now with the sun far behind the moon, you can still make out little bits of topography around the entire limb, just bumps as you go around it. And there's about the glow around the moon, once your eyes adjust, is easily 10 widths or diameters of the sun around the entire moon. Science in Houston integrity. I know this observation won't be of any scientific value, but I'm really glad we launched on April 1st because humans probably have not evolved to see what we're seeing. It is truly hard to describe. It is amazing. I'm not sure if we talked much about the star field, but we've got lots of stars. You've got the nice glow around the moon, but, right off the, well, we're upside down now, but from upside down 4 o'clock, right off the edge of the moon, looks like a planet, that line of planets. There's something a moon diameter to the left and something right off the limb of the moon to the right, and then something orange. It looks orange to the right of that, about half the moon diameter. So, but anyway, there are definitely stars. I think some of those planets that you said we might see, we're seeing. And so in unreal view, yeah, the moon in the foreground is one of the darkest things we see out the window, and now it's deep space behind it is kind of dark blue like it looks from Earth, but we can also still see stars. It's quite a wicked view.
Victor,
Good morning from Mission Control Houston. We are at a mission elapsed time of 5 days, 14 hours, 2 minutes and counting. The Artemis II crew is currently in their sleep period. Now, we would like to share with the world that while the crew was asleep, we did receive some of those stunning downlinked images from the lunar flyby, which took place earlier in the cruise day. So let's take a look. Here we have it. The first image we see from behind the moon, the crew watched Earth set. There's a soft blue arc fading behind a silent, cratered horizon. Part of this world was already in darkness, and the rest was still alive in motion, with clouds turning over ocean halfway a world away. In the foreground, we see the moon, unchanged for billions of years, and beyond them, something rare in spaceflight. Watching not a sunrise, but home slowly slipping away. What a breathtaking image. We also have a second stunning image, and here we have it. This image was captured by the Artemis II crew during their lunar flyby, which again took place here on Earth. It was April 6, 2026. And this view shows the moon fully eclipsing the sun. From their vantage point, the moon appears large enough to completely block the sun, creating nearly 54 minutes of totality, far longer than what we've experienced from Earth. The sun's corona is forming a glowing halo around the dark lunar disk, revealing the outer atmosphere normally hidden by the sun's brightness. With the moon in shadow, even distant stars become visible, points of light that are usually washed out in images like this. Along the edge, you can also see a faint glow on the moon's surface. That's sunlight reflected from the Earth, softly illuminating the near side. It's a striking view and a rare opportunity to observe and document the corona as we return to deep space. For now, this is Mission Control Houston. Good morning once again from Mission Control Houston. We really hope that you enjoyed those photos that just came down from the crew who's asleep aboard the Orion spacecraft. We are at a total mission elapsed time of 5 days, 14 hours, 9 minutes and counting of the Artemis II mission, and we're going to be continuing our live continuous coverage here. With me, I have Franklin. You're the Artemis III Vehicle Integration Manager.
That's correct.
Thank you so much for being here. Tell us a little bit about your role and what you're doing.
So as a vehicle manager, what I do is I kind of see myself as like the Artemis III Orion's mother. I followed it all the way from cradle to grave. I watch it being assembled. I watch making sure the parts come together. And essentially I watch it just like a mom would do, right? You know, you take your kid to school, you make sure they all have lunch, and make sure you take them to the doctor's office, and any issues come arise, we went ahead and just we have to address it, get it through, and we get it out the door, and we send it over to the ground operations, the exploration ground systems. They will put it together on top of the rocket. I follow through the mission. I work with the FOD, the flight operating director. I work with the SLS program, the EGS program, and I make sure that we have a successful mission, launch and mission.
Excellent. And so it's like watching your child be born, take their first steps,
100%.
and then they're going off to college almost.
Yeah, it's going to be a sad day well, it's a happy day when we launch.
Exciting, but bittersweet.
Exciting. When he comes back, then it's, everything is on you, right? You're watching the mission, your spacecraft, you got your 4 crew members on board. You want, make sure that you're hoping that, and we know the vehicle's doing good, and we're going to come home safely, and then it's going to be a bittersweet to see that mission is going to be over soon. And again, see all those 4 crew members come out, and it's going to be fantastic.
Artemis II is coming to an end, but we are now on the heels of Artemis III. So you are playing quite a significant role in the mission that's coming up. So tell us what we're going to expect for future Artemis missions.
So for Artemis III, the crew module right now is in Florida, in the ONC building. It's going to do all the testings. The service module is essentially done. So we'll be mailing it pretty soon this summer. Our goal is to roll out by the end of the year or early next year. Then we're going to be able to, put on top of a rocket, SLS rocket, and we should be able to launch sometime in 2027. So that's our goal. So there's the Orion spacecraft.
So just for our viewers, let's talk about what the crew module is and the service module.
So the crew module is this conical shape, very much similar to the Apollo capsule that you recognize. Anything below that, anything that's white right here, including the solar array wings, that will be the service module.
Okay, so I'm going to put Orion this way up right now, and then for our viewers, it's this piece of the vehicle, right?
This will be the service module from this part.
This point
onwards. Crew module adapter CMA ring, all the way down to the ESM, the service module. This is service module.
Service module,
this only part is crew module.
Okay,
yes.
excellent.
And crew module is where the astronauts are obviously in right now.
So thank you for doing that little show and tell with us. Tell us a little bit about some of the objectives for Artemis III.
So the objective for Artemis III right now, as Administrator had laid out, is to bite down the risk for the upcoming mission, for the moon landing mission of Artemis IV. Our objective is to test out how do we integrate and dock with our landers, both the Blue Origin lander as well as the Starship from SpaceX. We're going to go ahead and practice it. We have never done this yet. So Artemis II, as you have shown, we did the RPOD, we did a proximity rendezvous, but we didn't actually do a docking. So our goal in Artemis III is to actually dock with each of the vehicles.
Got it.
Okay. And then try to go inside so that we essentially bite down the risk of docking with another spacecraft that we have never done before. And able to ingress inside and experience it, the environment.
If I'm going to translate this to more generally, what we're going to do is for Artemis III, we will fly in high Earth orbit.
Low Earth orbit.
Low Earth orbit. This is the docking adapter here.
Yep, docking module.
And so the docking module will dock to another spacecraft.
That's correct.
Right, the human landing system. They will dock. They will practice docking and undocking, just like we did for Artemis II with the proximity operations.
Except we don't actually dock.
Except we didn't dock. So this time we'll actually dock. And then when you said they will ingress. They will enter the human landing system from Orion. Is that right?
So that is going to be the goal. We are trying to find out. Our goal right now is to try to go inside, because then really demonstrate that we had the ecosystem on the other vehicle as well.
Right.
That's still being discussed right now.
Okay, so we want to make sure, as we discuss that, if we do end up going inside the human landing system, then that will also help test out the environmental control and life support systems.
That is correct.
Got it. Okay, that's really great to know. So then, are there any other key objectives that you may have missed, or anything else that we should know about Artemis III?
I mean, just in general, how the crew, like Artemis II, we got 4 crew done the fantastic job right now. They're on the way back.
Right.
And I think it's going to be the second time we fly the crew again on a crew vehicle. We just want to make sure that the system that we have built, that we have experienced on Artemis II, do we have the same exact experience with Artemis III? This way we get consistency, so we can get a trend, right? Just as we get more experience with the spacecraft, then we get more comfortable with the spacecraft, and we are able to relax some of our requirements and stuff like that, so that we are more comfortable. We expand our performance, envelopes.
So I'm summarizing here. The more data we get, the more we learn, the more we can adjust and improve, or
you got it. That's
shorten
exactly
processes where possible.
Shorten processes and understanding how the vehicle behaves, so give us more confidence on the spacecraft.
Okay.
If we ever see something that's not as expected, with the experience that we have, it gives us more confidence on the spacecraft performance.
True. Yeah. Okay. This is so exciting. Tell me how you're feeling now that you're seeing your baby fly, and almost, we have a clock up here, splashdown, 3 days, 11 hours, 2 minutes.
Well, it's not really my baby, right? Because I was a vehicle manager for Artemis II for a little bit, and then Bernal Rodriguez came in and she took over. So she's doing a fantastic job, and she's up there upstairs right now doing the MER. So I'm watching afar in a way, and I'm watching her back up. I'm cheering her on, so I still feel good, but it's still, I was part of the Artemis II. I think it's great that I see, like I said, like this spacecraft with Reid, Christina, Victor, and Jeremy in the spacecraft and doing what they were able to do is just fantastic. It really brings tears to my eyes just to see them out there. They're going to be coming home Friday. We're going to learn so much from them, right? It's not just about the spacecraft alone that we are able to monitor. It's really about them living in the spacecraft for the 10 days. And then what do they see? What do they experience? How do they feel? That's really what we need to learn from. Because I was Artemis I vehicle manager that we flew around the moon for 26 days, but nobody was down there. Right. So we learned about our spacecraft, but this time we had the 4 crew members telling us how the vehicle really behaves, how it works. And if that experience is going to really give us to improve on Artemis III, so that Artemis III crew members is able to have a better experience again, and then their experience going to build on for Artemis IV and go on.
That human factor that gets introduced when crew flies is so fascinating, because you can learn so much more. Just like yesterday with the flyby, the descriptions coming from the crew, not only was I sobbing for most of that flyby, I was also just enjoying seeing them be geologists for the team on the ground. So similarly, we're going to get a lot of information back about Orion. I'm incredibly excited for what you're going to learn and to see what sort of improvements or adjustments happen to Artemis III.
100%. I really think that with the experience that the crew is able to come back, and we're sure that we'll get a debrief from them. What went well, what didn't go as well, what should be improved, and we'll definitely try to we'll assess the situation, we'll assess their recommendations, and we'll look into what we can do to improve on Artemis III so that the next crew would have a better experience and able to operate the vehicle better.
Well, Frank, I really appreciate you taking the time out of your busy schedule to join us today. And once again, we are here in Artemis Mission Control, telling you all about the Orion spacecraft, and we'll continue to follow along with our live 24/7 coverage of the Artemis II mission. This is Mission Control Houston coming to you live from the Artemis Flight Control Room here at the Johnson Space Center. The Orbit 3 team of flight controllers is currently on console, and we are conducting an activity. So for the last couple of minutes, you would have seen Orion making some movements. Those are actually the solar array wings that are moving around doing the surveying activity that I had mentioned earlier on this morning. So for those of you just joining, you may have been seeing some distorted imagery coming around as Orion's solar array wings were moving around. This surveying activity took place a little bit after the launch and then is now taking place post-lunar flyby. The surveying activity is exactly what it sounds like. Orion's solar array wings are moving around and they are looking at the service module and the crew module to see or assess for any issues, damage post-lunar flyby. So if you don't know this, the bottom half of the vehicle, that's the European service module. In the center, that is the adapter. And then above that is the crew module. And all of that together makes Orion. So we're getting decent views right now coming in of this activity. And you can see the solar array wings getting closer and closer to the vehicle. We'll continue to see some of this activity and we'll continue to bring it to you live as much as possible where views allow. But as this happens, you can see the team doing the surveying to make sure that the crew is ready to come back home. So speaking of coming back home, we are 3 days, 10 hours, 48 minutes and counting down from splashdown. We are halfway through the mission. So for now, what we'll do is we'll take a moment to take a look back at Flight Day 6's flight highlights. This is Mission Control Houston.
Mark, I think one of the most interesting things right now is the four of us have looked at this moon our entire lives, and the way we are responding to what we are seeing out the window is, it's just like we're a bunch of little kids up here. Just, we cannot get enough of this. It's amazing. Thank you for the privilege.
Thank you for sharing that special perspective you have with all of us back here.
This is Artemis Mission Control in Houston, Texas. We recently received confirmation that the Orion spacecraft and its crew have officially entered the lunar sphere of influence. That milestone taking place at a mission elapsed time of 4 days, 6 hours, 2 minutes, and 54 seconds into the Artemis II mission. By reaching this milestone, it means that the gravitational forces of the moon are now greater on the Orion spacecraft than that of Earth.
Hello, Artemis II. This is Apollo astronaut Jim Lovell. Welcome to my old neighborhood. When Frank Borman and Bill Andrews and I orbited the moon on Apollo 8, we got humanity's first up-close look at the moon and got a view of the home planet that inspired and united people around the world. I'm proud to pass that torch on to you as you swing around the moon and lay the groundwork for missions to Mars for the benefit of all. It's a historic day, and I know how busy you'll be, but don't forget to enjoy the view. So, Reid and Victor and Christina and Jeremy and all the great teams supporting you, good luck and Godspeed from all of us here on the good Earth.
Good morning, Houston. Integrity on one. That was an awesome message from Jim Lovell, and very cool to hear him. Welcome us to the neighborhood. It's going to be a great day. Thank you.
Good morning, Houston, from inside Integrity, 215,049 miles away from Earth and 12,712 miles from the moon. Let's actually savor the calm delay that we have. We're ready for the morning DPC.
Beautiful. We are savoring it down here. Good morning, Integrity, and good morning, Moon. Our room is buzzing with moon joy today, and I imagine yours is too.
We are ready to go. We are looking forward to working with and for the science team. And we are just excited to be so close to finally accomplishing what we've been training for so many years. And also, we want to say thank you for that really special message from Jim Lovell. We have a pretty neat emblem up here. We have a patch that was flown on the Apollo 8 mission. And that patch is here on the Artemis II mission as well. And that was sent to us by the Lovell family, by Jim Lovell's son. And so that was a really special way to start the day. And he said to welcome us to the neighborhood, and it's great to be in this neighborhood, and we look forward to sharing this neighborhood with you all.
We can't wait. We see the patch, and it's looking beautiful. Thank you.
When this showed up in our office from his family, we were completely honored, and the Earthrise, which this crew is responsible for taking that photo, has been instrumental both to our crew as our ethos and values, but also just personally to myself. I had the photo up in my room as a kid, and it was part of what inspired me to keep working hard to achieve things I dreamed about. Also, we took a deep dive into the cockpit recordings around the time that picture was taken, and it turns out there was a lot of hubbub, kind of I wouldn't say fighting over cameras, but definitely everyone wanted to capture the shot. So we're happy to carry on that legacy because we often are all glued to windows and looking for cameras too.
And I'll just close. I know it looks like a piece of paper in the camera there, but that is actually the original Apollo 8 patch printed on silk that they had done before they launched, and they flew that with them on their journey around the moon, and then the family handed it over to us, as I said, and it's just a real honor to have that on board with us. Let's go have a great day.
Right now, the Artemis II crew and Mission Control are preparing to support today's lunar flyby, the first time we've sent humans around the moon in over 50 years.
Integrity, you can use the OEs and your HHP camera for the milestone words at the Apollo 13 record distance.
You'll notice that we pause every time we hear communications to and from the crew. They are the stars for today. This afternoon, the crew will have their closest approach of the moon and will surpass the record. That record just mentioned of the furthest humans have ever flown, set by the Apollo 13 astronauts in 1970. As you can see, the crew members have dimmed the cabin lights inside Orion. Dimming the lights also helps prevent reflections from inside Orion onto the windows. Ahead of this lunar flyby, let's dive in and explain what you can expect over the next several hours. The crew has about 6 hours allotted to make observations about the moon. Throughout the flyby, their activities have been precisely timelined. There are five blocks of time during which the crew will be observing the moon from Orion's windows. At any time, 2 members will be at the windows working in a pair. One crew member will be taking photos from window 2 with a blue shroud over the window. This can help prevent that glare or reflection from inside Orion. They have an 80 to 400 millimeter zoom lens to use. The other astronaut will be in window 3 using their portable computing device, you'll hear that referred to as PCD, to make annotations. Both of these crew members will make audio recordings of what they are seeing, and they'll wear headsets connected to those PCDs. Those audio recordings will be sent to the science team at a later date. We will not hear them live. The 2 crew members at the windows will swap roles and positions halfway through their timelined block. The other 2 crew members who won't be at the windows at that time will be serving in the background as support. One will be conducting the science sit reps, or situation reports. This is what we will hear live from the crew. They'll be calling down a few times each hour to discuss what they are observing. Those situation reports include how the crew is positioned, any missed targets, or anything unexpected they saw, lunar target descriptions, any hardware issues, and of course, their emotions and reactions as they fly by the moon.
Good morning, crew. This is Science. We couldn't be more excited for a full day of lunar and planetary observations today, the first one in over 54 years. How do you hear me?
We hear you loud and clear, and Kelsey, you just got to know you're pulling us away from the moon right now, so let's go.
Message received. I will keep it tight here. I did just want to start with a thank you on behalf of the Lunar Science team and the entire lunar and planetary science community, of which you are absolutely a part, for what you've already done in this mission and what you're going to do today to inspire the next generation of scientists. I have to say moon joy is the new term that's already become our team's new motto, so thanks for that. A reminder also that your observations so far indicate it will likely take some time for your eyes to adjust. We especially heard that around your terminator observations and your color observations. So reminder to know that your eye adaptation is going to kind of come in throughout your shift, and let us know when you start to see that nuance. Last reminder is around Earthset and Earthrise. When you're viewing us back here at home, you'll be looking directly at Asia, Africa, and Oceania. So I'm sure people watching from those places here on Earth will want to give you all a wave as you take their picture.
And we're live in Artemis Mission Control in Houston, but we are not the only room monitoring today's flyby. As you heard Young mention, in this same building and just down the hall, a multidisciplinary lunar science team supports the Artemis II crew in real time, including experts in lunar geology, impact cratering, volcanism, polar science, imaging, and visualization. There are two integrated facilities, and the first is the SIR, which is what you have right here. That's the Science Evaluation Room. They are embedded within Mission Control to provide science input during live operations like what we see today. Additionally, and not pictured, we have the Science Mission Operations Room, a back room that processes data, evaluates imagery, and supports rapid analysis.
Integrity crew, we have Reid's family in the viewing gallery. You're welcome to say hello.
Well, whether you're being serious or you're kidding around, that is awesome to hear. Thanks, Jenny. And hello to Ellie and Katie. I don't know who else is there, but it's great to know that you're in Mission Control right now, following along. We are having a blast up here, and the view of the moon is absolutely amazing.
I'm seeing a lot of hearts come out of the viewing gallery and even more smiles. Thanks, Reid. Copy heart, copy bracelet. Integrity crew, on April 15th, 1970, during the Apollo 13 mission, 3 explorers set the record for the farthest distance humans have ever traveled from our home planet. At that time, over 55 years ago, Lovell, Swigert, and Hayes flew 248,655 statute miles away from Earth. Today, for all humanity, you're pushing beyond that frontier. Integrity, over to you.
Yeah, from the cabin of Integrity here, as we surpass the furthest distance humans have ever traveled from planet Earth, we do so in honoring the extraordinary efforts and feats of our predecessors in human space exploration. We will continue our journey even further into space before Mother Earth succeeds in pulling us back to everything that we hold dear. But we most importantly choose this moment to challenge this generation and the next to make sure this record is not long-lived. And we have a couple more things we'd like to take this moment for. Our science team helped us out with a couple of relatively fresh craters on the moon that have not been previously named, and our crew would like to propose a couple of potential names for those items or those areas. And we spent a bit of time this morning looking out the window, and we're able to see them now both with our naked eye and through the long lens, and so we feel this is a good time to send this down, and a special shout out to Kelsey for helping us with this. The first one we'd like to suggest is a named crater in honor of our great spacecraft, Integrity. And so if you were to look at Oriental on the far side and then draw a line straight up to Ohm on the far side,
Relatively in the middle is an unnamed crater, and we would like to suggest it be called Integrity in the future. And the second one, and especially meaningful for this crew, is a number of years ago we started this journey in our close-knit astronaut family, and we lost a loved one. And there's a feature in a really neat place on the moon, and it is on the near side, far side boundary. In fact, it's just on the near side of that boundary, and so at certain times of the moon's transit around Earth, we will be able to see this from Earth. And so we lost a loved one. Her name was Carol, the spouse of Reid, the mother of Katie and Ellie. And if you want to find this one, you look at Glushko, and it's just to the northwest of that, at the same latitude as Ohm, and it's a bright spot on the moon. And we would like to call it Carol, and you spell that C-A-R-R-O-L-L.
Integrity and Carol Crater, loud and clear. Thank you.
There was a moment of silence here in Mission Control Houston. And now the team and the Artemis II crew are ready to begin their lunar flyby.
We just realized that we have Earth out window 1 and Moon out window 2, and Earth out window 4 and Moon out window 3, and it gives you the best idea of scale we have had yet. The Moon is about 3 to 4 times the size of the Earth, and it is almost full, and the Earth is just a small crescent out there. It's magnificent. I got a picture of it with the wide lens. Such a majestic view out here.
Amaze, amaze, amaze. Thank you, Reid.
Now this is a view from their lunar targeting package at this time, helping them determine what they're seeing on the moon, as well as on the left, keep up with what their next target will be. As you can see, we have got a long list and an exciting day ahead of us.
Houston, another observation, whole moon. When you look at the moon, something I've never seen in photographs before, but is very apparent, all the really bright new craters. Some of them are super tiny. Most of them are pretty small. There's a couple that really stand out, obviously. And what it really looks like is like a lampshade with tiny pinprick holes and the light shining through. They are so bright compared to the rest of the moon.
School after just being in the 400 mil for the last half hour, looking up close. I got pictures of everything Ike was just describing on the Terminator. It really is a fascinating Terminator. And then Oriental just looks so dynamic right now. It's very three-dimensional out the docking hatch compared to what I was just looking at through the 400 mil.
We love it. We are getting a sneak preview from one of our SAW cameras at what you're looking at, and we see some of what you're describing. We cannot wait to see your photos. Thanks.
Yeah, Jenny, I wish you had some longer lenses on the solar array so you could see the whole moon, but man, it is, or the up-close moon, not the whole moon, but it is just fascinating here. It's so cool.
All right, MPO and INCO, take notes. We want a zoom lens on those saws next time. Thanks, Reid.
At one point, towards the end of the images of my time in window 3, I just had an overwhelming sense of being moved by looking at the moon. It lasted just a second or two, and I actually couldn't even make it happen again. But something just drew me in suddenly to the lunar landscape, and it became real. And the truth is, the moon really is its own body in the universe. It's not just a poster in the sky that goes by. It is a real place. And when we have that perspective and we compare it to our home of the Earth, it just reminds us how much we have in common. Everything we need, the Earth provides, and that in and of itself is somewhat of a miracle.
Science, integrity. First, I wanted to start off with connecting with what Christina said, that it was very moving to look out the window. I had the unfortunate sequence to start looking out the window and then moved to the long lens, and it was hard to speak looking through the zoom because I went straight where Christina went, and I was walking around down there on the surface, climbing and off-roading on that amazing terrain. I also want to underscore something that she said. As we continue to explore, when we actually do go down there to the surface, I know for safety reasons that we would never send someone alone, but I just want to really emphasize how important the discussion time was. When we started to talk, we not only got better science discussion, we got better human connection, and so doing this as a pair, we just learn and grow together, and that's just super important, so thank you for adding that to this plan.
Integrity Houston, you are 6 minutes from your 40-minute lunar flyby LOS. From all of us, it's a privilege to witness you carrying the fire past our farthest reach. Thank you. Godspeed.
Thank you for that, Jenny. And thank you to all of you for allowing us the immense privilege to be on this journey together. It's quite amazing. And as we go on this journey, thinking about the NASA mission to explore the unknown in air and space, to innovate for the benefit of humanity, and to inspire the world through discovery. And as you've gone along on this journey with us, hopefully we're doing just those things. And as we get close to the nearest point to the moon and farthest point from Earth, as we continue to unlock the mysteries of the cosmos, I would like to remind you of one of the most important mysteries there on Earth, and that's love. Christ said in response to what was the greatest command, that it was to love God with all that you are. And he also, being a great teacher, said the second is equal to it, and that is to love your neighbor as yourself. And so, as we prepare to go out of radio communication, we're still to feel your love from Earth, and to all of you down there on Earth and around Earth, we love you from the moon.
Houston copies. We'll see you on the other side.
We are now less than 3 minutes away from loss of signal with the Orion astronauts. The Artemis II crew will be out of signal for about 40 minutes as they are on the other side of the moon, continuing their work photographing the lunar surface, and they will reemerge, and we will also get this view on the other side. 30 seconds now until we expect loss of signal. And we have confirmation of loss of signal of the Orion spacecraft as it flies behind the moon. We expect to regain communications with them in another approximately 40 minutes. This was expected as their spacecraft is now out of direct line of sight with Earth and behind the moon. And this is a poignant moment as it's the first time in over 50 years that we have humans completely unreachable by anyone else on Earth. No matter how distant or secluded, we could reach anyone living landing on Earth, but while the crew flies behind the moon, it's simply impossible to make contact with them. And we just heard confirmation here in Mission Control Houston that we have reached the closest point of our destination to the moon at MET 5 days, 25 minutes, and 34 seconds, and we anticipate the spacecraft's altitude is approximately 4,067 statute miles above the moon. We're continuing to track what the crew is doing while around the other side of the moon. They are continuing to take pictures of the moon, the Earth now out of sight. What they are in right now is a crew choice event. The science team has encouraged them to find interesting features on the surface, to take photos of those, and describe why they were interesting. Something else that they'll be looking toward next, just momentarily, will be impact flashes. They've got a few minutes allotted to look at the darkest portions of the moon. They're interested in short-lived flashes on the lunar surface because these would be caused by impact bombardment. After their impact flash targeting, the team is interested in if the crew can see lofted lunar dust. This would only be visible just before Earthrise. Now 20 minutes until we expect to regain communications with Integrity and the astronauts for Artemis II. We are getting our first views from Orion after the loss of signal. Orion has come back around the other side of the moon, and that little crescent that you see is Earth, over 252,000 miles away. With this transit complete, lunar flyby continues, but Orion has also technically begun its journey home. This view from inside the Orion spacecraft, all 4 astronauts now back on the other side of the moon and in contact with us on Earth. Their tasks for lunar flyby did not stop as they went behind the moon and out of contact with us. We anticipate during that time they were attempting to image some impact flashes, short-lived flashes on the lunar surface, which would be caused by impact bombardment and potentially even lofted lunar dust. Right now, of course, they are getting pictures of Earthrise.
Integrity, comm check.
Integrity, we have you loud and clear. How many?
Houston, we have you the same, and it is so great to hear from Earth again. To Asia, Africa, and Oceania, we are looking back at you. We hear you can look up and see the moon right now. We see you too. When we burned this burn towards the moon, I said that we do not leave Earth, but we choose it. And that is true. We will explore, we will build ships, we will visit again. We will construct science outposts, we will drive rovers, we will do radio astronomy, we will found companies, we will bolster industry, we will inspire. But ultimately, we will always choose Earth. We will always choose each other.
Integrity, from Earth, our single system, fragile and interconnected. We copy. Those of us that can are looking back. Integrity, Houston, in mission control, all of your flight controllers and your flight director have flipped their Artemis II patches around. We are earthbound and ready to bring you home.
A very special moment just now in mission control. Ahead of the crew's flight to Kennedy Space Center and during one of their last sims or simulations here, they visited the mission control team in Artemis Mission Control in Houston and brought us each a patch. Everyone in the flight control room has had these on their signifiers at their console. On one side of the patch that you've probably seen is the moon with the Earth behind it. Now that we've passed behind the moon and we are returning home, The flight control team has instructed everyone in the room to switch their patch around so that the Earth is closer and the moon is behind us. We are really looking forward to seeing the Artemis II crew. And the Capcom, Jenny Gibbons, did call that update up to the crew that the flight control team here has turned their patches around as was instructed by the crew during that last sim. And we are counting down the days until they get home. They are now 5 days, 1 hour, and 3 minutes mission elapsed time into the Artemis II mission. The Artemis astronauts are about to experience a solar eclipse from their capsule. And this is a solar eclipse that no one else on Earth will experience. This eclipse is about 54 minutes, and to the astronauts, it'll look a lot like a total solar eclipse on Earth, except the moon is going to be huge compared to the sun, unlike when you watch one on Earth and the moon and the sun appear about the same size in the sky. You're getting a live look from Orion as the crew observes a solar eclipse from the moon.
Science integrity in the blind. This is continues to be unreal. The sun has gone behind the moon, and the corona is still visible, and it's bright, and it creates a halo almost around the entire moon. But when you get to the Earth side, the Earth shine is already shown. I mean, almost seconds after the sun set behind the moon. You could see Earth shine. The Earth is so bright out there, and the moon is just hanging in front of us. This black orb out in front of us, in front of now, not the blackness, but the gray that blends and drifts into the blackness. We can see stars and the planets behind it. And Christina is in window 1, Reid is in window 2 with the long lens, and Jeremy is describing it in window 3, and it is quite an impressive sight. You can still see the horizon lit up brighter where the sun set on that side of the moon. It is bright, and Earthshine is very distinct, and it creates quite an impressive visual illusion. Wow, it's amazing. Let's see, not a huge change in here, just an update. The camera settings for Earthshine are challenging. This one's challenging to capture. What we're seeing, we're just not picking up on the cameras. And after all of the amazing sights that we saw earlier, we just went sci-fi. This has, it just looks unreal. You can see the surface of the moon between, I guess, the Earthshine. I guess Earthshine. You can actually see a majority of the moon. It is the strangest looking thing that you can see so much on the surface.
Integrity Science, we were loving your Science Sit Reps in the Blind, and it should come as no surprise that we have a number of follow-up questions. First, you mentioned Reid observing meteors. Can you speak to that? Were you referring to comets or impact flashes or something else?
Yeah, there was a little bit of giddiness. We have seen 3 impact flashes so far. I saw 2, and Jeremy has seen 1. Undoubtedly, Jeremy saw 2, so that's 4 total. Undoubtedly, quick impact flashes. It was not sun glint off of particulate from the thrusters or the purge tanks. It was definitely impact flashes on the moon. And Jeremy just saw another one. Go ahead with your next question.
Amazing news. I literally just looked over at the SIR and they were jumping up and down literally. If you could describe where on the moon you saw them, please.
So they've all been either on or a bit south of the equator and on the Earth side of the moon. Stand by. All right, so Jeremy has seen them kind of on and south of the equator, kind of spread across the moon, and mine were both south of the equator and just a little bit left of center of the moon.
Incredible news, Reid, and reminder, we have citizen scientists here on Earth looking for impact flashes, so hearing you saw them on the near side means that people saw them too.
One of the other things I wanted to describe, which was surprising to me, but the entire moon is lit up. It's glowing behind the entire moon. I thought it would look, dark against the black sky or deep space, but the sun is lighting up the entire limb of the moon. You can see the entire perimeter of it, and even now with the sun far behind the moon, you can still make out little bits of topography around the entire limb, just bumps as you go around it. And there's about the glow around the moon, once your eyes adjust, is easily 10 widths or diameters of the sun around the entire moon. Science and Houston integrity. I know this observation won't be of any scientific value, but I'm really glad we launched on April 1st because humans probably have not evolved to see what we're seeing. It is truly hard to describe. It is amazing. I'm not sure if we talked much about the star field, but we've got lots of stars. You've got the nice glow around the moon, but, right off the, well, we're upside down now, but from upside down 4 o'clock, right off the edge of the moon, looks like a planet, that line of planets. There's something a moon diameter to the left and something right off the limb of the moon to the right, and then something orange. It looks orange to the right of that, about half the moon diameter. So, but anyway, there are definitely stars. I think some of those planets that you said we might see, we're seeing. And so in unreal view, yeah, the moon in the foreground is one of the darkest things we see out the window, and now it's deep space behind it is kind of dark blue like it looks from Earth, but we can also still see stars. Well, it's quite a wicked view.
Victor,
I'm just doing the best job, and I'm not going to try to add on to what he's doing. It's indescribable. No matter how long we look at this, our brains are not processing this image in front of us. It is absolutely spectacular, surreal. There's no adjectives. I'm going to need to invent some new ones to describe what we are looking at out this window.
Artemis Mission Control in Houston, Texas. We are currently 5 days, 2 hours, and 44 minutes into the Artemis II mission, and we have about 11 minutes remaining in the eclipse at the latter half of the lunar flyby that the Artemis II crew is experiencing on board the Orion spacecraft.
Okay, we all think we're starting to see something. I believe the most popular term is baby hair. As the light grows in intensity and the horizon on this side becomes very distinct. You can still see Earth shine, even though the sun's brightness is definitely growing in intensity.
Love the description, Victor. I'm sure as the next couple minutes progress, more of those structures will continue to pop out.
If you've ever seen the spotlight off the top of the Luxor at night in Las Vegas, this looks like what that wants to be when it grows up.
Integrity Science, glad to hear you're following your training of tell it like you see it.
This is Artemis Mission Control. The eclipse period is coming to an end, and we did hear that call up that the crew now has to put on those eclipse glasses to be able to protect their eyes for this final portion of the eclipse. And these views coming to you from the solar array wing cameras on the Orion spacecraft.
And Houston, if you could give me about 20 new superlatives in the mission summary for tomorrow, that'll help my vocabulary out a bit. Thank you.
We will solicit input from the team.
And Integrity Science, this is basically wrapping up your fly-by-day observations. I can't say enough how much science we've already learned and how much inspiration you've provided to our entire team, the lunar science community, and the entire world with what you were able to bring today. You really brought the moon closer for us today, and we cannot say thank you enough. And Science signing off, and can't wait to talk to you tomorrow morning.
To your entire team, Kelsey, to the entire NASA science team, you all really turned to when we shifted launch dates to April 1st, and you got the most incredible package together for us to go do some great science and some great, truly human experience moments here. And we were well prepared, and we appreciate all of you. And this is what we do best when we all come together and work as a team. So y'all knocked it out of the park. Thank you for giving us this opportunity.
Beautiful words, Reid. Thanks so much.
The crew on board the Orion spacecraft recently completed their lunar observation period. It was an approximately 7-hour period of time in which they were focused on several different targets identified by the science team here on the ground that they studied and prepared for ahead of time. And then they also were referencing a lunar targeting package that was uplinked about a day ago with those final targets. Now they are completing some post-lunar flyby activities, so they're working to clean up their observations that they've made and also working to downlink some of the photos that they've taken throughout the day. The science team here on the ground will then work to get as much data as they can overnight, and then there will be a post-flyby conference tomorrow after the crew wakes up. And that's not a debrief, but a science data collection to capture their nuanced experience while they're still in the field and the experience is still fresh. And they are now about 8,100 miles away from the moon, and that distance will continue to increase as they are now in the return leg of their journey.
Artemis II crew, we have a very special guest who wanted to be the first person to greet you after your return from the far side of the moon. Reid, Victor, Christina, and Jeremy, it's my honor to introduce the President of the United States of America, President Donald J. Trump. Over to you, sir.
Well, thank you very much, Jared, and you are doing a fantastic job. And hello, very special hello to Artemis II. Today you've made history and made all America really proud, incredibly proud. We have a lot of things to be proud of lately, but this is there's nothing like what you're doing, circling around the moon for the first time in more than a half a century and breaking the all-time record for the farthest distance from planet Earth. Humans have really never seen anything quite like what you're doing in a manned spacecraft. It's really special. I want to personally salute and congratulate Commander Reid Wiseman, Pilot Victor Glover, Mission Specialist Christina Koch, and Jeremy Hansen.
President, this call is certainly special to all of us, and we really have a lot of faith in our administrator, Reid Wiseman, who is with you. We appreciate his leadership in NASA and in the international community. We are doing great things, and we are proud to be a part of.
Hey, Reid, we were wondering if this adjusted fan speed is something that you would like to keep going forward, or if it was just a specific change request for the events this evening.
Certainly for PAO events, this is an ideal fan speed. If you're willing to give us this fan speed for routine habitability, I think we would take it and try it for a while.
And Reid, we are able to support keeping the fan speed in this config. Happy to keep it here to collect data.
Okay, you got 4 happy astronauts up here. We'll take it. Obviously, when we go to exercise, we'll need to bump it up, but I think for quiet of living, this will be great.
We copy, and we love seeing those smiles.
This is Mission Control Houston coming to you live from the Artemis II Flight Control Room here at the Johnson Space Center. We are currently at a mission elapsed time of 5 days, 15 hours, 16 minutes and counting of the Artemis II mission. Currently, the flight control room here is the Orbit 3 flight controllers led by Flight Director Brandon Lloyd. That's the gentleman that you see in the screen wearing the blue jacket with the NASA logo. Next to him is another flight director on our team, Ron Spencer. Our capsule communicators, or Capcoms, today on this orbit are Amy Dill, who you see in the lighter colored top, and Sandra Moore. Capcom is tracking all of the activities that are there on the ground to help the crew when they wake up. The crew is scheduled to wake up in about an hour and 42 minutes counting down. Now, over in the front of the room, you see our, what we like to call our big board. And in the center of that board is what I like to call our world map. This is a great visualization that we've often seen with the International Space Station, where we can see the flight path of the vehicle as well as the different coverage points. So let's talk a little bit about this. So first things first, you see the white line going through the top part of the screen. That is our flight path, or the remainder of our flight path for the Artemis II mission. As you may know, yesterday we did, or Flight Day 6, which is currently still going on for an hour and 42 minutes, did fly around the moon and is now on that return trajectory to Earth to splash down off the coast of the Pacific. Now, as you may know, we did enter the lunar sphere of influence at the end of the day on Flight Day 5, and we are exiting the lunar sphere of influence on Flight Day 7. This means that as we exit the lunar sphere of influence, the Earth's gravitational pull gets stronger than that of the moon's. This helps our vehicle increase its velocity and get closer and closer to its targeted splashdown location. In addition to that, as you may know as well, we are operating on the Deep Space Network, or DSN, and that's what you see in the coverage map below. You can see the different satellite locations that we have, as well as their coverage points all around the world, so we can communicate with the crew aboard the Integrity spacecraft. Now, speaking of Integrity, it is actually 32,826 miles away from the moon and 238,078 miles away from Earth. As we target splashdown coming up in 3 days, 9 hours, 59 minutes counting down, you will see the increase of the distance from Earth, decrease from the distance from Earth and increase from the distance of the moon. We'll continue to monitor things on the ground here as the crew is going through their sleep period and provide periodic updates. For now, this is Mission Control Houston. This is Mission Control Houston in the Artemis Flight Control Room coming to you with a live update. We currently have a surveying activity that is taking place. You can see here the solar array wings aboard Orion are moving around right now to conduct this surveying activity. This is when teams on the ground are taking a look at the vehicle post-flyby and making sure that the vehicle is in good shape as we gear up for splashdown, which is coming up in 3 days, 9 hours, and 53 minutes and counting down. We also had a really interesting countdown or count up clock that happened or that got added to our big board here in the room in Mission Control. And that is a periloon clock counting up, 14 hours, 59 minutes counting up. And that is the time since our closest lunar approach. So for those of you who missed that closest lunar approach, that took place on flight day 6, and the closest approach was 4,067 miles. As we continue to watch the surveying activity take place from the solar arrays of the Integrity spacecraft, let's take a look at some of the photos we received from Flight Day 6 in the lunar flyby. Now, most of us have been used to seeing the iconic Apollo 8 Earthrise image. Now, you might think that this is the same image, but the reality is this is actually Earth set as captured by the Artemis II crew. This is when the crew began to go to the far side of the moon and the Earth was setting. So from behind the moon, the crew watched the Earth set, and you can see a soft blue arc fading behind a silent and cratered horizon. So part of the world was already in darkness during this time. That's why you can see that little crescent of the moon. And the rest of the world was still in motion with daylight. And the clouds are there, half a world away, and the oceans are visible from this distance as well. In the foreground, we can see the craters of the moon that have been unchanged for billions of years. This is an absolutely stunning image. And for those of you watching us right now, I hope you are evoked with the emotions that I am as I look at this. We also have another image here that we'd like to share with you all. And here's the other image that was taken. This was captured by the Artemis II crew during their lunar flyby. Once again, that lunar flyby took place on flight day 6, April 6th, 2026. And this view shows the moon fully eclipsing the Earth, the sun. Fully eclipsing the sun. From their vantage point, the moon appears large enough to completely block the sun, creating nearly 54 minutes of totality, far longer than what we can expect here on Earth. You also see the sun's corona that's forming a glowing halo around the dark lunar disk, revealing the outer atmosphere normally hidden by the sun's brightness. With the moon in shadow, even distant stars become available. Take that in for a second. You can see these points of light that are usually washed out, but in an image like this, we see them very clearly. Along the edge, you can also see a faint glow on the moon's surface, and that's sunlight being reflected from the Earth, softly illuminating the near side. I don't know about you, but this is a striking view and a rare opportunity to observe and document the corona as we come around the moon and this crew heads back home. We're going to leave you with this view and then transition to look back at Flight Day 6, the mission highlights from the lunar flyby. This is Mission Control Houston.
Mark, I think one of the most interesting things right now is the four of us have looked at this moon our entire lives, and the way we are responding to what we are seeing out the window is, it's just like we're a bunch of little kids up here. Just, we cannot get enough of this. It's amazing. Thank you for the privilege.
Thank you for sharing that special perspective you have with all of us back here.
This is Artemis Mission Control in Houston, Texas. We recently received confirmation that the Orion spacecraft and its crew have officially entered the lunar sphere of influence. That milestone taking place at a mission elapsed time of 4 days, 6 hours, 2 minutes, and 54 seconds into the Artemis II mission. By reaching this milestone, it means that the gravitational forces of the moon are now greater on the Orion spacecraft than that of Earth.
Hello, Artemis II. This is Apollo astronaut Jim Lovell. Welcome to my old neighborhood. When Frank Borman and Bill Andrews and I orbited the moon on Apollo 8, we got humanity's first up-close look at the moon and got a view of the home planet that inspired and united people around the world. I'm proud to pass that torch on to you as you swing around the moon and lay the groundwork for missions to Mars for the benefit of all. It's a historic day, and I know how busy you'll be, but don't forget to enjoy the view. So, Reid and Victor and Christina and Jeremy and all the great teams supporting you, good luck and Godspeed from all of us here on the good Earth.
Good morning, Houston. Integrity on one. That was an awesome message from Jim Lovell, and very cool to hear him welcome us to the neighborhood. It's going to be a great day. Thank you.
Good morning, Houston, from inside Integrity, 215,049 miles away from Earth and 12,712 miles from the moon. Let's actually savor the calm delay that we have. We're ready for the morning DPC.
Beautiful. We are savoring it down here. Good morning, Integrity, and good morning, Moon. Our room is buzzing with moon joy today, and I imagine yours is too.
We are ready to go. We are looking forward to working with and for the science team, and we are just excited to be so close to finally accomplishing what we've been training for so many years. And also, we want to say thank you for that really special message from Jim Lovell. We have a pretty neat emblem up here. We have a patch that was flown on the Apollo 8 mission. And that patch is here on the Artemis II mission as well. And that was sent to us by the Lovell family, by Jim Lovell's son. And so that was a really special way to start the day. And he said to welcome us to the neighborhood, and it's great to be in this neighborhood, and we look forward to sharing this neighborhood with you all.
We can't wait. We see the patch, and it's looking beautiful. Thank you.
When this showed up in our office from his family, we were completely honored, and the Earthrise, which this crew is responsible for taking that photo, has been instrumental both to our crew as our ethos and values, but also just personally to myself. I had the photo up in my room as a kid, and it was part of what inspired me to keep working hard to achieve things I dreamed about. Also, we took a deep dive into the cockpit recordings around the time that picture was taken, and it turns out there was a lot of hubbub, kind of I wouldn't say fighting over cameras, but definitely everyone wanted to capture the shot. So we're happy to carry on that legacy because we often are all glued to windows and looking for cameras too.
And I'll just close. I know it looks like a piece of paper in the camera there, but that is actually the original Apollo 8 patch printed on silk that they had done before they launched, and they flew that with them on their journey around the moon, and then the family handed it over to us, as I said, and it's just a real honor to have that on board with us. Let's go have a great day.
Right now, the Artemis II crew and Mission Control are preparing to support today's lunar flyby, the first time we've sent humans around the moon in over 50 years.
Integrity, you can use the OEs and your HHP camera for the milestone words at the Apollo 13 record distance.
You'll notice that we pause every time we hear communications to and from the crew. They are the stars for today. This afternoon, the crew will have their closest approach of the moon and will surpass the record. That record just mentioned of the furthest humans have ever flown, set by the Apollo 13 astronauts in 1970. As you can see, the crew members have dimmed the cabin lights inside Orion. Dimming the lights also helps prevent reflections from inside Orion onto the windows. Ahead of this lunar flyby, let's dive in and explain what you can expect over the next several hours. The crew has about 6 hours allotted to make observations about the moon. Throughout the flyby, their activities have been precisely timelined. There are five blocks of time during which the crew will be observing the moon from Orion's windows. At any time, 2 members will be at the windows working in a pair. One crew member will be taking photos from window 2 with a blue shroud over the window. This can help prevent that glare or reflection from inside Orion. They have an 80 to 400 millimeter zoom lens to use. The other astronaut will be in window 3 using their portable computing device, you'll hear that referred to as PCD, to make annotations. Both of these crew members will make audio recordings of what they are seeing, and they'll wear headsets connected to those PCDs. Those audio recordings will be sent to the science team at a later date. We will not hear them live. The 2 crew members at the windows will swap roles and positions halfway through their timelined block. The other 2 crew members who won't be at the windows at that time will be serving in the background as support. One will be conducting the science sit reps, or situation reports. This is what we will hear live from the crew. They'll be calling down a few times each hour to discuss what they are observing. Those situation reports include how the crew is positioned, any missed targets, or anything unexpected they saw, lunar target descriptions, any hardware issues, and of course, their emotions and reactions as they fly by the moon.
Good morning, crew. This is Science. We couldn't be more excited for a full day of lunar and planetary observations today, the first one in over 54 years. How do you hear me?
We hear you loud and clear, and Kelsey, you just got to know you're pulling us away from the moon right now, so let's go.
Message received. I will keep it tight here. I did just want to start with a thank you on behalf of the Lunar Science team and the entire lunar and planetary science community, of which you are absolutely a part, for what you've already done in this mission and what you're going to do today to inspire the next generation of scientists. I have to say moon joy is the new term that's already become our team's new motto, so thanks for that. A reminder also that your observations so far indicate it will likely take some time for your eyes to adjust. We especially heard that around your terminator observations and your color observations. So reminder to know that your eye adaptation is going to kind of come in throughout your shift, and let us know when you start to see that nuance. Last reminder is around Earthset and Earthrise. When you're viewing us back here at home, you'll be looking directly at Asia, Africa, and Oceania. So I'm sure people watching from those places here on Earth will want to give you all a wave as you take their picture.
And we're live in Artemis Mission Control in Houston, but we are not the only room monitoring today's flyby. As you heard Young mention, in this same building and just down the hall, a multidisciplinary lunar science team supports the Artemis II crew in real time, including experts in lunar geology, impact cratering, volcanism, polar science, imaging, and visualization. There are two integrated facilities, and the first is the SIR, which is what you have right here. That's the Science Evaluation Room. They are embedded within Mission Control to provide science input during live operations like what we see today. Additionally, and not pictured, we have the Science Mission Operations Room, a back room that processes data, evaluates imagery, and supports rapid analysis.
Integrity crew, we have Reid's family in the viewing gallery. You're welcome to say hello.
Well, whether you're being serious or you're kidding around, that is awesome to hear. Thanks, Jenny. And hello to Ellie and Katie. I don't know who else is there, but it's great to know that you're in Mission Control right now, following along. We are having a blast up here, and the view of the moon is absolutely amazing.
I'm seeing a lot of hearts come out of the viewing gallery and even more smiles. Thanks, Reid. Copy heart, copy bracelet. Integrity crew, on April 15th, 1970, during the Apollo 13 mission, 3 explorers set the record for the farthest distance humans have ever traveled from our home planet. At that time, over 55 years ago, Lovell, Swigert, and Hayes flew 248,655 statute miles away from Earth. Today, for all humanity, you're pushing beyond that frontier. Integrity, over to you.
Yeah, from the cabin of Integrity here, as we surpass the furthest distance humans have ever traveled from planet Earth, we do so in honoring the extraordinary efforts and feats of our predecessors in human space exploration. We will continue our journey even further into space before Mother Earth succeeds in pulling us back to everything that we hold dear. But we most importantly choose this moment to challenge this generation and the next to make sure this record is not long-lived. And we have a couple more things we'd like to take this moment for. Our science team helped us out with a couple of relatively fresh craters on the moon that have not been previously named, and our crew would like to propose a couple of potential names for those items or those areas. And we spent a bit of time this morning looking out the window, and we're able to see them now both with our naked eye and through the long lens, and so we feel this is a good time to send this down, and a special shout out to Kelsey for helping us with this. The first one we'd like to suggest is a named crater in honor of our great spacecraft Integrity. And so if you were to look at Oriental on the far side and then draw a line straight up to Ohm on the far side, Relatively in the middle is an unnamed crater, and we would like to suggest it be called Integrity in the future. And the second one, and especially meaningful for this crew, is a number of years ago we started this journey in our close-knit astronaut family, and we lost a loved one. And there's a feature in a really neat place on the moon, and it is on the near side, far side boundary. In fact, it's just on the near side of that boundary, and so at certain times of the moon's transit around Earth, we will be able to see this from Earth. And so we lost a loved one. Her name was Carol, the spouse of Reid, the mother of Katie and Ellie. And if you want to find this one, you look at Glushko, and it's just to the northwest of that, at the same latitude as Ohm, and it's a bright spot on the moon. And we would like to call it Carol, and you spell that C-A-R-R-O-L-L.
Integrity and Carol Crater, loud and clear. Thank you.
There was a moment of silence here in Mission Control Houston. And now the team and the Artemis II crew are ready to begin their lunar flyby.
We just realized that we have Earth out window 1 and Moon out window 2, and Earth out window 4 and Moon out window 3, and it gives you the best idea of scale we have had yet. The Moon is about 3 to 4 times the size of the Earth, and it is almost full, and the Earth is just a small crescent out there. It's magnificent. I got a picture of it with the wide lens. Such a majestic view out here.
Amaze, amaze, amaze. Thank you, Reid.
Now this is a view from their lunar targeting package at this time, helping them determine what they're seeing on the moon, as well as on the left, keep up with what their next target will be. As you can see, we have got a long list and an exciting day ahead of us.
Houston, another observation, whole moon. When you look at the moon, something I've never seen in photographs before, but is very apparent, all the really bright new craters. Some of them are super tiny. Most of them are pretty small. There's a couple that really stand out, obviously. And what it really looks like is like a lampshade with tiny pinprick holes and the light shining through. They are so bright compared to the rest of the moon.
School after just being in the 400 mil for the last half hour, looking up close. I got pictures of everything Ike was just describing on the Terminator. It really is a fascinating Terminator. And then Oriental just looks so dynamic right now. It's very three-dimensional out the docking hatch compared to what I was just looking at through the 400 mil.
We love it. We are getting a sneak preview from one of our SAW cameras at what you're looking at, and we see some of what you're describing. We cannot wait to see your photos. Thanks.
Yeah, Jenny, I wish you had some longer lenses on the solar array so you could see the whole moon, but man, it is, or the up-close moon, not the whole moon, but it is just fascinating here. It's so cool.
All right, MPO and INCO, take notes. We want a zoom lens on those saws next time. Thanks, Reid.
at one point towards the end of the images of my time in window 3, I just had an overwhelming sense of being moved by looking at the moon. It lasted just a second or two, and I actually couldn't even make it happen again. But something just drew me in suddenly to the lunar landscape, and it became real. And the truth is, the moon really is its own body in the universe. It's not just a poster in the sky that goes by. It is a real place. And when we have that perspective and we compare it to our home of the Earth, it just reminds us how much we have in common. Everything we need, the Earth provides, and that in and of itself is somewhat of a miracle.
Science, integrity. First, I wanted to start off with connecting with what Christina said, that it was very moving to look out the window. I had the unfortunate sequence to start looking out the window and then moved to the long lens, and it was hard to speak looking through the zoom because I went straight where Christina went, and I was walking around down there on the surface, climbing and off-roading on that amazing terrain. I also want to underscore something that she said. As we continue to explore, when we actually do go down there to the surface, I know for safety reasons that we would never send someone alone, but I just want to really emphasize how important the discussion time was. When we started to talk, we not only got better science discussion, we got better human connection, and so doing this as a pair, we just learn and grow together, and that's just super important, so thank you for adding that to this plan.
Integrity Houston, you are 6 minutes from your 40-minute lunar flyby LOS. From all of us, it's a privilege to witness you carrying the fire past our farthest reach. Thank you. Godspeed.
Thank you for that, Jenny. And thank you to all of you for allowing us the immense privilege to be on this journey together. It's quite amazing. And as we go on this journey, thinking about the NASA mission to explore the unknown in air and space, to innovate for the benefit of humanity, and to inspire the world through discovery. And as you've gone along on this journey with us, hopefully we're doing just those things. And as we get close to the nearest point to the moon and farthest point from Earth, as we continue to unlock the mysteries of the cosmos, I would like to remind you of one of the most important mysteries there on Earth, and that's love. Christ said in response to what was the greatest command, that it was to love God with all that you are. And he also, being a great teacher, said the second is equal to it, and that is to love your neighbor as yourself. And so, as we prepare to go out of radio communication, we're still to feel your love from Earth, and to all of you down there on Earth and around Earth, we love you from the moon.
Houston copies. We'll see you on the other side.
We are now less than 3 minutes away from loss of signal with the Orion astronauts. The Artemis II crew will be out of signal for about 40 minutes as they are on the other side of the moon, continuing their work, photographing the lunar surface, and they will reemerge, and we will also get this view on the other side. 30 seconds now until we expect loss of signal. And we have confirmation of loss of signal of the Orion spacecraft as it flies behind the moon. We expect to regain communications with them in another approximately 40 minutes. This was expected as their spacecraft is now out of direct line of sight with Earth and behind the moon. And this is a poignant moment as it's the first time in over 50 years that we have humans completely unreachable by anyone else on Earth. No matter how distant or secluded, we could reach anyone living on Earth, but while the crew flies behind the moon, it's simply impossible to make contact with them. And we just heard confirmation here in Mission Control Houston that we have reached the closest point of our destination to the moon at MET 5 days, 25 minutes, and 34 seconds, and we anticipate the spacecraft's altitude is approximately 4,067 statute miles above the moon. We're continuing to track what the crew is doing while around the other side of the moon. They are continuing to take pictures of the of the moon, the Earth now out of sight. What they are in right now is a crew choice event. The science team has encouraged them to find interesting features on the surface, to take photos of those, and describe why they were interesting. Something else that they'll be looking toward next, just momentarily, will be impact flashes. They've got a few minutes allotted to look at the darkest portions of the moon. They're interested in short-lived flashes on the lunar surface because these would be caused by impact bombardment. After their impact flash targeting, the team is interested in if the crew can see lofted lunar dust. This would only be visible just before Earthrise. Now 20 minutes until we expect to regain communications with integrity and the astronauts for Artemis II. We are getting our first views from Orion after the loss of signal. Orion has come back around the other side of the moon, and that little crescent that you see is Earth, over 252,000 miles away. With this transit complete, lunar flyby continues, but Orion has also technically begun its journey home. This view from inside the Orion spacecraft, all 4 astronauts now back on the other side of the moon and in contact with us on Earth. Their tasks for lunar flyby did not stop as they went behind the moon and out of contact with us. We anticipate during that time they were attempting to image some impact flashes, short-lived flashes on the lunar surface, which would be caused by impact bombardment and potentially even lofted lunar dust. Right now, of course, they are getting pictures of Earthrise.
Integrity, comm check.
Integrity, we have you loud and clear. How many?
Houston, we have you the same, and it is so great to hear from Earth again. To Asia, Africa, and Oceania, we are looking back at you. We hear you can look up and see the moon right now. We see you too. When we burned this burn towards the moon, I said that we do not leave Earth, but we choose it. And that is true. We will explore, we will build ships, we will visit again. We will construct science outposts, we will drive rovers, we will do radio astronomy, we will found companies, we will bolster industry, we will inspire. But ultimately, we will always choose Earth. We will always choose each other.
Integrity from Earth, our single system, fragile and interconnected. We copy. Those of us that can are looking back. Integrity, Houston. In mission control, all of your flight controllers and your flight director have flipped their Artemis II patches around. We are earthbound and ready to bring you home.
A very special moment just now in mission control ahead of the crew's flight to Kennedy Space Center, and during one of their last sims or simulations here, they visited the mission control team in Artemis Mission Control in Houston and brought us each a patch. Everyone in the flight control room has had these on their signifiers at their console. On one side of the patch that you've probably seen is the moon with the Earth behind it. Now that we've passed behind the moon and we are returning home, The flight control team has instructed everyone in the room to switch their patch around so that the Earth is closer and the moon is behind us. We are really looking forward to seeing the Artemis II crew. And the Capcom, Jenny Gibbons, did call that update up to the crew that the flight control team here has turned their patches around as was instructed by the crew during that last sim. And we are counting down the days until they get home. They are now 5 days, 1 hour, and 3 minutes mission elapsed time into the Artemis II mission. The Artemis astronauts are about to experience a solar eclipse from their capsule, and this is a solar eclipse that no one else on Earth will experience. This eclipse is about 54 minutes, and to the astronauts it'll look a lot like a total solar eclipse on Earth, except the moon is going to be huge compared to the sun, unlike when you watch one on Earth and the moon and the sun appear about the same size in the sky. You're getting a live look from Orion as the crew observes a solar eclipse from the moon.
Science, integrity, in the blind. This is continues to be unreal. The sun has gone behind the moon, and the corona is still visible, and it's bright, and it creates a halo almost around the entire moon. But when you get to the Earth side, the Earth shine is already shown. I mean, almost seconds after the sun set behind the moon, you could see Earth shine. The Earth is so bright out there, and the moon is just hanging in front of us. This black orb out in front of us, in front of now, not the blackness, but the gray that blends and drifts into the blackness. We can see stars and the planets behind it. And Christina is in window 1, Reid is in window 2 with the long lens, and Jeremy is describing it in window 3, and it is quite an impressive sight. You can still see the horizon lit up brighter where the sun set on that side of the moon. It is bright, and Earthshine is very distinct, and it creates quite an impressive visual illusion. Wow, it's amazing. Let's see, not a huge change in here, just an update. The camera settings for Earthshine are challenging. This one's challenging to capture. What we're seeing, we're just not picking up on the cameras. And after all of the amazing sights that we saw earlier, we just went sci-fi. This has, it just looks unreal. You can see the surface of the moon between, I guess, the Earthshine. I guess Earthshine. You can actually see a majority of the moon. It is the strangest looking thing that you can see so much on the surface.
Integrity Science, we were loving your Science Sit Reps in the Blind, and it should come as no surprise that we have a number of follow-up questions. First, you mentioned Reid observing meteors. Can you speak to that? Were you referring to comets or impact flashes or something else?
Yeah, there was a little bit of giddiness. We have seen 3 impact flashes so far. I saw 2, and Jeremy has seen 1. Undoubtedly, Jeremy saw 2, so that's 4 total. Undoubtedly, quick impact flashes. It was not sun glint off of particulate from the thrusters or the purge tanks. It was definitely impact flashes on the moon. And Jeremy just saw another one. Go ahead with your next question.
Amazing news. I literally just looked over at the SIR and they were jumping up and down literally. If you could describe where on the moon you saw them, please.
So they've all been either on or a bit south of the equator and on the Earth side of the moon. Stand by. All right, so Jeremy has seen them kind of on and south of the equator, kind of spread across the moon, and mine were both south of the equator and just a little bit left of center of the moon.
Incredible news, Reid, and reminder, we have citizen scientists here on Earth looking for impact flashes, so hearing you saw them on the near side means that people saw them too.
One of the other things I wanted to describe, which was surprising to me, but the entire moon is lit up. It's glowing behind the entire moon. I thought it would look, dark against the black sky or deep space, but the sun is lighting up the entire limb of the moon. You can see the entire perimeter of it, and even now with the sun far behind the moon, you can still make out little bits of topography around the entire limb, just bumps as you go around it. And there's about the glow around the moon, once your eyes adjust, is easily 10 widths or diameters of the sun around the entire moon.
Science and Houston integrity. I know this observation won't be of any scientific value, but I'm really glad we launched on April 1st because humans probably have not evolved to see what we're seeing. It is truly hard to describe. It is amazing. I'm not sure if we talked much about the star field, but we've got lots of stars. You've got the nice glow around the moon, but, right off the, well, we're upside down now, but from upside down 4 o'clock, right off the edge of the moon, looks like a planet, that line of planets. There's something a moon diameter to the left and something right off the limb of the moon to the right, and then something orange. It looks orange to the right of that, about half the moon diameter. So, but anyway, there are definitely stars. I think some of those planets that you said we might see, we're seeing. And so in unreal view, yeah, the moon in the foreground is one of the darkest things we see out the window. And now it's deep space behind it is kind of dark blue like it looks from Earth, but we can also still see stars. It's quite a wicked view.
Victor,
Like he's doing the best job, and I'm not going to try to add on to what he's doing. It's indescribable. No matter how long we look at this, our brains are not processing this image in front of us. It is absolutely spectacular, surreal. There's no adjectives. I'm going to need to invent some new ones to describe what we are looking at out this window.
Artemis Mission Control in Houston, Texas. We are currently 5 days, 2 hours, and 44 minutes into the Artemis II mission, and we have about 11 minutes remaining in the eclipse at the latter half of the lunar flyby that the Artemis II crew is experiencing on board the Orion spacecraft.
Okay, we all think we're starting to see something. I believe the most popular term is baby hair. As the light grows in intensity and the horizon on this side becomes very distinct. You can still see Earth shine, even though the sun's brightness is definitely growing in intensity.
Love the description, Victor. I'm sure as the next couple minutes progress, more of those structures will continue to pop out.
If you've ever seen the spotlight off the top of the Luxor at night in Las Vegas, this looks like what that wants to be when it grows up.
Integrity science. Glad to hear you're following your training of tell it like you see it.
This is Artemis Mission Control. The eclipse period is coming to an end, and we did hear that call up that the crew now has to put on those eclipse glasses to be able to protect their eyes for this final portion of the eclipse. And these views coming to you from the solar array wing cameras on the Orion spacecraft.
Houston, if you could give me about 20 new superlatives in the mission summary for tomorrow, that'll help my vocabulary out a bit. Thank you.
We will solicit input from the team.
And Integrity Science, this is basically wrapping up your fly-by-day observations. I can't say enough how much science we've already learned and how much inspiration you've provided to our entire team, the lunar science community, and the entire world with what you were able to bring today. You really brought the moon closer for us today, and we cannot say thank you enough. And Science signing off, and can't wait to talk to you tomorrow morning.
To your entire team, Kelsey, to the entire NASA science team, you all really turned to when we shifted launch dates to April 1st, and you got the most incredible package together for us to go do some great science and some great, truly human experience moments here. And we were well prepared, and we appreciate all of you. And this is what we do best when we all come together and work as a team. So you all knocked it out of the park. Thank you for giving us this opportunity.
Beautiful words, Reid. Thanks so much.
The crew on board the Orion spacecraft recently completed their lunar observation period. It was an approximately 7-hour period of time in which they were focused on several different targets identified by the science team here on the ground that they studied and prepared for ahead of time. And then they also were referencing a lunar targeting package that was uplinked about a day ago with those final targets. Now they are completing some post-lunar flyby activities, so they're working to clean up their observations that they've made and also working to downlink some of the photos that they've taken throughout the day. The science team here on the ground will then work to get as much data as they can overnight, and then there will be a post-flyby conference tomorrow after the crew wakes up. And that's not a debrief, but a science data collection to capture their nuanced experience while they're still in the field and the experience is still fresh. And they are now about 8,100 miles away from the moon, and that distance will continue to increase as they are now in the return leg of their journey.
Artemis II crew, we have a very special guest who wanted to be the first person to greet you after your return from the far side of the moon. Reid, Victor, Christina, and Jeremy, it's my honor to introduce the President of the United States of America, President Donald J. Trump. Over to you, sir.
Well, thank you very much, Jared, and you are doing a fantastic job. And hello, very special hello to Artemis II. Today you've made history and made all America really proud, incredibly proud. We have a lot of things to be proud of lately, but this is there's nothing like what you're doing, circling around the moon for the first time in more than a half a century and breaking the all-time record for the farthest distance from planet Earth. Humans have really never seen anything quite like what you're doing in a manned spacecraft. It's really special. I want to personally salute and congratulate Commander Reid Wiseman, Pilot Victor Glover, Mission Specialist Christina Koch, and Jeremy Hansen.
President, this call is certainly special to all of us, and we really have a lot of faith in our administrator, Reid Wiseman, who is with you. We appreciate his leadership in NASA and in the international community. We are doing great things, and we are proud to be a part of.
Hey, Reid, we were wondering if this adjusted fan speed is something that you would like to keep going forward, or if it was just a specific change request for the events this evening.
Certainly for PAO events, this is an ideal fan speed. If you're willing to give us this fan speed for routine habitability, I think we would take it and try it for a while.
And Reid, we are able to support keeping the fan speed in this config. Happy to keep it here to collect data.
Okay, you got 4 happy astronauts up here. We'll take it. Obviously, when we go to exercise, we'll need to bump it up, but I think for quiescent living, this will be great.
We copy, and we love seeing those smiles.
Welcome back to the Artemis Flight Control Room here at the Johnson Space Center. We are coming to you live with our 24/7 continuous coverage of the Artemis II mission. With me, I have Chris Bellant. He is the Flight Activities Officer here in the room on my shift with me. Chris, welcome.
Thank you. Thanks for having me.
We're excited to have you, and you are the one that keeps us organized over the course of the mission. So tell us a little bit about your role in Artemis II.
Yes, I'm one of a team of 10 planners. We do the initial planning, but we lead the initial planning before the mission to lay out all the activities in the most efficient way possible so the crew can get the most done. And then every night we go through a small replan shift to adjust the timeline for the next day for any updates we have from the previous day, things we want to add or time adjustments that we learned from the previous day.
And we learn these time adjustments based on our trajectory. If there's small corrections we need to do with trajectory, that may impact the timeline. So overnight, or what we do during Orbit 3 is just replan, and then sometimes replan again, and sometimes replan a third time. Is that right?
Yep, that's correct. We keep replanning until we get it right. We load a new trajectory every night, new comm data, and lots of other small files that adjust a lot of our condition data and our activities a little bit. And then we go over it a couple times with a fine-tooth comb to make sure everything's perfect. And then we put it on board for the crew just before they wake up.
So you have to be quite organized to do something like this. We joked before we went on the air that, you know, you and I were both probably very type A people. So what kind of skills and attention to detail do you need to do a role like Flight Activities Officer?
Lots of checklists to help you remember what to do, thinking through activities, what could happen, all the different outcomes, just trying to remember all the constraints for the different activities and what conflicts with what. And a lot of conversations with the team, pulling in 3 or 4 people when I think something doesn't look right, just having a discussion about it until we figure out all the details and how to plan it out the best way for the crew possible.
Well, thank you so much for all that you've been doing over the course of the mission, but you had told me when we first started that 9 years you've been supporting the Artemis program. So tell us about how this evolution that brings us to Artemis II.
Yes, I started about 9 years ago as one of the lead planners for Artemis I, and I got to start off with a very rough timeline and go through the whole development process for that program and fly the mission around the moon. I was actually on the console for the second slingshot around the moon for Artemis I. This mission, I was on the shift just before we went by the moon, doing the replanning shift right before that. So it's been a really exciting time, and I find on console that I have a smile on my face the whole time.
So no matter how stressful, how many things you have to replan, and how many times you have to replan, it still brings you joy.
Absolutely. I just keep remembering that I'm part of a team flying a spacecraft around the moon, and I can't get enough of it.
I have to ask you, you are one of millions of people, along with me, that sent your name around the moon. Is that right?
Yep. I submitted my name a couple months ago, and I got a boarding pass along with more than 5 million others, and I brought it in today so I get to get a picture with the crew when they wake up.
That's fantastic. And how does it feel knowing the impact, the role you've had in this mission? How are you feeling?
Oh, incredible. It's wonderful to think about being a part of something so big and that the world's so excited about.
You and me both. Well, Chris, thank you so much for joining us. You have to get back because the crew is waking up in 42 minutes and counting. So for now, this is Mission Control Houston. We'll continue to provide you with live coverage of the Artemis II mission. This is Artemis Mission Control coming to you from the Johnson Space Center in Houston, Texas. You're at a mission elapsed time of 5 days, 16 hours, 19 minutes, and counting. Currently, the Orion spacecraft, named Integrity, is 34,000 miles and counting away from the moon, and 236,000 miles and counting away from Earth. While the crew is currently in their sleep period, they should be up in the next 40 minutes or so. So for now, let's take a look at some of the images that continue to come down from Flight Day 6's lunar flyby. So here we have a stunning image that's come down of the lunar South Pole. This is captured by the Artemis II crew, and you can see the heavily cratered terrain rather. It's the edge of the South Pole, or eastern edge of the South Pole Aitken Basin. And you can kind of see the shadowed terminator. And the terminator, you probably heard that while the crew was making their observations, but that's basically the boundary between lunar day and lunar night. And the South Pole Aitken Basin is the largest and oldest basin on the moon. So you are getting a glimpse into ancient geologic history built up over billions of years. Now, these are some of the observations and visuals that we have as we plan for future Artemis missions to take us to the lunar South Pole. And as you can see from this stunning image of the moon, the geology here and the terrain here is quite treacherous. And in order for us to land in a rocky place that's heavily cratered, we need to ensure precision landing. We need to ensure that humans can work. We need to look at lighting conditions. So all of these scientific observations and even the preceding robotic missions that are headed to the South Pole will help us better understand this area before humans land. We also have another image here, another angle of the eclipse that we brought to you earlier. So here's a close-up view from Orion during the flyby on April 6th, which captured the total solar eclipse. And you can see just part of the moon visible in the frame. And there's still a soft halo of light around the moon's edge. Over the course of the eclipse, the crew did experience 54 minutes of totality. So that's far longer than a total eclipses that we see here from Earth. And the cropped perspective emphasizes the scale of the alignment and reveals a subtle structure of the corona during the rare extended eclipse that was observed by the crew. And that bright silver glint that you're seeing on sort of the left edge of your screen is the planet Venus. And the sort of round dark gray feature that is visible along the moon's horizon at sort of what we call the 9 and 10 o'clock position is Mare Crisium. That's a feature that we can often see from Earth. It's a great image. So you can imagine when you are looking at an eclipse, there's often a need for safety. So we did get another image down. This one is one of my favorite images from the eclipse, but the caption that we put together here from the team on the ground is safety first, and you're seeing that firsthand. So you can see beginning from left to right, you see mission specialist Christina Koch, mission specialist and Canadian Space Agency astronaut Jeremy Hansen, our commander Reid Wiseman, and then mission pilot Victor Glover. So these are the glasses or the eclipse glasses that we had during our 2023 and 2024 eclipses. The 2024 eclipse was our total solar eclipse that we experienced here in North America. But it's protecting your eyes are obviously key during these moments of the eclipse. So this was actually the first time that eclipse glasses were used at the moon to safely view an eclipse. Now we have hundreds of images that continue to come down, and our team is working diligently. Big shout out to our imagery team, but they are working diligently to get these images up and ready for you. So one place where you can find these images is images.nasa.gov. If you go there, you can find the entire library. In addition to the photos that I just showed you and have showed you over the course of this morning, you will find a ton more images there. You can also follow us on our NASA social media channels at NASA Artemis, at NASA Solar System, at NASA Johnson. All of the accounts, I just named a few, but wherever you track your social media, you should be able to see these images. So we'll continue to follow along here from Mission Control, but hope you enjoyed those pictures. We'll continue to update you here from the flight control room. This is Mission Control Houston here in the Artemis Flight Control Room at the Johnson Space Center. We are coming to you live with our 24/7 continuous coverage of the Artemis II mission. While the crew is currently asleep aboard the spacecraft, the Orion spacecraft named Integrity, they are scheduled to wake up in about 21 minutes and counting down. Currently, the Orion spacecraft is 35,000 miles and counting away from Earth, from the moon rather, and 236,467 miles and counting down from Earth. Now, as you might be aware, we are here in Mission Control, which you see on the left side of your screen. And on the right side of your screen, you see our SIR, or our Science Evaluation Room, very hard at work. It's slightly dark in there, but just like the crew had to dim their cabin yesterday to take imagery of the moon during the flyby, the team here on the ground has now received a slew of those images and is reviewing them in the Science Evaluation Room. As I mentioned previously, if you would like to see any of the images that we have received, you can go to images.nasa.gov to check those out. Now, ahead of crew wake or post-crew wake at a mission elapsed time of 5 days, 20 hours, and 25 minutes, there is the post-lunar flyby crew conference. This is a debrief and a discussion of the lunar flyby observations. So the team here on the ground is preparing for that, and you can see them hard at work. Lots of chatter, lots of planning, lots of coordination. In addition to the Science Evaluation Room, there are 2 additional back rooms that are helping to support the science officer here in Mission Control. So as we continue to follow along, just about 20 minutes from now, the crew will be waking up. We will be standing by for that. For now, this is Mission Control Houston. Good morning from Mission Control Houston here at the Johnson Space Center in the Artemis Flight Control Room. We are coming to you live with our 24/7 coverage of the Artemis II mission. At a mission elapsed time of 5 days, 16 hours, and 50 minutes and counting, the crew is scheduled to wake up in just under 10 minutes from now, which will be 5 days and 17 hours. Currently, the Orion spacecraft named Integrity is 35,000 miles and counting away from the moon, and about 236,000 miles and counting away from Earth. While the crew did complete lunar flyby, Flight Day 6, we are gearing up for Flight Day 7, which means splashdown is near. Splashdown is coming up in 3 days, 8 hours, and 27 minutes and counting down. Orion will exit the lunar sphere of influence a little bit later. And that means the Earth's gravitational pull is stronger than that of the moon. We will stand by for crew wake. So for now, this is Mission Control Houston. This is Mission Control Houston coming to you live from the Artemis Flight Control Room here at the Johnson Space Center. At a mission elapsed time of 5 days, 17 hours, the crew was woken up aboard their Integrity spacecraft, marking the start of Flight Day 7 activities. Today's wake-up music was Tokyo Drifting by Denzel Curry and Glass Animals. Activities today are focused on a ship-to-ship call when Expedition 74 crew aboard the International Space Station speaks to the Artemis II crew aboard the Orion spacecraft. The team will also be assessing and conducting a potential return trajectory correction burn 1 or RTC burn 1, and the beginning of their day actually is focused on a post-flyby science conference. The crew are currently coasting back on their way from the moon as we speak. Meanwhile, the Artemis Mission Control team here in Houston monitored all systems overnight, and the vehicle continues to perform well. The crew will exit the lunar sphere of influence in their post-sleep period at a mission elapsed time of 5 days, 18 hours, 48 minutes. This is when the gravitational pull of the Earth will become stronger than that of the moon. For now, this is Mission Control Houston. This is Artemis Mission Control here at the Johnson Space Center in Houston, Texas. At a mission elapsed time of 5 days, 17 hours, and 43 minutes, we are coming to you live with continuous coverage of the Artemis II mission. The crew was woken up at a mission elapsed time of 5 days, 17 hours. This marks the commencement or the beginning of flight day 7 of the mission. Currently, the Orion spacecraft, named Integrity, is 37,000 miles and counting away from the moon, and 235,000 miles and counting away from Earth. The crew and Integrity spacecraft will exit the lunar sphere of influence during their post-sleep period today at a mission elapsed time of 5 days, 18 hours, and 48 minutes. This means that the Earth's gravitational pull becomes stronger than that of the moon. The Orbit 1 team of flight controllers just came on console and completed their handover from Orbit 3. So we'll continue to follow all operations here in Mission Control. I'm Nilofer Ramji, handing things over now to our Orbit 1 commentator, Leah Cheshire Mustachio. She'll take you through the next few hours as we kick off Flight Day 7 of the Artemis II mission. For now, this is Mission Control Houston.
Good morning and welcome to Artemis Mission Control here at Johnson Space Center in Houston, Texas. I'm Leah Cheshire Mustachio. The Orbit 1 team has just taken over from the Orbit 2 team and is led by Jeff Radigan, NASA Flight Director. The Capcom, or capsule communicator for today, is Stan Love. He's a NASA astronaut and is the only voice you'll hear communicating with the crew. Of course, there is an exception for that today, during which the science team will be conducting their post-lunar flyby conference. If you tuned in yesterday, you got a treat, and we got to see amazing views of the moon as well as hear the crew's description of them. Now, while the crew was taking those photos, they were also recording private voice notes that they sent down to the science team overnight. This morning, the science team is going to talk about the observations that the crew made while those are all still fresh. We've also got some other exciting activities coming up today, including a ship-to-ship call. The Orion spacecraft and the 4 Artemis II astronauts, Reid Wiseman, Victor Glover, Christina, Koch, and Jeremy Hansen, will be calling the International Space Station. We have 7 crew members living and working aboard the International Space Station, and we've just surpassed 25 years of continuous human presence living and working in space. This will be the first time that these 2 spacecraft have ever talked to each other. We are on flight day 7 with a mission elapsed time of 5 days, 17 hours, and 53 minutes. We're gearing up for a great shift today, and thanks for tuning in. This morning, the Artemis II astronauts woke up just after 10 a.m. Central Time, and the song you heard playing was Tokyo Drifting by Glass Animals and Denzel Curry. They are currently in their post-sleep period. This is an opportunity for them to get the cabin ready for the day by stowing any window shades that they put on Orion's windows over the night, or stow their sleeping bags that they hang up in the spacecraft to sleep in. They also get a chance to brush their teeth, complete any hygiene activities, and eat breakfast. On the menu today is Mexican scrambled eggs, granola and blueberries, a cinnamon bun, cashews, couscous with nuts, tortillas, and some coffee. You're looking at a live view from Orion from one of the solar array wing cameras. There are 4 solar arrays with a camera mounted on each of them. Of course, we got great views during the flyby yesterday, but these are also used to check out the spacecraft. Orion is currently 38,210 miles away from the moon. At closest approach yesterday, they were about 4,067 miles from our lunar neighbor. They are 234,839 miles away from Earth. That number will continue to shrink as we prepare for splashdown, now about 3 days, 7 hours, and 20 minutes away. Orion will exit the lunar sphere of influence, or the time in which the moon's pull on the spacecraft is greater than the Earth's, at 12:21 p.m. Central Time today. Yesterday was an extremely busy day for the Artemis II crew, spending 6 hours, or approximately 6 hours, taking photos, making recordings, making annotations of everything they saw on the lunar surface, and sharing all of that with us on Earth. We've been able to share some of those images so far, and if you would like to find them, you can visit NASA or NASA Artemis on social media. And because of the crew's busy day yesterday, they have a little bit of time off this evening. They also have the opportunity to speak with their families today. This afternoon, we're also expecting to see the RTC-1 burn. This is return trajectory correction burn. If you recall, on the way to the moon, we had outbound trajectory correction burns. We canceled 2 of those, they were deemed unnecessary ahead of our lunar flyby, and we executed 1 of them to just further refine the spacecraft's trajectory. We do have one of those scheduled for today. This, again, is a return trajectory correction burn. This is a smaller burn using the RCS, or Reaction Control System, thrusters on the service module. If you look closely in this image, you can see a large bell shape. That's the OMS engine, the Orion, or the Orbital Maneuvering Service engine. That's the engine that was used to perform the translunar injection burn, and that's the burn that sent us beyond the moon, but also what committed us to coming back to Earth. Just ahead of that burn, Christina Koch said, "With this burn, we don't leave the Earth, we choose it." These return trajectory correction burns help further refine their path back to Earth. This is Artemis Mission Control here, Tuesday, April 7th, on Flight Day 7 of the Artemis II mission. Our crew members woke up at 10:35 a.m. Central Time. They are in their post-sleep period, so we won't hear from them probably for a little while. We will have the daily planning conference with them in about an hour and a half. Just before that daily planning conference, Flight Director Jeff Radigan will gather inputs from the teams here on the ground in Mission Control Houston. This could be anything about the astronaut schedule for the day, vehicle system information, as well as answer questions from the crew. This is Artemis Mission Control with a mission elapsed time of 5 days, 18 hours, and 12 minutes. The crew are on their way home, having flown by the moon yesterday. This is the first flight of humans aboard the Orion spacecraft, and in the official flight kit aboard Orion are some special flags. One of those is from Apollo 18. This is the American flag that would have been planted on the moon during that mission, should it have occurred. It was on display in the NASA headquarters building in Washington, D.C., making its way around the moon over 50 years since its originally intended flight. The other American flag aboard Orion is from a little more recent history. It was flown on STS-1, the first space shuttle flight, STS-135, the last space shuttle flight, and NASA SpaceX DM-2, or Demonstration Mission 2, which was the return of launching American astronauts from American soil on American rockets. This is a picture of that more recent flag that is stowed aboard Orion for this mission. A prominent symbol of the Artemis II mission has been the crew's patch. They explained the patch's symbolism when they revealed it to the world last year. They said the Artemis II test flight begins when a mighty team launches the first crew of the Artemis generation. This patch designates the mission as all, signifying not only the second major flight of the Artemis campaign, but also an endeavor of discovery that seeks to explore for all and by all. Framed in Apollo 8's famous Earthrise photo, the scene of the Earth and the moon represents the dual nature of human spaceflight, both equally compelling. The moon represents our exploration destination, focused on discovery of the unknown. The Earth represents home, focused on the perspective we gain when we look back at our shared planet and learn what it is to be uniquely human. The orbit around Earth highlights the ongoing exploration missions that have enabled Artemis to set sights on a long-term presence on the moon and soon Mars. Those words directly from our crew members, Reid Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, again, having flown by the moon yesterday and taking a picture very similar to this. As you just saw, the Earth peeking behind the moon in that patch, this is a photo from yesterday's lunar flyby as the Artemis II crew came close to passing behind the moon and experiencing that planned loss of signal. They captured this image of our crescent Earth setting on the moon's limb. In this photo, you can see half of Earth is experiencing nighttime, or a little more than in this image. And that dark line across the Earth is the terminator. We heard that mentioned several times yesterday on the moon. That dark terminator line is the difference between day and night. Of course, in the foreground, our very beautiful moon. Yesterday, at closest approach, the astronauts were about 4,067 miles away from the lunar surface. We continue to get beautiful imagery from the crew, and you can follow NASA on all social media accounts at NASA and at NASA Artemis to make sure that you see it too. If you're a new spaceflight fan, we also have a lot of other ways you can get connected. If you like podcasts, NASA has a handful of official podcasts, including the one produced here at Johnson Space Center called Houston, We Have a Podcast. Houston, We Have a Podcast now has over 400 episodes, including interviews with astronauts, scientists, engineers, and more. Most recently, we shared an interview with the Artemis II crew. You can find that and more at nasa.gov/podcasts. If you're just tuning in, we are live from Artemis Mission Control in Houston, Texas. We are in the middle of the astronauts' post-sleep period, having woken up at 10:35 a.m. Central Time. They have another hour or so in this post-sleep period, so we may not hear from them very much, but we will during the daily planning conference when they will speak with the team here on the ground, specifically Capcom Stan Love and Flight Director Jeff Radigan. This is Artemis Mission Control at Johnson Space Center in Houston, Texas. You're looking at a live view from Orion, a camera mounted on one of its solar arrays. The spacecraft now 234,311 miles from Earth, and that distance continuing to shrink. You can keep up with Orion's location and positioning at nasa.gov/trackartemis. The crew is still in their post-sleep period, and we expect to hear from them for the daily planning conference coming up in about an hour and 10 minutes. Orion will also exit lunar sphere of influence today. That's coming up in just 21 minutes at 12:21 p.m. Central Time. The lunar sphere of influence is when the moon's gravity has a greater pull on the spacecraft than that of Earth's. This is Artemis Mission Control in Houston, Texas, with a mission elapsed time of 5 days, 18 hours, and 35 minutes into the Artemis II mission. You're looking at a live view outside the Orion spacecraft from a camera on one of its solar array wings. Orion completed its flyby of the moon yesterday, its closest approach at about 4,067 miles. They are now 39,532 miles away from the moon. The crew is still in their post-sleep period, having woken up at about 10:35 a.m. Central Time today. We are about 10 minutes away from the crew exiting the lunar sphere of influence, when the moon's pull is stronger on the spacecraft than is Earth's. The crew has an exciting morning and more of a relaxing afternoon after such a busy day yesterday. First up, we will hear from the crew during the daily planning conference. That daily planning conference coming up in about an hour. Afterward, we will have a ship-to-ship call, during which Orion and the crew aboard the International Space Station will get to talk with each other. After the ship-to-ship call, the science team will speak with the astronauts aboard Orion. They want to recap everything that the crew saw yesterday. The crew will also have an opportunity to speak with their family members today, and we are targeting the RTC-1 burn. That's Return Trajectory Correction 1. These are small maneuvers using the reaction control system thrusters on the spacecraft to help refine the trajectory as Orion heads home to Earth. This is Artemis Mission Control. Again, we do not hear calls to the crew at this time as they are in their post-sleep period and getting ready for the day. However, we do anticipate that Orion has departed the lunar sphere of influence. That's when the gravitational pull of the moon is stronger than the gravitational pull of Earth. We're now 5 days, 18 hours, and 52 minutes into the flight of Artemis II, the first mission of humans aboard the Orion spacecraft. We are coming up on 5 days and 19 hours into the flight of Artemis II. This is a live view from the Orion spacecraft, now making its journey back home to Earth following a lunar flyby yesterday. This mission is built by people and companies in all 50 states and with international partners. And with Artemis II flying, it's a testament to everyone's hard work and dedication. Let's learn a little bit about them.
What we're doing here is a collaborative effort of hundreds of thousands of people.
This is about the parts, the hardware, the software, the services, all coming together to make that mission possible.
My dream for this space program is that we would not just push the boundaries, but that we push them together.
And liftoff of Artemis I. We rise together, back to the moon and beyond.
It takes a team to do great things. And Artemis has an incredible team.
We have international partners. We have commercial partners and industry partners.
It takes unity to accomplish great things, and that's what this mission's all about.
We're not sending our money to the moon and lighting it on fire. We're putting that money right back into the economy in ways that benefit everybody. So every dollar that comes out of the Treasury that goes to support this mission goes back into the Treasury 3 times. What is very important to me is that we do it the right way, and that we do it with our values, that our industries grow, that our communities grow, that our families are healthy and safe and have amazing things to work on. Then we're going to build machines to go even further onto Mars.
That is our generation, the Artemis generation, that defines the starting point of our exploration future.
I just want to say thank you to all of the hands that have touched a part of this program and the hearts that have moved everyone to this goal, because we're going to the moon and we're going beyond.
One team.
One team.
One team.
One dream.
It does take a team, and we are live here in the Artemis Flight Control Room at Johnson Space Center in Houston, Texas, where the Orbit 1 team continues monitoring the flight of Orion, the first flight of humans on this spacecraft. You've heard us mention a lot about the flight director or the capsule communicator, the person speaking with the crew, but there are a number of positions in this room that are monitoring all of the systems and the daily plans aboard Orion, making this mission happen. That includes INCO, the Integrated Communications Officer, CDH, Command and Data Handling, PROP, the Propulsion Officer, FIDO, the Flight Dynamics Officer, Booster and Control, who monitor the flight of the Space Launch System, IVA, or Intravehicular Activity, ECOM, Emergency Environmental and Consumables Officer, GNC, the Guidance and Navigation Control Officer, FAO, the Flight Activities Officer, MPO, Mechanical and Power Officer, CDH, Command and Data Handling Officer, GC, Ground Control, Surgeon, BME, the Biomedical Engineer, and Science. We might get to share what's happening during the mission, but these are the team members, along with their backrooms, and everyone who has contributed to the flight of Artemis II that are making this mission happen. We are 5 days, 19 hours, and 5 minutes into the flight of Artemis II, the first flight of humans aboard the Orion spacecraft. And you're looking at a live view from Orion, looking back at us here on Earth, the destination of the crew, headed for a splashdown in approximately 3 days, 6 hours, and 12 minutes. The translunar injection burn that occurred on Flight Day 2 is what committed the spacecraft to its splashdown. Yes, that sent us around the moon for yesterday's fantastic lunar flyby, but it's also the burn that helped us slingshot around the moon and target that splashdown in the Pacific Ocean. That was a 5-minute and 50-second burn using the OMS engine, the Orbital Maneuvering Service engine. It's a great picture of the OMS right there on the left side of your screen. The crew has also exited the lunar sphere of influence, meaning that the pull of the moon's gravity is less intense now as the pull of Earth's. The crew aboard Orion are currently in their post-sleep period, having woken up about 10:35 a.m. Central Time. This post-sleep period is the time frame that they can get ready for the day, just like you would at home before leaving for work. They are putting up their sleeping bags, doing any hygiene, and eating breakfast, and we will talk to them in about 30 minutes for the daily planning conference. Flight Director Jeff Radigan here in Mission Control Houston has been gathering topics from the team about the spacecraft systems or the plans for the day that he will relay up to the crew. You're looking at a live view from the Orion spacecraft at our home, planet Earth, now 233,138 miles away and continuing to grow closer. The crew inside are getting closer to the end of their post-sleep period, and we expect to hear from them for the daily planning conference. That'll be in about 20 minutes. This is Artemis Mission Control in Houston, Texas. We are monitoring the flight of the Artemis II crew aboard the Orion spacecraft. This live view looking back at all of us on Earth, the destination of the spacecraft and the crew. We are now 233,031 miles away from Earth. Orion reached its farthest distance from Earth yesterday, approximately 252,756 statute miles away from our home planet. That surpassed the previously set record from Apollo 13. Until yesterday, the Apollo 13 crew were the humans who had traveled farthest from Earth. When that record was passed, Jeremy Hansen reported that he and the crew hoped that their new record would soon be broken. The crew is wrapping up their post-sleep period, having woken up at 10:35 a.m. Central Time today. Their wake-up music was Tokyo Drifting by Glass Animals featuring Denzel Curry. Pretty good choice for their drift back to Earth. It's going to be a busy day for the crew. Going to be a busy day for the crew aboard the Orion spacecraft, as we are looking forward to a ship-to-ship call when Orion and the International Space Station crew members get to speak to each other, both in flight. While Orion was over 250,000 miles away from Earth, the International Space Station orbits Earth 16 and sees 16 sunrises and sunsets a day, 250 miles above our planet. And if you've been enjoying hearing from the astronauts and seeing photos taken from this mission, you would also love to keep up with the International Space Station as the astronauts do amazing Earth photography there from the cupola, the window to the world looking down on Earth. You can follow the International Space Station on all social media platforms as well as NASA. Less than 10 minutes now until the daily planning conference for the crew, when the flight control team will call up.
Integrity, we're getting ready for DPC. Would you like the D5 streamed on the 4K encoder for DPC? We would enjoy that.
Integrity, we'd love that.
It worked. Dan, good morning.
Good morning to you.
Our first morning messages from the crew aboard Orion. Again, they woke up about 10:35 a.m. Central Time today and are heading into that DPC, the Daily Planning Conference. You heard the crew call down that they were going to set up the D5 on the 4K encoder, meaning we anticipate getting views of the crew inside Orion soon.
Integrity, we are on board with the D5.
We're getting views of the crew. The first coming down on flight day 7. On the left, NASA astronaut Victor Glover, the pilot for Artemis II, and on the right, NASA astronaut Reid Wiseman, the Artemis II commander. If you watched Lunar Flyby yesterday, you can tell that the cabin looks quite different. All the lights are back on. During the Lunar Flyby, the crew turned off all of the lights inside the spacecraft to allow them to better take photos outside of the windows. That helped prevent any reflections from inside the spacecraft bouncing up onto the windows, and if you haven't seen some of those photos already, you should absolutely check them out. You can find them on nasa.gov as well as NASA social media. That's at NASA and at NASA Artemis. It is going to be a little bit of a quieter day for the crew, at least in their afternoon. They will have the space station and Orion ship-to-ship call shortly, and after that they will have an opportunity to talk with the science team, discussing their lunar flyby observations. The science team will be able to ask questions about what the astronauts saw while their memory is still fresh for the event. Of course, we also got calls during the flyby yesterday, as well as they were recording some audio into their portable computing devices, or that tablet that you see right there. Those audio recordings have been downlinked to the science team. They will then review those and gather data from what the crew was able to observe during their flyby period. Later this evening, they will also have the RTC-1 burn, that's Return Trajectory Correction 1. Return trajectory correction burns are similar to outbound trajectory correction burns in the sense that they are small refinements of the spacecraft's flight path. The translunar injection burn is what really put us on the trajectory that we're on today. That occurred on flight day 2 and is what committed the crew to flying around the moon and to their splashdown in the Pacific Ocean on flight day 10.
Good morning, Houston. We are 202,306 nautical miles away. Earth is pulling us back, and we are happy about that. We're ready for morning DPC.
We're happy about that too, and ready for DPC. We've got about a dozen quick items for you. The first of which is updated nominal burn plan and nominal RTC last star on board. Next, for Victor, a reminder for your exercise per the execute note at MET.
We'll be looking on the D's. Christina's checking right now.
Oh, we're stepping on each other. Victor at MET, 22 hours, 20 minutes. Please stop your exercise in advance of the OpNav attitude maneuver. Over.
Okay, Stan, if you could just give us a call and remind us, that would be great.
We will do it. Next, for Christina, for your exercise, we expect to be in a forward-link LOS at that time, so you will have the opportunity to park the arrays for exercise yourself. We have three items for the toilet. Last night, 14 hours of waste tank dumping has freed up 11% of room in the tank. So we would really like to treat tank volume as a consumable for entry today. We'll keep that vent going, but we're asking you not to use the toilet for urine until then. And we understand that you're down to support that with CCU use, but wanted to be certain. Over.
We'd be happy to talk more about the Hail Mary option, but if this is the final answer, we can support this on board.
Okay. Roger. Thank you. For FecoCan R&R, we know of one full container. Are there others? Over.
That's a negative for now.
Roger that. Last item for the toilet, no Oxone R&R for today's toilet maintenance. Over.
I do love the smell of oxone in the morning, but it sounds good. No R&R today.
Roger that. Next, PCD1 is not showing a micro SD card inserted. If there is a card there, would you please reseat it?
Yep, Stan, we will work on that.
Okay. Next, DU2 had today's flight plan pulled up when we updated that plan, so we'd like you to close and reopen the flight plan on DU2. And we see your thumbs up.
Okay, Christina's knocking that out right now.
Sweet. Jeremy, for docking cam install, can you please tell us about how long this takes?
I'd say probably 20 minutes, and it's much faster once you know what you're doing, but the big thing is we store it down here in F3 in the clamshell, and it's not as bad to unstow it. It's a little bit harder to stow it. The cables are a bit unwieldy, but other than that, once you know what you're doing, it's pretty quick.
Stand by. And can you give us an estimate of how long it takes from once the camera is out of the locker to installation complete?
For a first-time install, 20 minutes. For every other, if you're doing it by yourself, 5 minutes.
Thank you. That's very helpful. Jeremy, one more item for you. After this meeting, when you turn on the acoustic monitor, can you please give us a call? We're timing things here on the ground.
He will give you a call.
Thank you. Our last item. Science got your audio files from the first 5 hours of the flyby. We did not find any from the eclipse time frame. Are there any? And if so, where may we find them?
There's definitely going to be some on PCD2. I would look through all the PCDs. Jeremy was the primary commentator there, but we can also look and get back to you.
Roger, we'll check PCD2 first and the others, but if you can give us a clue later, that would be helpful. And that's it from MCC Houston. What you got for us?
Okay, sounds good. Stan, we will just do a quick check on board as well. We have, from your notes in the mission summary, the bobs. We are working our way through bobs, but we are nowhere near completing all the food on board. For instance, I went through an inventory of my food today, and I expect to have 1.5 bobs remaining at the end of the flight, and all my bobs are in bag 16, but we will go and do a pretty good inventory. Overall, I'd say we're probably 40% through the total food allotment right now.
Copy, 40%.
I think the big thing we need for the food is when we start realizing we have uneaten food that we are not going to eat for the remainder of the mission, just tell us where you want us to stow that.
We will do that.
Okay, we have two more topics. First is just a quick one for Huntsville, but don't leave us, Houston. For Avatar, lights 15 and 16 are out, all others are on, and I'm going to hand the microphone to my esteemed colleague and fellow naval aviator.
Pod copies, Avatar.
Actually, Stan, we want to knock out some questions from the mission summary.
And we're ready for questions from the mission summary.
Yes, for the volume in the contingency urine storage bag, I would estimate 300 to 500 mils. And I will continue to use it. And if you'd like me to report, I can.
Copy volume, and thanks for bearing with us.
For email sync, you can keep as scheduled. Sorry, we talked over each other. Stan, can you please repeat?
Yeah, Christina, we copy volume in the contingency storage bag, and thank you for bearing with us. Also copy that we can keep the mail sync where it is.
And thank you for your answers. I think we are questions complete.
And nothing further here in the control room, so we'll call DPC complete. Have an excellent day.
Actually, Stan, we have one more small and quick thing. We just wanted to take this moment to recognize the two newest members of the Association of Space Explorers, NASA astronaut Christina Koch and Canadian Space Agency astronaut Jeremy Hansen. Reid and I are both members, and we're proud to welcome the two of them to this international body of human space explorers. And also congratulations to Jack Hathaway, who recently joined aboard the International Space Station. Thank you.
Thank you for those words, and welcome to the club.
And Houston, a question on acoustic monitor.
We're listening.
Stan, given that we have the USB charger on board now, I was just going to plug it in instead of using batteries throughout the day. And I was also going to install it at the bottom of the docking tunnel, right behind the Nat Geo microphone. That's pretty central. So instead of putting it on the DUs, it'll be at the bottom of the docking tunnel, yeah, opposite the windows.
Copy, checking. And Jeremy, we are good with plugging the acoustic monitor into the USB charger, and we're good with your install location.
Okay, perfect, thanks. And then at nighttime, if we're doing docking camera tonight, which I suspect we are, then I'll transition it to PCD power.
Checking. And Jeremy, we like your plan.
This is Artemis Mission Control in Houston, Texas. You just heard the conclusion of the DPC, the Daily Planning Conference, when the ground team here can relay up any status updates or daily planning for the crew aboard Orion. And the crew has an opportunity to ask some questions as well. Some of those reports may have sounded very simple or menial, but this is the first flight of humans aboard the Orion spacecraft, and so every single detail, even about normal daily tasks, is very important to this team as they prepare for future Artemis missions to the moon. This crew is truly learning and testing everything aboard the spacecraft to make sure we have good systems and good plans for our future explorers. Coming up in about 15 minutes, we will have the ship-to-ship call when the Orion crew will be able to speak directly with the astronauts and cosmonauts living and working aboard the International Space Station.
Okay, Houston, the acoustic monitor is set up and it is recording, and I will take a photo of that for you. I think I'll just take the photo on the iPhone and put it on PCD3 for you, if that's okay, because we're using the D5 right now for the PAO event.
Copy all, Jeremy. We like it.
You're looking at a live view inside the Orion spacecraft of the Artemis II astronauts. Closer to the camera is Commander Reid Wiseman.
And Integrity Houston, just a reminder for the upcoming ship-to-ship call, it's going to be the OE1 microphone, not the handheld.
Again, you're looking at a live view inside the Orion spacecraft. Victor Glover in the background, pilot of Orion. They will soon be speaking with the crew aboard the International Space Station. The International Space Station has been orbiting Earth with humans living and working aboard it for over 25 years now. Current crew members are part of Expedition 74. That includes Roscosmos cosmonaut Sergei Kuzverchkov.
And Houston for a downlink on the 4K encoder, we only need the video, not the audio.
Okay, Sam, thanks for that. We have restarted the stream with audio off, and hopefully you're getting a good image.
We copy the audio, and we see a great image.
Again, the Expedition 74 crew currently living aboard the International Space Station. Roscosmos cosmonaut Sergei Kuzverchkov, NASA astronaut Chris Williams, Roscosmos cosmonaut Sergei Mikhaev, NASA astronaut Jessica Meir, NASA astronaut Jack Hathaway, ESA astronaut Sophie Adeno, and Roscosmos cosmonaut Andrei Fedyayev. This is Artemis Mission Control. We are preparing for the ship-to-ship call from Orion to the International Space Station. This will be an audio-only event broadcast at this time due to bandwidth, but we expect to download the video from each crew later and share that with you. Please follow NASA on social media at NASA and at NASA Artemis, as well as the International Space Station, to make sure you can see all of our crew members talking to each other while in space. While the crew aboard the Orion spacecraft is coming back to Earth after passing more than 250,000 miles away from our home planet, the crew aboard the International Space Station is about 250 miles above our planet.
Integrity, this is Houston. Are you ready for the event?
Integrity is ready for the event.
Station, this is Mission Control Houston. Please call Integrity for a voice check.
Integrity, this is the International Space Station. How do you hear?
Space Station and Jessica, we have you loud and clear. How about us?
We have you loud and clear as well, and we have DME TV up, so we have a view of you right now, and it is making us so excited. We feel like you're here with us, and this is really just making our entire week right now. We've been following along and have seen the incredible photos and heard some of your observations that you've been reporting.
Jeremy, we have been waiting for this like you can't imagine. Let me go check on our PFD. We are 201,726, now 25 nautical miles from planet Earth, which is just hard to believe. The scales are impossible to believe. And for the run of show this morning, I figured I'll say a quick hi, which I have done. I'll hand the microphone to fellow chump Jeremy. He can say a quick hi, and then we'll let you three A-balls just get on with it. Yeah, thanks for giving me like a tiny bit of microphone time before the A-balls get after it. But it's such a pleasure to be spending a little bit of time with our colleagues in space, and we talk so much up here, or we try to anyway, emphasize how important the work is that we're all doing in this program to do the types of things that get us ready to get back on the surface of the moon, and like the administrator was saying yesterday, onto Mars. And so we just appreciate you, and it's fun to be up in space with you at the same time.
We are so excited to be up here with you, and we had a couple of questions. We are wondering, we know how fortunate all of us are as humans to come up here and look down at the Earth from above. Every astronaut that comes to space remarks on that, and we really wanted to hear what that felt like, how different that felt now from your new perspective around the moon.
Well, I'll start by saying we do miss the ISS. The views there are awesome, being able to see specific places, being able to see your home specifically. So y'all's views are absolutely incredible, and I miss them every day almost. The thing that changed for me looking back at Earth was that I found myself noticing not only the beauty of the Earth, but how much blackness there was around it. And how it just made it even more special. It truly emphasized how alike we are, how the same thing keeps every single person on planet Earth alive. We evolved on the same planet. We have some shared things about how we love and live that are just universal. And the specialness and preciousness of that really is emphasized when you notice how much else there is around it.
That's really amazing to hear. You know, it's been an incredible time getting to be here on station. I know you guys have had a lot of that same experience, and we were super curious. You know, like what you're carrying forward from your time training for and flying on ISS to the moon.
Well, the Navy pilots were carrying on, so I'm the only one that heard the question. I'll go ahead and respond. Actually, Chris, it was awesome to watch you and Jessica go out on a spacewalk. I was lucky enough to sit console for your suit up, and I was just filled with pride, but it also really reinstilled in me those flight operations principles that we live by in a real-time, high dynamic, and risky environment. So having that kind of impressed in my mind right before this flight was huge. And basically every single thing that we learned on ISS is up here. And then of course there's the funny and practical, how to eat, how to do silly things with water, how to flip around. We're bringing that with us too.
And I just got to add, C-Dub, right before you launched, you said you can't wait to talk to us on the space to ground, and it is happening, brother. I cannot believe it.
Face to face, we said.
Yeah, I can't believe it. I mean, I remember having coffee and sitting with you guys just before I left to fly up here, and it's just so awesome being able to talk to you right now. It's such a special opportunity.
And we had another question, because now you're in a little capsule that is your home, and although this is a test flight and so everything is new, what surprised you in your journey so far? We know that Reid really likes it up there.
It's really great to hear your voice up there. I can't tell you how fun this event is for us. I hope you guys are enjoying this as much as we are. I don't mean to give you such a short answer, but I can truly say everything. From the core stage ignition and solids lighting to getting into a new orbit, even right after 8 minutes of boosting on the core stage, to then the translunar injection, to flying by the moon. This entire journey has been interesting, but also applying some of the lessons from station in a much smaller volume, how we move around and eat. Those things have also been surprising, because the difference between ISS and here is we don't have another module to deconflict, and so everything we do essentially starts with a spatial conflict, and we have to take the time to work it out in every activity. And so we've been just having fun working through that.
Thank you so much, Victor. That was such a good answer. We laughed all here hearing your answer. Thank you so much.
All right, my turn, and I'm excited to talk to you guys. It's been awesome up here. Being rookie it's been such an awesome experience having a great crew. I know you guys have a tight bonded crew as well. Jessica dared me to grow a mustache all during training, and I felt and I came through on that. So I'm kind of curious what kind of fun you guys had in your training and on your flight here that's been keeping you guys smiling.
I just had a process escape on my water training up here, and I left the PWD valve open a little bit too long. Now, I will say, I'm not the only one to have done this, but I do have the record so far for the largest process escape on the water training failures.
Well, we can tell that you guys are definitely experiencing moon joy, and I feel like even we are experiencing moon joy right now. I think this also sounds like a great band name, so we can't wait for you to drop your first album.
I got a question for you, but the quick story I wanted to tell you is you were asking what it's like here compared to International Space Station, and I'm just going to relate a very quick funny story. Heading into our translunar injection burn, we're coming out of 38,000 miles, coming down to a 100-mile perigee to do that burn, and when we were about 5,000 or 6,000 miles up from the Earth, looking at the entire Earth just growing rapidly in the window, Jeremy turns around to us and goes, "I'm not sure, I think we're going to run right into it." And we were all dying laughing. And it was the most fascinating thing to watch that Earth grow. And we actually ended up TLIing on the upper half of the Earth, and we thought we were going to TLI on the bottom half of the Earth. Like, that is the perspective we had, and then the vehicle reoriented and we went. So it is crazy up here, and it does bend your mind. So question for you guys, I'm looking around the Integrity spacecraft right now. We're rehydrating some sweet and sour chicken. We've got some Kona with cream. We've got some butternut squash, and spicy green beans. So it's all the same food. We want to know, what are you eating, and we're going to mirror you today.
So I had spicy green beans for lunch, and I've been loving seeing all of the things about you guys having the same food. It's fantastic.
I had a mango salad this morning. I think you have this on board too. Oh, Nana, I know you love that mango salad just like I do.
Yep, there's a mango salad on the deck right now.
Well, I hope I'm not talking over somebody, but I wanted to say a couple things to my Astro sister, Jessica. One, sorry to steal your next spacewalk day, everybody, but thank you for cheering us along anyway. And Jessica, I always hoped we would be in space again together, but I never thought it would be like this. It's amazing. Congratulations to you on being commander, and I hope you have an amazing rest of your trip in space.
Thank you so much, Christina. I totally share all the same sentiments, and I'm so happy that we are back in space together, even if we are, a few miles apart. We like to joke about that up here, too, because everyone's talking about the records of the distance, and we ran to the far end of the space station when you guys were on the other side so that we could claim we were the furthest away from you in that moment. Love all four of you so much.
We were doing the same shenanigans here when we got to the furthest point from the moon. I tried to get to the furthest point from Earth. I tried to get to the furthest point in the spacecraft, and my crewmates were clawing me down. And I know that's a joke. We were busy doing science, but we had that same conversation. It was a lot of fun. I don't know how much longer we have here, but from the 4 members of the spacecraft Integrity, we really want to just say our deepest appreciation to the 7 members of the International Space Station, and this has been a true treat. It takes the entire world to do amazing things like this, and to get to come together as this group of people and talk for just a minute at these distances. We are all off the planet Earth right now, and we're all going to go home to that planet, and that is a very special thing. So thank you all for tying in.
Thank you, Reid. Well, beautiful words, and yeah, from here.
And Integrity Houston, ISS is doing a teacher's handover. They'll be back with you shortly.
We are loving all four of you from here, from the space station in low Earth orbit. We'll keep the fires burning here.
And we'll keep carrying the fire. Thanks, guys. Over and out.
Thank you, guys. International Space Station, over and out. Made our day to talk to you.
Thank you to all participants. Integrity and station, we're now resuming operational audio communications.
My goodness, Houston, that was amazing for all four of us. All smiles up here. Just thank you so much for enabling that. That was very, very special to this crew.
Reid, we were happy to do it. You should have seen all the smiles in the control room, and we had a packed visitors gallery, and everybody was grinning up there, too.
Man, Stan, that just made us all cheer up here as well. That is just such a cool thing for the agency, the nation, and the world. What a neat moment.
And here we are experiencing it.
This is Artemis Mission Control at a mission elapsed time of 5 days, 20 hours, and 19 minutes into the flight of Artemis II. You just heard the voices of the Artemis II crew and the crew aboard the International Space Station speaking with each other while both are in space. A ship-to-ship call. We are excited to share that video and audio with you later on today. You can find that on NASA's social media. This is Artemis Mission Control, and the audio you just heard of the crew aboard Orion and the crew aboard the International Space Station speaking with each other. Again, we are going to downlink that video, and we will let you know when that is available. You can follow NASA on social media and the International Space Station as well. We can't promise a time frame when we'll have that video down for you to enjoy, but once we do, it will be fantastic. The International Space Station is now flying 267 statute miles just south of Africa. Meanwhile, the Artemis II crew is flying 231,793 miles away from Earth. Coming up next for the Artemis II crew is a conference with the science team. They will be reviewing what they saw yesterday during their lunar flyby, sharing any findings or interesting information with the science team while it's all still fresh for the crew members. Of course, they have quite a lot of audio recordings that have been downlinked to the science team, and that team has been reviewing and will continue to do so to help them understand what the crew saw and formulate new thoughts about our moon. During the crew's post-lunar flyby conference with the science team, you'll hear them speaking with Dr. Kelsey Young. You heard Kelsey's voice quite a lot yesterday as she was communicating with the crew aboard Orion Integrity. She and her team in the science evaluation room were helping determine even what some of the features were that the crew members were seeing but couldn't quite identify.
Houston Integrity, where did you want to do that flyby conference? On OE1 or OE2?
Jeremy, around Earth 1, please, and Kelsey standing by.
Okay, Kelsey, fire away.
Integrity Science, I have to start with a giant wow. Our whole lunar science team and the broader science community has been pouring out positive feedback and gratitude, so know that what you did yesterday really made a difference scientifically. Also want to say the science team has confirmed the locations of the proposed Integrity and Carroll craters, and it was such a powerful moment here for everybody listening and following along. And then also, just before I dive into the list of questions questions. We heard both Christina and Victor yesterday commenting that being able to discuss with each other amongst your crew, taking things from observation to inference to hypotheses, really added scientific value, and so we'd love to build on that here. So we'll ask specific questions for you guys, but please treat it like a discussion as we heard you yesterday that enhanced value. When you're ready, I'll dive into our questions.
Okay, Kelsey, love all those words. Your plan sounds good. The one thing I wanted to ask you about today during this was I did not record at all where we saw the impact flashes yesterday, so I was thinking maybe I should do that. And if I mean, it's very, very, very rough, so I don't know if that's of any value or not. But if Reid and I can record a rough position in OneNote, do you want to get them off the PCDs, or you just get them when we land? What do you want to do with that?
Can you read my mind? This was exactly the first question on our list. So I'll actually just jump right in, and I think I'll answer your question. So number one question was Reid and Jeremy each reported 3 impact flashes. There were audible yells of excitement in the SIR. And we do not feel we have clarity on when the first 4 of those impact flashes occurred. And so we had follow-ups on, were the flashes brief or were they prolonged, and did you notice any color? And to directly answer Jeremy's question, yes, please do make an annotation on where you think you saw those, because right now the citizen science community is analyzing the data and trying to narrow down where you would have seen those.
Okay, Kelsey, I was just comparing notes with Reid here. We both experienced the same thing. It's a pinprick of light. I would suspect there were a lot more of them. However, you're going to really be staring at the middle of the dark and not looking at the edges of the sun glow around the moon. And it is just a momentary flash, no color, about the size of a star, and it really only lasts milliseconds. Half a second at most.
That's great feedback, Jeremy. Did want to also talk relatedly about any kind of galactic ray flashes you may have experienced. So have any of you guys experienced flashes in your eyes during the mission related to galactic rays, either like while working or sleeping, just to try to speak to the difference between those and what you saw yesterday?
Yeah, 100% difference in those and what we saw yesterday. We see, I definitely see a dozen or 2 every night when I'm going to sleep. I can talk about those if you want, the galactic flashes, galactic cosmic ray flashes. But the impacts on at least these, what we suspect were impact flashes, were absolutely different, 100% different. And Jeremy said like half a second. I would say they were a millisecond. Like the fastest a camera shutter can open and close, that is what I saw. And I would say they were just white to bluish white, and the size of, Jeremy said size of a star. I really like that analogy from space. It was just a pinprick of light. And maybe it was a priming bias, but to me there was no doubt we were seeing it, and we were all seeing it. So it was, and we were correlating.
Great stuff, Reid. Yeah, don't need the description of the galactic ray flashes. So I guess last question for you guys on that. We definitely want that annotation. Please let us know when you have that, and we'll try to downlink it in flight. But when during the period did you see them? Because I think we heard from you like 20 minutes in that you had already seen a couple. So any timing granularity you can provide would help us find evidence from those from the ground and from LRO.
Well, I think it was just whenever we were intentionally looking for impact flashes. We were looking pretty hard. The eclipse occurred, and then we had about 5 minutes of human emotional reaction to staring at that orb floating in the vastness of space. And then right after that, we were like, oh, somebody in the cabin said, let's look for impact flashes, or I see an impact flash. And then we started looking at it, and as we were looking, we all just saw, you know, 1 or 2 or 3. Mine were, Jeremy's annotating right now, and then I will annotate on his as well. I never saw any that would have been in the Earth glow side, so I do not suspect any that I saw would be able to be correlated from a Earth-based science team.
Great feedback. So it sounds like when you guys reported multiple impact flashes, it could have been that you guys all saw the same ones occurring. Any guidance on how many total you saw?
Yeah, we didn't necessarily announce everyone out into the cabin, though. Reid and I saw 2 identical ones. He saw one before mine, and then I know I saw another one after that. So we'll try and give you the annotation and what order they came in. But just remember, this is just very rough.
That's great. Moving on, a question for Christina and any others that observed something similar. Christina suggested there may have been possible lofted dust just prior to Earthrise. Can you describe what you saw just before the Earth popped out from behind the moon? And any other crew, did you witness anything similar to what Christina is about to describe?
Hey, Kelsey. So this was during, Earthrise. I was still on Eclipse for some reason. Yes, okay. My crewmates were they didn't see it the same as I did. What I saw was when it got close, so as you know, a crescent rose, so it was kind of like 2 fangs came up, one fang and then later another fang, and then eventually the center of the smile, the crescent. And right before the center of the crescent came up right before the crescent was there was when I thought I saw something.
That's a very evocative description, Christina. Thanks. You noticed it was gray. You kind of highlighted a gray color. Did it, what was the thickness of it above the surface of the moon? And anything else you can describe about what made you think it was lofted dust?
Yeah, and to be clear, this was Earthrise, right?
A-firm Earthrise, because it's that glow from Earth that would allow that lofted dust to become highlighted against space.
Yeah, I was just making sure it wasn't right after Earth set, if that might also be a time, because the picture I'm building in my mind, I just want to make sure I'm not creating false memories. Basically, and I think this is why not everyone saw it as lofted dust, it was not tall. It was, it wasn't like the corona where it came up high or anything like that. It was just a slightly different gray color right before it rose. And it was small enough to be within the fangs of the crescent. It didn't go farther than the inner part of the crescent, and it could have been an optical thing and not lofted dust, but to me it just sort of appeared, and I felt like it had a glow. I know that those different terms mean things, but I think in this case that would be the appropriate thing there, that it was potentially, in my mind, the sunlight reflecting off of the Earth and creating a little glow right before the brightest part of the crescent came over the horizon.
Exactly what we were looking for. Thank you, Christina. Similarly, on dust, we heard that Reid chose for his second crew choice target to look for suspended dust. So, Reid, did you see any glow or hints of that dust earlier that made you come back to that observation?
Negative. Just really wanted to see some, and I saw none.
Understood. Okay, for Christina and Victor, during Earth's set, we heard you say that the Earth was so bright it made the moon look dark. So you all had the Earth in view during the majority of your flyby. Did you notice any time when the brightness of Earth began to change your view of the moon's brightness? And can you describe how your perception of the moon's color changed as the Earth came closer to the moon?
Yeah, absolutely. And essentially, as soon as the Earth became in the view, the easy view, where I didn't have to turn my head, when it was in what I'll call my field of view, not my field of regard, when I could just see it looking straight, the moon was already at a point where I was losing subtle albedo differences. I think it's the angle of incidence. The angle, the sun to the moon didn't change much, but we moved to the side, so we were seeing a different angle, and the color was less apparent. Oriental had also rotated really close to the limb, so a lot of the features that I was looking at were moving away, but I think the change in lighting was due to the angle of incidence, but then when the Earth became apparent, its brightness, it was so bright. It looked out of place. The gray of the moon and the black of space kind of seemed to go together, but then more in the dull sense, but then the vividness and brightness, like the difference between an LED display and a painting, right? You can just do things with light that you can't do with paint colors. The Earth looked out of place, and it just continued to dim the albedo and color that was earlier apparent in the moon. I'm passing to Christina.
You saw me nodding vigorously back here. That wasn't just my fantastic listening skills. I was nodding to make sure. Oh, we're not on video. This whole time I've been putting on a show. I was nodding, now you know, because I agreed with everything he said. I'll add a couple thoughts that popped into my mind, which was, I think I made the comment that the moon turned into a sponge of light. In my mind, before the Earth came into view, the moon actually was reflecting light, and it was lit up. As soon as the Earth got close enough to be in my field of view to take them both in at the same time, exactly what Victor said, it dulled, it turned into a sponge. It's almost like it went matte, like a matte finish. And for me, so that's brightness and albedo. It also, I would say for me, got like a browner taupe color, like almost an olivey brown, kind of like the boys' pants, not like my pants, but like these pants. And whereas before, I would have said it was more like electric gray in its grayer areas. So for me, it turned more brown, but a very matte brown. I'm going to stop there. There's one more comment I'll make about when it was very close, just in case it's interesting.
Absolutely, we take that
observation. The only other thing I wanted to add to that is not scientific on lunar observations, but I think that, I know myself in particular, but probably we all underestimated the amount of impact of sunlight and Earth glow on cabin windows, on glare on the window structure, window frame, on the heat shield tiles coming across the cabin. That was a pretty large impact, Kelsey.
That stuck up to us here on the ground as well, Reid, and we were hearing the struggles that all those different expected illumination sources provide, but unexpected in the impact that they had. Speaking of things that had an impact on observations, Victor, we heard during your sit rep when you were in the docking window that having that orange Kapton tape in your field of view affected your color observations. That was fascinating and has a lot of impact for future Artemis
Artemis missions and hardware and impacts on color. So any other comment you want to make on how your ability to perceive color on the surface was influenced or limited by other objects of color in your view? We're interested here in color rather than brightness.
Absolutely, but all the comments I made about the Earth earlier apply to this one as well. This is the thing I wanted to make sure to add, so I'm glad you asked, is that the human eye adjusting is another thing that had huge impact. Some of the colors and their patterns did not appear in the moon. The Aristarchus Plateau, you know, the browns, the streaks that we saw there, until you stared, kind of like the impact flash. You really have to be staring. And it wasn't because of intention, it was because my eyes were adjusting. And so as soon as I would look inside the cabin, the vehicle, if those bright LEDs that were in the vehicle, or if the sun was reflecting off of a corner of the windowsill, or the bright Earth in the field of view, those things would change my eye, and I'd have to wait for them to adjust again. And I want to add, while Victor's talking about that on the Kapton tape color, let me see if I can nods from my crewmates, but when we're looking at Earth, just a normal Earth lit up by the sun, I'm used to seeing these deep blue pictures of like Earth Day photos, Apollo 8 photos, but when we look out, the cloud cover is so bright, it is almost blindingly bright, and you really cannot make out significant detail in the Earth when we're at long distance on a sunlit Earth. So it was very interesting to me that the Earth is so bright from the clouds that it is actually hard to look at.
Hey, since we're going discussion style, like you mentioned, I'll add a couple comments on color. I didn't notice color changing my view, except maybe, like Victor said, I didn't realize it when I looked down at the PCD and back, because I do think there was a time scale there where you saw things a little differently if you just stared for a long time. And sometimes even staring out into the blackness to kind of reset and come back. So I think that is a note. We were very much reliant on PCDs for instruction, but that did cause our eyes to constantly refresh on those colors. I didn't notice necessarily a color difference, but just like a quality of observation, maybe like he was saying, like the details or the contrast. So it might have even been a night vision thing. Yeah, that's all saying that. I did want to mention that when we were getting the really, really high amount of light into the windows, even the shrouded windows from the sun, the reflection on things behind the observer that are in the cabin was really strong on the window. So there's some high albedo things behind our heads, like there's a white bar, the abort sticker on the RHC, some other metal things, like we have some white bungees. I was trying to observe the dark side of the moon during the Earth set while the Earth was behind it, and I ended up asking Reid to give me some black t-shirts, and we covered all of that stuff so that the reflection was just less in the glass, and it worked so well. It basically made observing for impact flashes possible, whereas it wouldn't have been otherwise. So that's a good tip, and I would even recommend, like maybe as part of your stuff, if you ask this in the future, like a black room, a dark room cloth or something to lay behind the observers. Finally, back on the question of moon color change during Earth set, the other thing that that happened, which was kind of, I think, just more in the category of like a mirage or something, even though I recognize there's no atmosphere around the moon that would cause the same things as mirages on Earth. There was definitely an effect, like when the Earth actually set, of like when it first touched the moon, it was like your eyes didn't know what to do at that boundary, and it kind of just created a lot of light in that spot. Once it got below that tangent first touch, then it got more normal, and I was able to just see the Earth and see the moon and see their contact. That's all for me. Anybody else on this question?
Thank you, Christina. And as I think I saw you notice, we did just get video a couple minutes ago, so it's nice to see you as we're talking to you. Next question is for all of you. Ohm crater was observed by all 4 of you, and we're interested in whether your different viewing angles resulted in how you observed Ohm. Jeremy and Reid saw it first. Were you able to see the ejecta rays, the central peak? And then Christina and Victor, you were next, and you observed Ohm later in the past. Could you resolve similar or different features than what you're about to hear from Jeremy and Reid?
The ejecta blanket for Ohm, I mean, it definitely changed as we went around the moon, but it did not change that much. It was always there. It was always fairly apparent. What is more apparent than the ejecta is the brownish gray, darker area that makes the 12 o'clock to 3 o'clock cut of the pie shape. Like that was always very apparent, and the ejecta rays just made that contrast much more apparent. But overall, Ohm did not change drastically as we went around the moon, unlike Oriental, which drastically changed as we went around the moon. And I'll keep going there. I'm kind of going to ask Reid this question, but it was later on in the orbit that I noticed the ray of Ohm, like the primary ray of Ohm that comes out of roughly the 3 o'clock position, was on the mare. And I'm not sure if I was picking that up initially in our first observations, but definitely in the latter. Did you notice that at all? No, the near side mare, yeah. Yeah, Reid says he was noticing that the whole time. That might have been more noticeable to me later on, but that would be the only delta.
Understood, Reid and Jeremy. Curious to hear Victor and Christina's thoughts after hearing you guys.
For the later observation, I was able to see into the crater wall on the east side, and the shadowing there was actually neat, so I could see layers of shadow, so that there's kind of like 2 faces, or maybe 3. I couldn't tell because we were so far away, but I could clearly see light, then dark, then light, and so the layering within the interior crater wall on the eastern side. I was able to see the central area, and I actually thought I saw 3 distinct groupings of something, and I think that's in the recording, but again, I was so far away, and my eyes were quite tired from adjusting. I was wearing glasses and looking in at the PCD and then looking out of the window out above the glasses, and so my eyes were really getting to work out. And they've definitely been changing. That's the other thing about the eyes, too. My eyes shifted on this. I'm about to turn 50, and that just was very different than 5 years ago. But I did see interior structure, and I commented on the colors, but again, from the angle we were from the surface, everything just looked plain, but the interior floor seemed to be the same color as the surface outside to the west, but the wall seemed to be a different color, which kind of made this was the same color as the rays and I think the central lift, but I said this in my recording, and it's already becoming fuzzy, but I made some correlations between there, and I talked about looking at the Grand Canyon, where you can see different layers and know that this is the same as that, even though they're not connected. I think the interior, the floor, and the wall maybe had different color or albedo, and I don't remember which one I said in the recording.
I'll pile on with your question. We just brought up the LTP because I forgot that while I was doing this, because there was no shadows on this whatsoever, I think it was towards the end when it was just in full light and very little relief, I kept losing Ohm itself. And I actually thought that there was a crater northeast of Ohm that is at the center of those kind of starfish rays. There actually looked like there was a very simple and old crater there, and that is what I kind of actually went back and forth between that one and now what I see is true Ohm, and I wish I would have referred back to my PCD at the time. But I think the lesson learned here is without any relief, it is very difficult to sometimes make out craters, especially here where the rays are actually offset from where the crater itself is. So you're drawn into a spot, and I am so surprised right now that there's not a little crater where those rays meet, because in my mind there was, and that was
Hey, that reminds me of something else I talked about earlier. When Reid and Jeremy were in the windows, I remember looking out and I said something to you. I think that it doesn't look like purely rays. I did see the continuous feature of that east-west line, that 3 o'clock ray all the way into the near side Mare. There's some interesting something going on there. But at first, it looked to me like just like a contact of two different materials coming together, or two different age materials coming together. And when we got on the far side, the far side view, where I was looking back at it, I mean the later view, it still looked like, I don't know, it sometimes didn't look like a ray, it just looked like different color material. And really the point of this is not to talk about the 3 o'clock ray and the 12 o'clock ray, it's to talk about the wedge. The wedge looks to me, if you remember my recording comment about continents, I kind of had the near side Mare continent, the middle from Ohm to Oriental, and then the Hertzsprung continent. Those colors in the wedge look like, and not they look the color of, but also the concrete kind of packedness of what's around Hertzsprung. Those look similar. So that's kind of also playing tricks on my eyes between rays and just different material, not just a ray laying on top of the material.
Thanks a lot, Victor and Christina. Wow, we're really looking forward to continuing to dive into this when you guys are back with us on Earth. We want to sign off now to get you guys over to your next activities. Before I do that, I'll just say when you're making those annotations about the impact flashes, any annotations you want to provide about the structures in the corona you saw during the eclipse, we would take those annotations. And that's it for me. It was so wonderful to talk to you over the last 2 days. Thank you again, and can't wait to see you all back here on Earth. Thanks again for what you did for science.
You guys did an extraordinary job of preparing us. We really appreciate you. Can't wait to talk more about this. This was too short. For the sunset recording, if you're looking for that, it's on PCD3, and the file name is recording, open brackets, 13, close bracket.
Copy all, integrity. Science is over and out.
Integrity Houston, we're maneuvering to the lunar obs attitude, and we'll be ready to dial for the PFC as soon as we see you online.
We copy, and can you say window for science pictures? We're a little PCD limited.
Checking. Christina, window 2.
Copy, we see it coming into view. You guys look gorgeous.
Why, thank you.
This is Artemis Mission Control. You just heard Dr. Kelsey Young, Artemis Science Flight Operations Lead, speaking with the crew aboard the Integrity spacecraft, Orion. Yesterday was lunar flyby day for the astronauts aboard Orion. They had about 6 hours to observe the moon, and during that time they took turns taking photos as well as making annotations and making audio recordings that were sent to the science team last night. Of course, if you got to watch, the astronauts were also calling down information real time of what they were seeing while orbiting the moon. The conversation you just heard from Dr. Kelsey Young with the crew was their post-lunar flyby conference. As you heard, she asked some specific questions about some of the targets that they saw, as well as the configuration of the spacecraft. As this is a test flight, everything we learn on this mission helps us prepare for future Artemis missions to the moon. So even minute details about moving through the spacecraft or how vision was changed based on placement are very important to us. Now this view inside the SIR, the Science Evaluation Room, you can see this team of scientists taking a look at one of the photos that the crew shared. And you can see the photos from the crew at images.nasa.gov or by visiting NASA's social media. That's at NASA or at NASA Artemis. During the flyby yesterday, the crew became some of the first humans to see portions of the moon that had never been seen before by human eyes. Just after the conclusion of the post-lunar flyby conference with the science team, you heard NASA astronaut Christina Koch is moving into the next portion of her day. That would be opportunistic science imaging. She's going to be taking some pictures of the Earth from outside the windows of Orion. All of the Artemis II members will also get a chance to speak with their families today in private family conferences. Additionally, we are targeting the RTC-1 burn this evening. We're looking at about 7:03 p.m. Central Time. The RTC-1 burn stands for Return Trajectory Correction. Our trajectory was determined when we completed the translunar injection burn. So these trajectory correction burns are fine-tuned burns that allow us to just further refine our flight path on the way home. You're looking at a live view inside the Science Evaluation Room as the team continues to analyze some of the photos that the crew sent down. Again, this is the first crew to fly by the moon in over 50 years. So some of the photos they took will be of areas that had never before been seen by human eyes. This was determined by our launch date, which was April 1st. The crew additionally became the first people to see a solar eclipse from the other side of the moon. We got some live views of that real time as well. It was pretty incredible to see the corona of the sun coming around the side of the moon. If you haven't seen some of those images yet, please do visit nasa.gov. We're now at mission elapsed time of 5 days, 21 hours, and 2 minutes into the flight of Artemis II, the first flight of humans aboard the Orion spacecraft. Orion is now 230,896 miles away from Earth, but continuing to grow closer. 44,464 miles away from the moon and continuing to grow farther. You can track these stats at any time by visiting nasa.gov/trackartemis. Earlier today, Orion exited the sphere of influence from the moon this morning. That means the gravitational pull of the moon is now no longer pulling on the spacecraft, and that they are more pulled by the gravitational pull of the Earth. Again, we're targeting splashdown in about 3 days, 4 hours, and 14 minutes in the Pacific Ocean. Our coverage remains live 24/7, all the way until...
The moon gets small quick when you're leaving it. Wow. Moon and Earth are just about the same size. We saw the Earth for a minute. Now Christina's looking at the moon. Pretty awesome.
We copy. Thanks for the report.
As you've heard throughout the flight, the Orion capsule is often referred to as Integrity. This is a name given to the spacecraft by the Artemis II crew members and announced last year. The crew reports that the name Integrity embodies the foundation of trust, respect, candor, and humility across the crew and the many engineers, technicians, scientists, planners, and dreamers required for mission success. And that this name is also a nod to the extensive integrated effort from the more than 300,000 spacecraft components to the thousands of people across the world that must come together to venture to the moon and back, inspire the world, and set the course for a long-term presence at the moon. You're now looking at a live view outside the Orion spacecraft, solar array wing positioned to look at the spacecraft itself. The command module of Orion, that shiny part, is approximately 330 cubic feet habitable volume. So the interior living space for the crew is about the size of 2 minivans. And that's about 60% more cubic volume than the crew members had during the Apollo missions. As previously mentioned, this spacecraft is made from more than 300,000 components. And to be specific, 355,056 individual parts compose this vehicle. This a live view inside the Artemis Mission Control Room, where the team continues monitoring all systems aboard the spacecraft, making sure we are set for mission success. This room is also staffed and monitored 24/7. This helps us ensure the spacecraft is safe as well as our astronauts. And just down the hall, we have the International Space Station Flight Control Room, another flight control room staffed 24/7 to maintain all systems and safety for the crew living and working aboard our orbiting laboratory. Because the crew did have such a busy day yesterday for flyby, we anticipate hearing from them a little less today as they have some downtime. Even though they are potentially in an off day, each astronaut dedicates 30 minutes every day to exercise. When in a microgravity environment, the astronauts could experience bone and muscle loss if not continuously exercising. So Orion is equipped with a flywheel, which is a small device. It's been installed directly below the side hatch. The flywheel is a simple cable-based device, and it can be used for both aerobic and resistance workouts, and we've seen some of those from inside the spacecraft. We've also been able to see some of the movement that happens outside the spacecraft when the crew is working out. So during exercise, the crew or the ground team can park the solar arrays and prevent any loads being imparted on them that might damage them. Again, we're live here in the Artemis Flight Control Room. 5 days, 21 hours, and 15 minutes into the Artemis II mission. This is the flight day 7. And again, this is a little bit of a quieter day now that we have had the ship-to-ship call with the International Space Station and the post-lunar flyby conference with the science team.
Integrity Houston, we're maneuvering back to bias tail to sun. Also, we're preparing to clean up your onboard burn plans, and at DPC we forgot to ask you for AGA numbers. Could you please give us those?
Okay, Stan. AJ just came on, as you heard. Give us 5 minutes. We'll give you a reading, and we copy the other remarks. All good?
Roger.
The voice you hear communicating with the astronauts today from Artemis Mission Control is NASA astronaut Stan Love. He's the Capcom for today. The Capcom stands for Capsule Communicator, and that's the single person in the room that communicates with the crew. This keeps their communications streamlined, both from all the ground teams to and from the astronauts.
And Houston, integrity for opportunistic science imaging note.
We're listening.
Yeah, just wanted to mention mention that towards the end of that opportunity, I'm not sure if it was after the maneuver started or just before it started, but the sun was out the window that I was observing on, and I went to go look for the moon to take more pictures of it after kind of pulling my vision away to look at the lunar targeting package. And when I put the camera back out, I ended up pointing it directly at the sun for a second. So just a reminder that if something's gonna change to where the sun is now in the view that people are looking out at the camera, just give us a heads up.
We will do that. Thanks for that information. On another topic, your new state vector is on board.
Awesome, thanks, and I'll be ready for my PFC in a couple minutes. Do I need to tell you all which PCV I'll be on?
And Christina, no, we don't need to know which PCD you're on. We'll just dial your account.
Copy, I'll be signing in shortly. Appreciate it. Okay, got it. Thank you.
As you heard, that communication's coming from Orion and NASA astronaut Christina Koch, mission specialist. She had an opportunity to do some opportunistic science when the spacecraft's attitude was pointed to allow her to see Earth and the Moon at separate times. You also heard Christina calling about her PFC, that stands for Private Family Conference. All of the crew members are getting some time to talk with their families today. Meanwhile, NASA astronaut Victor Glover is scheduled to conduct some aerobic exercise on the flywheel. Teams here are sending commands to park the solar arrays in safe harbor. That prevents any loads being imparted on them while the crew is exercising. Coming up in about 30 minutes, we will have our daily news conference for Artemis II, where leadership here for the mission are at Johnson Space Center, and we'll be able to discuss the latest status on Artemis II. Again, that's coming up at 4:30 p.m. Eastern, 3:30 Central. That'll be broadcast on this stream on NASA's YouTube, but we will still have our clean feed on the separate YouTube stream. Once that status briefing is over, you can come right back to this feed or just stay right here and we will continue coverage from inside Mission Control Houston.
Houston Integrity, confirm we are go for secondary purge line dumps.
We are go for those dumps.
Can you remind me again, Stan, when we have to stand down from them today?
Checking. And Reid, we'd like you to stand down from CCU dumps between MET 3 hours and MET 5 hours 30 minutes, except for the scheduled dump on Victor's timeline at 3:10.
Okay, we copy, Stan. I'm in the process of setting up the recorded exercise. I would appreciate a call up with a 2-minute warning to stand down from exercise.
It's on our to-do list, Victor, don't worry.
Live here in Artemis Mission Control at Johnson Space Center in Houston, Texas. This is a visualization on your screen, and you can access this anytime on your own device by visiting nasa.gov/trackartemis. This is called ARROW, the Artemis Real-Time Orbit website. We're about 40,000 miles farther away from the moon than we were this time yesterday during our lunar flyby. And if you have not seen some of the pictures coming down, please do check out NASA's social media. They are absolutely phenomenal.
Integrity Houston, Orbit 1 team is stepping off headset for a few minutes to take our team photo. We'll be back with you shortly.
Sure. Sounds great, Stan. Enjoy that and savor that moment. Please savor that moment. What an exceptional time.
Will do, sir.
Those communications coming from Capcom and NASA astronaut Stan Love to the crew aboard Orion. The Orbit 1 team is monitoring the consoles here at Mission Control Houston, led currently by NASA Flight Director Jeff Radigan. The team's going to take a brief team photo. This is the team that has served this shift for the entire mission and has been training together for a significant amount of time now. All of these flight controllers are the ones keeping the systems and the crew safe aboard the Orion spacecraft for the Artemis II mission. Additionally, we have the Orbit 2 and 3 team with the same tasks, and they'll be taking their own photos. This is Artemis Mission Control continuing to monitor the flight of Orion. We are now 5 days, 21 hours, and 36 minutes into the Artemis II mission, the first flight of humans aboard Orion. The Orbit 1 team is currently on console here in Artemis Mission Control and just took a group photo. We are on flight day 7 of this 10-day mission, with Orion targeted to splash down about 3 days, 3 hours, and 40 minutes from now. This room is full of team members who make this mission possible. That includes Prop, the propulsion officer, CDH, command and data handling, INCO, our integrated communications officer, MPO, the mechanical and power officer, and so many more.
Houston Integrity, are you ready for AGA readings?
Yes, Jeremy, we're ready to take those AGA readings.
And Houston, there's no rush if you're still taking the photo. Just going to give you AGA readings whenever you want them.
Jeremy, go ahead with those AGA readings.
For O2 and CO2 is 1.5.
Copy numbers. Do you have temperature and pressure?
For pressure and 77.3 for temperature.
Copy all. Thank you, sir.
And you just heard Canadian Space Agency astronaut Jeremy Hansen calling down some AGA readings. The AGA is the Anomaly Gas Analyzer, and this is powered on before exercise. It takes about 5 minutes before they can give readings, and they want those readings once they start exercise and afterward. This is the first flight of humans aboard the spacecraft, and therefore the first flight of our ECLIS system, the Environmental Control and Life Support System. So these readings help the team on the ground understand what gases are in the cabin, as well as temperature. You just heard it's about 77 degrees Fahrenheit aboard Orion.
Integrity Houston for burn conference and targeting.
Go ahead, Stan.
Hey, Jeremy, our GNC maneuvers are conflicting with our preliminary targeting activity, so we may have to do prelim a little later, or we may skip it entirely and pick up at intermediate. We'll keep you posted on how it's going.
Okay, copy that. And then when, just cue me up on when the latest trajectory information is on board for targeting. Do we have the latest burn plan on board?
Jeremy, we do not have the latest on board yet. That's one of the things that we're trying to catch up with. So the burn conference scheduled before preliminary targeting is definitely canceled. Again, we'll call you when we have updates.
Okay, understood, Sam. No problem. We're pretty flexible.
And Jeremy, we're expecting approximately 30 minutes to get the new burn plan on board.
Okay, understood, Sam.
This is Artemis Mission Control at Johnson Space Center in Houston, Texas. The voice you hear on the ground is Capcom and NASA astronaut Stan Love speaking with the crew aboard Orion, specifically Canadian Space Agency astronaut Jeremy Hansen. We are targeting the RTC-1 burn today. That's Return Trajectory Correction 1. That is targeted for about 7:03 p.m. Central Time. This is a small burn using the reaction control system thrusters on the service module of the Orion spacecraft. This helps us fine-tune our path back home. Stan Love was letting the crew know that we are canceling their first preliminary burn targeting conference. They have another one of these in a couple of hours when they will have the final burn plans uplinked and the final targeting complete. It's now been 5 days, 21 hours, and 51 minutes since Orion launched atop the Space Launch System in Kennedy Space Center in Florida. The crew aboard Orion is getting into the first few hours of their day. They woke up approximately 10:35 a.m. Central Time today to the song Tokyo Driftin' by Glass Animals and Denzel Curry. There are a few more open blocks of time on the crew's schedule today, as they had an extremely busy day yesterday with lunar flyby. Right now, pilot Victor Glover is exercising. And Christina Koch is enjoying her private family conference. You heard her call down just prior to that she was ready for her PFC, and that's what that stands for. All of the crew members are getting a chance to talk to their families today. Thanks for joining us for our live coverage of the Artemis II mission. We are expecting to have a news conference today with mission leadership here at Johnson Space Center in Houston, Texas. We are expecting that news conference to start around 3:45, and I assume you're watching this on NASA's YouTube stream, and if so, if you're interested in watching the press conference, you don't need to change the channel or change your stream. We will be airing that right here. We also have a secondary stream with raw audio and video, and you can find that also on NASA's YouTube. Here's a video from the outside of Orion, and as we mentioned, pilot Victor Glover is exercising. We do see the spacecraft move a little bit when the crew is exercising, and so the teams here park the solar arrays into a safe harbor position. That means any motion that they experience due to the exercise doesn't damage the solar arrays. If you're just tuning in and you are looking for the news conference that was originally slated for 3:30 p.m. Central Time, we are now expecting that to begin 3:45 p.m. Central Time. That will be live here on this YouTube stream. This is Mission Control Houston, specifically the Artemis Flight Control Room here at Johnson Space Center in Houston, Texas. This is a live view from a camera mounted on one of Orion's solar array wings. Interestingly enough, each of these solar arrays provides enough electricity to power 2 3-bedroom homes. This camera looking back on the European service module as Victor Glover, pilot of the Artemis II mission, conducts his exercise for today. That's why you are seeing some movement on your screen. We are mission elapsed time 5 days, 22 hours, and 2 minutes into the flight of Artemis II, the first flight of humans aboard the Orion spacecraft. And if you are looking for the press conference that was slated to start at 3:30 p.m. Central, we are now expecting that to start closer to 3:45. You're in the right place. You're watching live coverage of the Artemis II mission, the first flight of humans aboard Orion. This is a view coming from outside the Orion spacecraft on one of the solar array wings, pointed back at the spacecraft. And as we mentioned, you see some movement because NASA astronaut Victor Glover is in his exercise period for the day. The crew is having a little bit of a quieter day after a very busy schedule yesterday, photographing and recording observations about the lunar surface as the spacecraft approached just about 4,067 miles away. Our distance to Earth continues to shrink now as we are preparing for splashdown on April 10th. We're standing by for the start of our daily press conference here at Johnson Space Center in Houston, Texas, and expect that to begin momentarily. So if you are watching this channel and looking for more spacecraft views, you can switch to our other live stream. Otherwise, you can stay.
The Artemis II mission is a test mission of the Orion space capsule.
Artemis II will be the first time we put humans on this rocket.
We're going back to the moon because it's the next step in our journey to Mars.
We were always going to the moon.
Pushing ourselves to explore is just core to who we are. That's a part of being a human.
And liftoff. We shall return.
Continuing to test out every bit of Orion.
Coming back to Earth, 7 miles a second.
When humanity sets big goals, we can bring together genius from around the world.
You have the best people on planet Earth putting this vehicle together.
That's what's up. To innovate for the benefit of humanity and to inspire the world through discovery.
And here we go.
Good afternoon and welcome to NASA's Johnson Space Center in Houston, Texas. I'm Bethany Stevens and we are here today to provide a status update on the historic first crewed test flight of the Orion spacecraft post-lunar flyby. On our panel today, we have NASA Administrator Jared Isaacman, Dr. Lori Glaze, head of Artemis, Rick Hinfling, Artemis II Flight Director, Kelsey Young, Artemis II Lunar Science Lead. We'll start with opening remarks from each of the briefers before opening it for questions in the room and on the phone bridge. If you're on the phone, press *1 to submit your question. When called upon, please state your name, affiliation, and to whom you'd like to direct your question. With that, I will hand the floor to Administrator Isaacman for his remarks.
Thanks, Bethany. It's been an exciting Artemis II mission so far, and a very eventful 24 hours as the crew surpassed the Apollo 13 distance record, 252,756 miles from Earth. They relayed observations from the lunar surface. They've captured some incredible imagery. They performed a ship-to-ship call with their colleagues on the International Space Station. They performed additional manual piloting of the Orion spacecraft. They've been working at a reduced cabin pressure of 10.5 psi in support of future integrated lander operations, and they did take a call from the President of the United States, Donald J. Trump. We had millions of viewers on that that tuned in for that historic broadcast, and it concluded with the President promptly inviting the astronauts to visit the Oval Office. Now, Integrity left the lunar sphere of influence earlier this morning, so they're now approximately 229,000 miles from Earth, and they will splash down Friday evening at approximately 8:07 p.m. Eastern Time, and the recovery weather is so far looking favorable. Now, you can see some of the spectacular images the crew have captured here on our screens. There we go. Now, this is the first time humans have documented some parts of the far side of the moon. Now, these images will be publicly available on NASA's website, our digital platforms, and the White House actually released the now iconic EarthSat photo from earlier today. Now, these are the first of many incredible images of the moon, and we'll continue to release them as they become available. My understanding from just a few minutes ago is that they captured over 175 gigabytes of imagery from the lunar pass alone just yesterday, and the images that you are seeing right now have been transmitted back to Earth predominantly through optical communication, which is pretty cool stuff. Now, before I turn the call over to Dr. Lori Glaze, I wanted to share some of the other things that we are doing at NASA while the Artemis II crew are underway on this historic mission. So the crew on the International Space Station are hard at work. They're undertaking the science and tech demos, many of which have directly supported the Artemis program missions and will continue to do so. The Exploration Ground System personnel, if you want a quick Kennedy Space Center update here, have been out at the launch pad. The crawler, my understanding, is approaching the outer gate, and we expect ML1 to be back in the vehicle assembly building within approximately a week. Now, this would cut down on the turnaround time that we observed from Artemis I, measured in months right now, several months. On the science front, my understanding is the Blue Origin Mark I lunar lander is wrapping up here at the Johnson Space Center in Chamber A. Nancy Grace Roman Space Telescope testing is progressing, so much so that we feel reasonably confident we're going to announce a target launch date this year sometime in the next 2 weeks. In aeronautics, we've been flying the X-59 almost daily while the Artemis II mission has been underway. So we work to rebuild our X-plane portfolio. The first senior-level Artemis III mission design discussion today. Teams are working with vendors on moon-based RFIs and RFPs, and we are advancing the Skyfall scientific payload for the first interplanetary nuclear-powered spacecraft, SR-1 Freedom. I think the most important point we're trying to make here is we can launch history-making missions like Artemis II, start making meaningful progress towards Artemis III, and do all the other important programs the world's been waiting for from NASA. And with that, I'll turn it over to Dr. Glaze.
Thank you, Jared. I just have to say, wow, when I look at all of those images that were scrolling by. I hope all of you are as inspired as I am. I know as they continue to be downloaded, they're just absolutely stunning, and we really hope that they are inspiring truly everyone in the world. As the crew surpassed their record for the farthest distance, as Jared just mentioned, when they traveled on the far side of the moon, they offered some compelling words, and I love this. They said they challenged this generation and the next to make sure that this record is not long-lived, and I love that because we have big plans to go not just back to the moon on a regular basis, but beyond. And then, of course, while it's been really exciting here the last couple of days, as we've been watching all of the activity in Orion, we still have to ensure that Reid, Victor, Christina, and Jeremy return home safely on Friday evening. So we're pretty focused on that now, making sure that they get home safely. I will just say a couple of things about yesterday's operations. Really provided a great opportunity to test how our flight operations teams and our science teams are working together in real time with the crews at the moon. And in fact, from my perspective, one of my favorite things about watching all of the amazing data that was flowing down yesterday is thinking about how so much of NASA is working together in order to enable all of what you're seeing.
Victor, this is your 2-minute warning. Please stop exercise within 2 minutes for the off-nap maneuver.
All right, better stop exercising. But as I was saying, what's really great to see everybody working together. So I think about our exploration programs that are supporting our transportation systems like Orion, working with our flight operations and our flight directors, all of the ground teams that are supporting, including the science team supported by the Science Mission Directorate, thinking about our crew that are actually performing the work, and then the payloads that have been provided that they're using. So everything that you're looking at isn't just, it's not just the pretty pictures, it's a huge chunk of NASA working together to enable that. All of this information that we're gathering is really going to help refine how we plan our future missions to the lunar surface. I'll just say that our flight operations team continues to fly Orion and put it through its paces as the crew and the spacecraft make their way home. And the mission isn't over yet. We do continue to learn from how our spacecraft and our crew are operating together in space. We continue with several of the science activities that are focused on the crew health and life in space. So still a lot of things going on, and with that I'm going to pass it over to Rick so he can share some of the operational details.
Thank you, Lori. The administrator touched on a few of the operations that the crew's been up to recently, but I'll fill in a few of the other details of interest. Since we last met Sunday evening, the crew performed the first orbital trajectory correction maneuver, outbound trajectory correction maneuver number 3. It was 10.4 feet per second. The burn duration was 19 seconds, and we used our auxiliary thrusters on the service module. Obviously, yesterday was the big day with flyby, and I'll save all those details for Kelsey, but you know, we had some really poignant remarks from the crew, and I can assure you there wasn't a dry eye in mission control when the naming of the 2 craters was announced by Jeremy. As part of the lunar flyby, the crew made their pass closest to the moon, flying at 3,138 miles per hour relative to the surface of the moon. And now they're on their way making their march back home to Earth. We bid a temporary goodbye to the moon earlier today at 1:23 p.m. Eastern Time. That's the milestone where we exited the lunar sphere of influence and we're back under the control of Earth's gravity. As for today's operations, we had a couple of public affairs events. The crew is going to have, each of them will have a conference with their family members. We'll have some routine medical checks. And then in the evening, we're going to perform the first return trajectory correction maneuver. It will be 1.3 feet per second. It'll last about 15 seconds, and we're going to use the service module reaction control system thrusters to do that burn. We expect that burn to occur about 9 p.m. Eastern Time. Finally, I'll conclude my remarks with acknowledging that the USS John P. Murtha has left port and has started steaming out to the midway point for the recovery of Integrity and her crew later on Friday. That's all for today's operations update, so I'll hand it over to Kelsey.
Thanks. Spirits are very high. We did what we set out to do. The lunar science team and the crew prepared extensively, as we talked about a couple days ago, for flyby, and I hope you all saw that yesterday during execution. We confirmed, as Lori mentioned, that we can, achieve science through orbital observations and through integrating science into flight operations. And as Rick just said, we left temporarily, and we're looking forward to integrating all these lessons learned in future missions. I can't conclude opening remarks without diving into science detail, so forgive me just a couple deep dives. Impact flashes, over a 30-minute observation period, and this was largely during that time of the eclipse, crew observed several impact flashes. We did have citizen scientists here on Earth also looking for flashes, and I know that the Lunar Reconnaissance Orbiter team is hard at work trying to identify evidence of those impact flashes that the crew observed. I did have a chance to have the post-flyby crew conference with the crew this morning, and we asked a lot of follow-ups on those impact flashes. Impact flashes are caused by micrometeorite impacts hitting the moon, and they really help tell us about the dynamic lunar environment, which is, of course, also important when we think about future missions. I don't know if I expected to have the crew see any on this mission, so you probably saw the surprise and shock on my face. And though I was not in the science evaluation room, I heard that there were audible screams of delight. So, a very excited science community. You've heard me talk a lot about the importance that human explorers bring to scientific exploration, especially around observations of color. And so I'm sure all of you, like I was eagerly awaiting if they saw any other colors other than black, white, and shades of gray. You heard that they did indeed. Right away, they started describing the green around Aristarchus Plateau and different brown hues. And these colors really help tell us nuances about the chemistry of lunar material, especially the greens around Aristarchus. That was exciting. That's something that we can all see from here on Earth. And so I encourage you all to go out and look at the moon tonight and look for Aristarchus and imagine those green hues that the crew members saw. You heard a lot of discussion, especially from our pilot, Victor Glover, about the Terminator, which really, to our mind, highlighted the benefits and also the challenges for future surface operations. The lighting conditions along the Terminator that the crew experienced yesterday do mimic, in many ways, the lighting conditions of the South Polar region. The low sun angles, the dramatic lighting causing, the extreme shadowing, and illumination also accentuating topography. This is really important for our agency's future moon-based plans and understanding how crew member observations can contribute to future mission planning. And finally, the Artemis II crew, in a very poignant moment, offered proposed names for two unnamed craters in the moon's eastern hemisphere: Crater Integrity for their vehicle and Crater Carol for Commander Wiseman's late wife. I think we have a picture. Yeah, thank you. Upon return, the crew does plan to submit these to the International Astronomical Union as consideration for official names. There was, as Rick said, not a dry eye in the house. Really poignant moment, and that we were really glad to observe them describing. And with that, I think we can take questions.
Yep, we will open the floor and take questions, and my colleague Will over here will pass along the mic. We can start with you, Jackie.
Thanks so much. Jackie Waddles with CNN. I don't think there was a dry eye on Earth when Carol Crater was named. I was just curious, was Reid aware that that was going to be something that the crew was going to do? I was just curious if there was any pre-planned discussions and they were just kind of looking for the crater, or kind of how that came about. And then really quickly, I also wanted to just check on a toilet status update. We heard this morning that I thought I heard some chatter around it being considered, a reentry issue now. Like, is the toilet out of commission until they get back, or where does that stand? Thanks.
I'll take the second part.
Okay. Yes, I know the crew put a lot of obviously thought and pre-planning into what you heard yesterday. It is my understanding that he was aware prior to yesterday.
And the toilet remains operational. The challenge that we're working through is evacuating the wastewater tank. The vent is a lot less than we were expecting, and so we're having to fall back to some other alternate means other than the toilet. But what you overheard on the Space to Ground, or on the Orion to Earth channel this morning, was us deferring some maintenance on the toilet. Typically, when you have 4 crew members using it throughout the day, nominally, you have to do a maintenance activity once a day. And with a lower use rate, since we're not able to vent the wastewater products, we don't need to do the maintenance as often. And so that's what that exchange was about.
Thanks. Irene Klotz with Aviation Week. I'm over here. Jared, that's a pretty impressive and full portfolio of missions you outlined that NASA's involved in now. And without getting you in trouble with your boss, are you going to be able to defend an $18.8 billion budget, $5.6 billion for 27, or are you prepared to kind of work with Congress to see if the administration will support more Thank you.
I will say we'd like to keep the focus on what we were speaking about today and then move on to other questions like that at a later date and keep the focus on the mission. Thank you.
Mark Strassman, CBS. I feel as though I've talked to about 10 people off campus today, and they all wanted to ask me about those remarkable images. And so they asked me, so I'm going to ask you. Have you seen anything in those images that surprised you? And what about those images touched you?
Take that, Kelsey?
Sure. Oh my gosh. When I woke up this morning, I've spent most of my morning just flipping through, the thousands of images that have started to come down. And there is something in every image that surprises me, right? I mean, you might think that after looking at hundreds of images taken of the lunar surface, I would get sick of it. I have not, nor do I anticipate getting sick of it. It's just their experience and the amount of time and the rate at which they were moving. Every vantage point is different. You heard them audibly describe yesterday, wow, I'm looking at the same feature as I was 10 minutes ago and it looks different, right? And the images reflect that. And so, when I see these images, I connect to each one in a different way, especially in light of what we heard from the crew yesterday. I think as a geologist by training, I love looking at the pictures of the lunar surface, but I think certainly, emotionally, a lot of us have connected with the images of Earth, with the images from during the eclipse, with the images from the vehicle cameras taking pictures of the moon during the eclipse period. And while they are inspirational and I think allow all of us to, really feel a little bit of what they were feeling, there's also a lot of science hidden, inside of those images. And I can tell you that right now, as we speak, there is a science evaluation room full of several dozen scientists who are already getting going on those images. Just as one example, there was a healthy scientific debate this morning about some of those images taken during the eclipse period and what we can see of the solar corona and what we can see of zodiacal light. So the conversations and the science lessons learned are just beginning.
Hi, TG Mascaro with the Epoch Times. Thanks so much for taking the time. For Jared, as we saw with Artemis II going around the moon and having that very characteristic blackout of when they go around the moon, how much longer are missions to the moon going to have that as we develop a moon base? And where do, say, communication satellites in lunar orbit land on the priority list?
Yeah, I'd say, people have asked quite a bit about, was elevated blood pressure when we were without comms with Orion on the far side of the moon. We have comm issues in LEO relatively, routinely. Certainly our operators train for it, our astronauts do as well. But in terms of the bigger picture, can we do better? For sure, right? We've talked about, prioritizing observation and comm relay satellites for lunar operations so we can bring the world along with us as we build out a moon base. And I think I was in a meeting not that long ago where we described it as if not the platinum age for commercial communication capabilities, certainly the golden age. We're very close. So we have a number of providers that are all investing heavily in these kind of capabilities that we can take advantage of in LEO, cislunar space, and I have no doubt in lunar orbit in the years ahead.
Hi, Kay for Interstellar Gateway. Thanks for doing these. This is really cool. Jared, question for you. Can you speak on the responsibility of what being the administrator during such a pivotal moment means? And secondly, I'm speaking on behalf of musicians around the world and bands. I have a band called Chasing Satellites, and will there be potentially an opportunity to submit music for a future Artemis mission for the wake-up calls? That was really cool to be a part of and to watch as a musician.
Certainly. So I think I've described before that I thought that certainly felt a lot more pressure, being on the outside and responsible for a human spaceflight mission than being in the vehicle itself, especially a mission such as Artemis II, which kicks off so many other exciting ones to follow as, we return to the moon and build that enduring presence to learn so that we can undertake even grander missions, as Dr. Glaze referenced, beyond the moon in the future. So I think it is a great responsibility, but you derive confidence from all the expertise that exists within NASA, the workforce, our commercial, our international partners that come together for a moment like this, all the testing that goes into it, and the fact that we have this playbook before and we're running it. Now, in terms of contributions for music and future wake-up music for subsequent missions, I hope we're running so many missions to and from the moon in the future that we're going to have to cast a very wide net for creative content. So.
Thank you. For Administrator Isaacman, Tom Costello with NBC News. I'm just wondering, how are you feeling now? I realize we don't have the crew home yet, but you've had a very successful trip around the far side. How are you feeling about this setting the stage, testing out the vehicle for a lunar landing as soon as 2028?
Yeah, well, I mean, I'd say for this mission, we're certainly off to a good start. I mean, clean launch, and the vehicle has been doing well. I've made commentary early on that I like that we're talking about, water access valves and cabin temperature and even plumbing issues, for that matter, for all the things that we could have been potentially talking about prior to the mission underway. But I'll breathe easier when we get through re-entry and everybody's under chutes and in the water. In terms of getting ready for the subsequent missions, it's kind of why I picked some of the words that I did at the beginning of this press event, is that a lot of people's rightful attention right now is on the crew of Artemis II, especially here at JSC and Mission Control, especially the recovery forces that are now making their way out to bring this crew back to their family. And for everybody else, we've got the other things to get done, including thinking about Artemis III. It's why I was very happy that the crawler is making its way out to 39B right now. We've got a timeline to get it back in the VAB, ideally in a week. That would cut down on the turnaround, I think, by 3 months compared to Artemis II. So we can undertake, again, world-changing missions like Artemis II right now and get ready for the next ones at the same time.
Hi, Josh Dinner, Space.com. Has this mission revealed anything about life aboard Orion, crew workload, flights in deep space, or maybe something unexpected that will shape how NASA and Artemis crews approach preparing for future missions?
Do you want to take that, Flight Ops?
Yeah, that's a really interesting question. We've learned a tremendous amount as part of a lot of the flight test subjective activities we've been doing. I think we have a couple of problems that we still need to work out, but Orion has shown itself to be a very capable capsule for beyond Earth orbit space travel. And I think the things like, as the administrator talked about, the things that we're going to have to improve upon for Artemis III are relatively small and incremental in nature, as opposed to wholesale redesigns of spacecraft subsystems. So overall, I'm extremely pleased with the performance of the spacecraft and how it's served as a campsite for our 4 crew members.
We'll go from Marcia to Eric and then do a couple on the phone bridge.
I'm Marcia Dunn, Associated Press for Dr. Young. It's hard for me to know how quickly these pictures are coming down. How many would you estimate that have come down so far of the moon? And these luminous flashes on the surface, was that an actual meteor shower, do you think, or is it just your usual business of falling debris?
Yeah, so the team, the FOD team, is working really hard to bring down the images as fast as they can. Of course, we also have other vehicle data that needs to come down as well, but the team is working really hard to try to get those images down and of course, get them out to you guys as well. As of the time I left Console, roughly an hour ago, there was just over 50 gigabytes of data from yesterday that had come down. Of course, every image does not exactly have the moon in it, but it is taken from within the lunar observation period. So we're working really hard to to get those down, as well as the audio files that the crew were taking. That's a really rich scientific data set because it captures the nuance of what the crew were seeing. You know, we heard a few of those per hour in those science situational reports you were hearing yesterday, but there are multiple hours of recordings of, you know, meaty science observations, about 2/3 of which we've been able to get down so far, and our team has already been looking at that, you know, those couple hours of transcripts and audio files. As for the impact flashes, yeah, absolutely. I mean, we think they saw at least 4 and possibly up to 6 impact flashes. Again, I talked to them about that just this morning in the crew conference with them. I think, you know, we you know, it's very early to tell, right? This happened less than 24 hours ago. Our teams are looking at it now, and spacecraft like the Lunar Reconnaissance Orbiter will be really helpful to try to help us narrow in on that. But the lunar environment is a dynamic place, and we have a lot to learn about it. You know, LRO has returned a lot of information about the lunar environment, but observations like this are a critical part of our understanding, which will pay dividends for future surface exploration.
Eric.
Eric Berger, Ars Technica. There's a question maybe for Jared. So why haven't we been back to the moon in 53 minutes? I'm just kidding. So you brought up the Artemis II mission design. Can you bring up sort of, or talk about the 2 or 3 hardest problems that you're tackling? Sort of, you talked about the mission design meeting today, but sort of the 2 or 3 hardest problems you're tackling right now to make sure that launches next year.
Yeah. So I don't want to get too far out in front of a mission that's underway right now. I would just say that there are a lot of things based on the information we have available today, from feedback from our vendors, that we know are achievable. And I think one of the questions probably will just be what the initial orbit will be for Artemis II. Is it going to be LEO or HEO? And I think that we're all going to have some sense of which one, and there's pros and cons for each of them for sure. We're all going to be able to have some sense about which path we'll likely go down based on launch cadence of our 2 HLS providers, both of which have launches coming up, I would say, in the next month or less right now. So a big key to our strategy, not just to return to the moon, but to stay and to build a base, is going to be rapid reusability of heavy lift launch vehicles. So the more they get experience doing that, the more options that are available for us for Artemis III. But I'd say right now, we certainly have a good plan for that mission. Will help us buy down a lot of risk in advance of a landing for Artemis IV in 28.
Jeff Faust with Space News.
Hi, Jeff Faust with Space News. Question for Dr. Young. Now that you are going to get all of these images and verbal descriptions and annotations, what's the plan for the science team in the days and weeks ahead to go through all of that data and see how they address the 10 science objectives that you laid out for this mission? Thank you.
Oh my goodness, what a good question. We have a lot of data to get through. Like I said, it has already started. We had teams working overnight, you know, after the crew went to sleep, as soon as we started getting data down. You know, I will reiterate that we will be getting all mission data relevant to lunar science archived and made publicly available within 6 months post splashdown. So these are all of the images of the moon, these audio files, and even the annotations. But in the meantime, over those next 6 months, we're also going to be preparing 2 reports that we also owe to be publicly released within 6 months post-mission. One is a science operations report that describes, you know, how our team was structured to integrate with flight operations to accomplish our objectives. But relevant to your question, the second one is a post-mission preliminary lunar science report. And so we are going to be going objective by objective with those 10 lunar science objectives you referenced, looking across this entire, you know, really rich, robust, but very large data set, and really trying to understand what data we got relevant to each objective, but set up the community for success so that they can access those data and help us answer these fundamental driving science questions. You know, the lunar science team for this mission, it was our charter to develop the objectives and to maximize the science value out of this mission. We'll be doing an initial assessment over 6 months, and then we're really eager to see what the community is able to do with these data.
We'll move to Ken Chang with the New York Times.
Thank you. So I have some questions about the optical communications. How was the performance like? How many gigabytes was sent? What was the data rate? How does that compare with what was expected? And how does it compare with the usual way of sending data back? And it seems like it's been almost operational already and not just a test. Thank you.
Yeah, I think the question was relative to some of the data rates for the optical communication system. I'll just give you a stat from overnight that we heard from Consul. We got 20 gigabytes down in a little more than 45 minutes. That's orders of magnitude more than we get via our S-band telemetry system. So optical comm has been working really well, and hopefully we can take what we learned on Artemis II and expand its operational capability and its implementation for future missions.
And now we will move to Lauren Grush with Bloomberg.
Out to me yesterday was just the vivid descriptions that the crew used for what they were seeing and how they remained in kind of constant contact and talkative throughout the flyby. I'm wondering if it's possible to say how that might have compared to the Apollo crew observations and how that robustness impacted the science and the data that was collected.
Absolutely. I mean, probably a lot of people watching have spent a lot of time looking back at Apollo and maybe watching Apollo in real time online and reliving what the Apollo crews, not just on the surface, but in orbit experienced. You have, I'm sure, heard the Apollo descriptions of the lunar surface from orbit, and they were also really impactful. They trained heavily in geology and orbital observations, just like the Artemis II crew did. I will say, listening to the level of scientific discourse that the crew was having yesterday was incredibly inspiring. I mean, a testament to how much they prepared before this mission. You know, I heard a couple times Christina and Victor especially saying, when we took the time to actually talk to each other about a specific target that we were both seeing, we elevated each other. We elevated what we were able to pull out of that target. You know, more brains on a scientific target are better than one, and we heard from them directly multiple times that they were helping each other to advance their scientific understanding of what they were looking at. We actually also heard them say, hey, we have a hypothesis. Can you guys provide guidance on that hypothesis, like right now in the middle of our flyby? So the science team was saying, you know, was cross-checking what they were seeing, was reading up geologic ages of major lunar impact features, and it was informing the observations they were making during the flyby. I mean, this is absolutely everything we hoped for by integrating science into flight operations, you know, because, again, science enables exploration and exploration enables science. And the fact that, you know, they're giving observations and, you know, I was able to immediately follow up on those observations with, you know, just the quick questions that can enhance science return, it meant that they were evaluating and buying down multiple working hypotheses in real time during their flyby. And just imagining the future when we have crew on the surface for short duration missions and ultimately the moon base, the amount of science we are able to gain when, you know, science is woven into this operational fabric is incredibly impactful. And we saw that, you know, for 7 straight hours yesterday.
Now we'll move to Micah Maidenberg with the Wall Street Journal.
Hey, good afternoon. For Rick, what is the approximate time on Friday when the crew module separates from the service module, if you have that on hand? You know, the administrator mentioned splashdown is expected for around 8:07 Eastern. And then any color on kind of reentry prep work ahead for the crew and mission control between now and Friday? Thanks.
Sure. I'll start with some of the times. The crew module and service module separation is going to occur about 20 minutes before entry interface. So that separation will be at 7:33 p.m. Eastern Time. We expect entry interface about 7:53 p.m. Eastern Time, with a splashdown around 8:06 p.m. Eastern Time on Friday. As for the preparations that the ground and the astronauts are doing today to prepare for entry, or today and future days, a lot of it is all of the science equipment and cameras and tablets and reference material that got unstowed in support of the flyby. Well, we have to put that all away. We have to pack up our suitcases and get ready to come home. And That takes time, and so we are laying out a plan to make sure that the crew gets everything packed away in time to get their suits on and get in their seats to perform that final trajectory correction maneuver on splashdown day and come home.
We'll move back in the room to Joey and then on to Will.
Thanks. Joey Roulette with Reuters. I just had another quick toilet question. Do you have any idea as to why the venting is not happening as fast as you hope it is? And what other hardware on the spacecraft might that implicate, or what other problems might that cause?
Yeah, so the engineering team is going to go through a full fault tree to identify all of the potential causes of the blockage. Initially, you may have recalled that we thought it might be icing up at the nozzle at the outer mold line of the spacecraft. We have pretty high confidence that it's not an icing condition. We've put the spacecraft in a sun-focused attitude to bake off any ice. We've activated heaters along the lines internal to the spacecraft, and we still see a blockage. And so the latest theory is related to some of the chemistry that goes into ensuring that the wastewater doesn't develop any biofilms. And there may be something going on with a chemical reaction where there's some debris that's generated as part of that reaction, and it's getting clogged in a filter. But again, we don't have root cause, and once we get the spacecraft back into the processing facility in Florida, we'll be able to get access to all the components and do a real detailed fault tree to identify the root cause.
Hi, Will Robinson-Smith with Spaceflight Now. Thank you all for taking the time. Going back to Dr. Young's point about the intersection of science and exploration, to both Dr. Young and to Dr. Glaze, given the number of believed to be impact flashes that the crew observed during just a relatively brief amount of time, I wonder how these observations and the ones made previously by LRO will factor into creating the conditions for a moon base that can allow the astronauts to stay safe, given the probability that they may experience a micrometeoroid impact at that site. Thank you.
Well, I do think that the data that we're collecting with these observations, and as you noted, the LRO data that we're continuously collecting, we have been for quite a while, all of that is being fed into our plans and making sure that we understand what all of the variety of risks are. There's many that we're looking at, and of course micrometeorites being one, as we start to establish infrastructure on the surface and understanding those rates. These kind of data really help inform us as far as what we can anticipate. And of course, the different parts of the moon, down at the South Pole, maybe a little slightly different rates than we would see higher up at higher latitudes. So we need to compile all of those data and understand where, what those impacts might be.
Hi, I'm Nick Notori with ABC 13. A question about the scientific stuff that you found yesterday. I know the question was asked about what was inspirational. I talked to Joe Kearns yesterday, and he had told me, I'm just looking at his quote, as a scientist, I can tell you what's most inspirational is when you're pouring through something you're working on and you realize you're seeing something that nobody else has ever seen before. I know you talked about the impact flashes, but is there anything else that no one else has seen before that you guys have already saw? And then also explain to us on Earth that maybe this is high level over our heads, how what was photographed or taken yesterday could maybe give us some answers on our planet of Earth.
Thank you. Yeah, lovely questions. I might just give a specific example of something I heard from the crew yesterday. My background's in geology and specifically impact cratering, so every time they describe those beautiful basins, I get really excited. They did describe Ohm crater a couple of different times, and they noticed a variety of different color and albedo hues associated not just with Ohm, but with the rays that extend out from the crater. This could indicate, impact events are really compelling for a lot of reasons. Obviously, I'm quite biased, having written my PhD on them. But they can excavate material from great depths below the surface, which means they're kind of like a geologist cheat code, right? Where you can't get all the way down there by yourself, but when an impact has brought up that material for you, it can actually perform that excavation, and we just need to send the crew to the right spots on the surface, and they can actually look at depths far below the surface. And I bring that up here to say that what the crew observed observed around Ohm yesterday was they actually noticed color and albedo hues coming out in those rays, and they noticed that they were distinct and different and evolved along the ray systems, which could potentially lead us to believe that that crater excavated from distinct depths below the surface of the moon. So it's those kinds of nuanced observations that can ultimately inform future landed missions, future crewed missions, to understand where can we go to maximize the scientific value. These ultimately get at chronology of the solar system, at how the inner solar system has evolved over time, which connects to, you know, the moon being the witness plate for our planet and for the inner solar system. You know, you heard Lori and I the other day get very excited about talking about, you know, pesky plate tectonics and oceans and vegetation that gets in the way of us looking at the early part of our planet's past, and the fact that that part of the record of our Earth-Moon system is still available on Earth. Well, where it's available is the highlands, the far side highlands, and the South Pole. Specifically, the South Pole has the South Pole Aitken Basin, which is my personal favorite lunar and planetary science objective. It's the oldest basin in the solar system. If we can get the right age constraints on that basin, it can help us anchor the chronology for the entire solar system. And so crew observing things like they did with Ohm, where they can say, with my eyes, I can see this distinction, which can ultimately tell us that future observations of high priority landing sites could tell us something similar. This is how we start to really bite away at these really, really fundamental science questions that impact not just our understanding of the moon, but how our own planet has evolved over time.
Mark Kirkman with NSF. This is for Rick. While we have you here, I'd like to drill down a little bit on entry day a little more. Sounds like weather in the primary recovery zone is looking favorable, but can you walk through, as we approach EI and pass EI, what redes capability you have, what kind of cross range and downrange capability you have, when you committed to that landing zone, and also with this thermally benign entry you're going to fly, do you still expect to exceed Apollo 10's speed record? I know you don't care about that stuff, but we do.
That's all right. You can still keep asking the questions, and we'll go follow up, and we'll find the answers. I do not have the answer offhand about the Apollo 10 speed record, so we'll have to get that back to you tomorrow. And tomorrow, I'm actually going to provide a lot of detail about the sequence of events for entry, as I'm the entry flight director for Friday evening splashdown. But with respect to your particular question about entry interface, we can select a new landing site as late as entry interface. We would prefer to not do that. We like to give ourselves a little bit of margin, but we can adjust the latitude and longitude of the site, and the spacecraft will fly to those coordinates so long as we get that command up before entry interface. So we're going to make a decision far in advance of entry interface to know where the splashdown site will be, because our top priority is to ensure that when Integrity and her crew of 4 splash down, that we have the recovery forces right nearby to help get them out and get them back to the recovery ship. So we have about a 475 nautical mile range. I can't do that conversion. But 475 miles of ocean within which we can select the most acceptable weather. And as you said, weather near San Diego looks favorable, so I'm optimistic that we'll be able to land close to the shore.
Tom Clark with Sky News in the UK. First of all, congratulations on the flyby and those breathtaking images, and thanks for doing this too. There's been a lot of focus on the toilet, but I'm looking to get a kind of overall perspective on how happy you've been with Orion and the European Service Module. What are you definitely going to have to fix before you fly it again? And how confident are you looking ahead to re-entry?
I'm not sure I heard the end of the question. You talked about how the Orion is performing, and it's performing spectacularly. I have to tell you, our Orion team is so pleased with really everything the way that it's performing. The engines, the manual control that you've heard us talk about several times, that The crew have just gone over and over about how well that's performing, how nicely the Orion crew module is handling. The service module, again, providing everything that we need. Yeah, we've had a couple of challenges, but overall, I mean, I think they're pretty minor in the whole grand scheme of things. The hardware itself performing extremely well. We're really looking forward to turning this around and flying again in a year, and then again a year after that. I think this hardware is really spectacular, and we're really looking forward to doing this more often. We're going to get the toilet figured out. The toilet is actually functioning perfectly. It's the drain, the ability to vent the wastewater. And as Rick said earlier, as soon as we get this down on the ground, we'll be able to get inside, and we will get to the root of that.
Hi, Lisa Grossman from Science News. This is especially for Kelsey, but actually for all of you. The astronauts yesterday used a lot of really fun analogies and descriptors for the features on the moon they were seeing. Did any stand out for you as favorites?
Oh, of like the analogies they used to describe lunar features? Yes, I liked the handprint, and that actually, we had a team working overnight to figure out exactly what they meant. They found it this morning. They were very excited to figure out exactly what they were talking about. I think, we train them, to be totally blunt, we train them to describe it like they see it. Tell us what speaks to you and how you can communicate it back to us. And so I think Christina delivered on that ask when she described a feature as looking like a wound. We do agree. I'm not sure it was my favorite lunar descriptor I heard yesterday, but it was evocative, and she was right. It did indeed look like a wound. And I was also really resonating with the way that several of the crew members were trying to, in the spirit of wanting to have a scientific dialogue, right? They had science questions they were trying to answer, and they were asking us some pretty sophisticated questions real time. And so to bring us with them on what they were seeing, the way that they were cluing us in to how they were moving across the moon by saying, take this feature, draw a line from that to this, and then continue going, and this is the feature we're looking at. Help us use that as a waypoint. It was an incredibly impactful way to have our team be ready to very quickly provide them with answers to the science questions, which is, again, important, not just because, of course, we want to support our crew at the moon, but when we can respond quickly and understand what they're looking at, it maximizes science, because we can immediately ask the follow-up question and have them burrow in even deeper on those multiple working hypotheses. So the descriptions are not just great to clue us into what they're seeing, but it really helps us in real time maximize the science we're getting out of, in this case, a 7-hour flyby.
I'd like to just comment real quickly on one of my favorite. It wasn't actually a lunar observation, but it was during the eclipse, and they were looking at the planets that could be seen. You could see Mercury, Mars, and Saturn.
And Venus, yeah.
And Venus on the other side, yeah. But they're looking at the planets, and I can't remember who said it, said one of them looks kind of red, and Kelsey's observation was, that's Mars, you're looking at your future. And I thought that was spectacular.
Thanks.
We only have time for a couple more questions, so I'll pass it over to you, Jonathan, and then we'll do one more.
Thank you. Jonathan Seri with Fox News. I would love to know about the logistics that went into the ship-to-ship call. If you could explain in layman's terms, how did it work out? And perhaps more importantly, what was the symbolic impact of that call?
So the logistics, we have done a number of public affairs events on integrity throughout the mission. We do them multiple times a week on the space station, and everything goes through Houston. So the data comes through the Deep Space Network, through the Jet Propulsion Laboratory over to Houston. We have audio and video technicians here in Mission Control who can reconfigure the routes for the data and send it to the appropriate destination. We do public affairs events down from the ISS through the tracking and data relay satellite system. And so that's something we do all the time. It's just a matter of connecting the two wires. And so logistics were really quite easy despite the distances.
Yeah, maybe I could add too. I was in the flight control room this morning for that call, and something I observed that I didn't anticipate. You know, of course, we're expecting the crew joy at talking and connecting to each other, but looking around the room at the other flight controllers, and actually the viewing gallery was open for other FOD employees to observe. You know, this is a team sport. You know, so many people, thousands of people work to enable this, and seeing the joy on everybody's faces as these two missions flying at the same time had this moment of connection is going to stay with me as a moment of inspiration from this mission.
Yeah, and I would just add, I mean, in terms of it being symbolic, it is certainly a step in the right direction. I mean, it began with a single person in a Mercury spacecraft, and we progressed to 2 spacecraft at one time. I mean, now we've got an international space station while a spacecraft is coming back from the moon. This is progress. We talk a lot about, what is an interesting KPI, the number of people living and working in space. We want to see that number grow. So hopefully in the not too distant future, we've got communication going on between our moon base, their colleagues that are orbiting above them in a lander, relaying back maybe to other colleagues on an international or future commercial space station. These are all steps in the right direction for the exciting future that many of us were probably imagined as children and we're trying to bring into reality.
We're going to do last question.
Hi, Dr. Allison McGraw, Mysterious Meteorites from here in Houston, Texas, for lunar science lead Kelsey Young. Are there going to be any science data available of perhaps the color data for the impact flashes or trajectory directions they came from?
I asked the crew about that this morning. Any color? How long did they last? Where were they? And Reid and Jeremy, as I was talking to them, had their crew tablets out and they were making annotations and sketches on what they saw. They did just report this morning in our conversation that they didn't observe any color to them and that they were very, very brief, but they did provide sketches on whereabout they saw them. And so again, like I said, we're going to use the Lunar Reconnaissance Orbiter to try to, track to those features and try to identify what they saw. Trajectory is going to be hard, but Lunar Reconnaissance Orbiter data can help us pull that out. What we really wanted to do before the crew, splashed down and got distracted with all of the things they're going to be doing here was capture that nuance before it got overcome by a lot of other mission events. So we were able to capture a lot more detail this morning in my conversation with them, and the LRO team is off to the races.
Great. With that, thank you for joining us today for our mission status briefing. We will have another briefing tomorrow. Until then, you can continue to follow along with the mission 24/7 on NASA's YouTube channel, and we will leave you with these beautiful images captured by Integrity.
Good afternoon and welcome back to the Artemis Mission Control Room here at Johnson Space Center in Houston, Texas, where teams continue monitoring all systems and the crew aboard the Orion spacecraft, the first flight of humans on this spacecraft. The crew is having a little bit of a quieter day today. They woke up at 10:35 a.m. Central Time this morning, got into their post-sleep period, and then got to talk to the International Space Station crew. Following that brief encounter, they stepped into their post-lunar flyby conference with science lead Kelsey Young. You just saw her in our mission status briefing. Since then, the crew has had some opportunities to speak with their families and exercise a little bit too. We are targeting the RTC-1 burn this afternoon. That's Return Trajectory Correction 1. This helps fine-tune our flight path for Orion and its crew to come splash down on Earth. We are now 3 days, 2 hours, and 9 minutes from our initially targeted splashdown time. You're looking at a visualization of the spacecraft. Now 48,670 miles from the moon and 228,090 miles from Earth, continuing to grow closer. You can keep up with this data at any time by visiting nasa.gov/trackartemis. Coming up shortly, we expect the crew to have their intermediate burn targeting conference. At that time, the teams will load up the latest burn plans aboard the spacecraft. The burn we're expecting this afternoon will be small, especially in comparison to the translunar injection burn that put us on this trajectory. These trajectory correction burns are using the RCS, or Reaction Control System, thrusters on the spacecraft. Much smaller thrusters with much less power than the OMS, or Orbital Maneuvering System, engine that we used to propel us around the moon and bring us back home. This is a live view from the spacecraft looking at the service module. That large nozzle is the OMS engine. We do not intend to use it again during the mission, having completed that translunar injection burn. We're coming up on the burn conference ahead of today's return trajectory correction burn with the crew members aboard the Orion spacecraft. As you heard Commander Reid Wiseman call down earlier, they have only eaten about 40% of the food allotted to them for this mission. The food the 4 astronauts eat plays a key role in maintaining their health and ensuring they can perform their mission objectives to the best of their abilities. Let's learn a little bit more about how to eat in space.
Around the moon meal.
Around the moon meal. What would you eat? Cheese? Can you think?
Oh my gosh. That's clever. What do you think?
That's good. My name is Christina Koch.
And I'm Jeremy Hansen. We're crew members on the Artemis II mission flying around the moon. And when we fly around the moon, of course, we're going to be taking some food with us.
That's right. This is how to eat in space. Here we are in what we call our food lab at NASA Johnson Space Center. We come in here quite often to sample space food. The neat thing about the food selection is it is so diverse. Different entrees that you wouldn't imagine can be rehydrated and actually good in space are completely fair game. And it's pretty awesome.
We came in for Artemis to do this. We got about halfway through the first session and we're like, we're not really sure we're going to have time on board to warm this stuff up. We talked a lot about day one. It's a long day. It's hours before we even leave the launch pad on our way to space. And then when we get to space, we have a lot of important events that day. We just did a sim yesterday where lunch is scheduled. It's
midday meal.
Yeah, midday meal for all 4 of us. And so those would be great moments, I think, in our mission to have prep some food and sit down or float as a crew and just have a joint meal.
For sure.
I think that'd be fun.
My name is Shulei Wu. I'm the food system manager for ISS and Artemis. The food lab at Johnson Space Center, that's where we make and package most of the space food, and also where we will be making all the food for the Artemis missions. Food is a big part for our crew members. They provide the nutrition, the calorie, micronutrient for crew members, but also boosting crew morale. It's very important. There is always a lot of steps, very strict steps for us to follow to making sure the food we provide are consistent and meet all the food safety, nutritional requirements, and most important, also need to taste good. The other strategy is always promote the variety because everybody's food preference can be very different. Therefore, the more variety we can have, the better to meet the needs of the astronaut group.
They bring out these little tiny samples of each food, and you're like, oh my gosh, I thought we were having lunch. And then by the end, there's so many space foods, and every time you leave, you're like, I am so full.
I'm so full, I'm in pain.
And you just rate them like, I love this, I don't want to eat it, I'd eat it if you tell me I need it. Because what the food lab does is they take all your preferences, but they're also like good parents and they're like, you need a well-balanced diet.
Exactly. They were like, no, you can't have mac and cheese every day, Christina. Sorry.
I'm Wyeth McKinley. I'm a flight controller and a crew instructor for Artemis II. We're here at the Space Vehicle Mock-Up Facility at Johnson Space Center. We're inside the Orion mock-up where we perform crew training for the Artemis II mission. On the Orion vehicle, crew is able to heat up their food using our briefcase-style food warmer. The food is held in contact with the central heater plate by these springs so that it can warm up and they can have a delicious meal. Much of the food and drink that's on Orion is rehydratable. And so crew at our potable water dispenser will fill up their food and drink, and then at that point, you go ahead and pop it into your food warmer.
I'm kind of envisioning there's maybe one person putting the stuff in and out, kind of tossing it out to everyone as it's done. Or maybe if we're not scheduled together, you're just on your own over there, popping some things in. Or maybe just in your 2 minutes of free time between things, you're kind of getting it ready so it has time to warm up. We'll see.
Eating together really resonates with me. I think it's just a human thing to break bread together and to enjoy that necessary thing you have to do, the thing you should be grateful for. And so doing that as a group, as a family, has always been meaningful for me.
Absolutely. It represents togetherness and something a little out of the ordinary. You don't necessarily get to have those meals with everybody in your life, but if you are sharing a meal, especially if you're sharing breakfast, lunch, and dinner with a group of people, that means something. It's like a camping trip.
Go ahead.
down and to the left, line 17, the DAP load is 3 for burn maneuver.
Go ahead.
In the guidance solutions section, the delta V tote now 1.4 feet per second. The TGO is unchanged at 15 seconds.
Good, go ahead.
Attitude, yaw, 154. Pitch, 26. Roll, 287.
Copy, go ahead.
And the last bit's the delta V, X, minus 1.2, Y, 0.6, Z, minus 0.6.
We copy all. Thanks for that clear read up, and we see that our next step is to run 2-level targeter.
We concur. We'll be watching. And just a reminder that we're not pressurizing the tanks before this burn, so we're going to do it in blowdown.
Copy blowdown, and understand we have a go to complete step 9 on board, even though the burn execution steps show it as a skip.
Checking. Oh, good catch, Christina. We missed that. That should not say skip. We do want you to do step 9 for intermediate targeting.
Copy all. We will do it and chat with you after. Thank you.
Roger.
That was Capcom Stan Love here in Mission Control Houston, a fellow NASA astronaut speaking with NASA's Christina Koch aboard the Orion spacecraft. The crew aboard the spacecraft is preparing for their return trajectory correction burn. It's the first of these return trajectory correction burns, reported to be a 1.4 foot per second delta V burn. Again, we are expecting that return trajectory correction burn tonight around 7:03 p.m. Central Time. These small return trajectory correction burns.
Houston integrity with that. If you wouldn't mind just giving the rest of the burn execution steps a once-over, we think they all look nominal from here on out, but we'd feel better. Let us know if you see any other deltas. Thank you.
We will run an additional check and call if we find any other problems.
Perfect, thanks.
Such a fantastic view coming from a solar array camera on Orion, looking back at all of us here on Earth. Currently, the spacecraft is 227,756 miles away from our home planet. Orion is now 49,168 miles away from the moon. Earlier today, the spacecraft exited the lunar sphere of influence. That's when the pull of gravity is strongest on the spacecraft.
And Integrity Houston, for Christina, we have double-checked all of the steps in the pad for the execution, and we found no more mistakes.
You guys rock. Thanks.
And Christina, while we've got you, we have increased the fan speed, and we're wondering if you want us to keep it at this level for the next exercise session.
We feel it, and yes, please.
We will do that. Thank you.
Thank you for that.
This is the Artemis Flight Control Room at Johnson Space Center in Houston, Texas. Current flight director is Jeff Radigan, leading all of the teams around the room, monitoring Orion's systems. This is Flight Day 7, following launch on April 1st of Orion atop the Space Launch System spacecraft at Kennedy Space Center in Florida. This live view is coming from Orion, looking back at all of us on Earth, or should I say looking to all of us on Earth, as that is where the spacecraft is headed following yesterday's lunar flyby.
Integrity Houston for the timeline. Integrity Houston for timeline.
We're live in Artemis Mission Control, and you are looking at a live view of the Earth from the Orion spacecraft. We are now 5 days, 23 hours, and 39 minutes into the Artemis II mission, the first flight of humans aboard Orion. The crew aboard the spacecraft has been working on the targeting plan for the upcoming RTC-1 burn. That's Return Trajectory Correction 1, a fine-tuning maneuver to keep us on a straight and narrow path on the way to the Pacific Ocean.
Integrity Houston, voice check, Orion Earth 1.
We have you loud and clear, Stan.
We have you the same. Did you hear 2 earlier calls for timeline about 3 minutes ago?
Negative. Go ahead, those calls again.
Okay. We had just tried to get your attention for some timeline things. It looks like there was some uplink going on elsewhere in the system. We're going to chase that down. For the timeline, can you please give us a status on the RHC install and the docking cam install?
Yeah, we're just processing the docking cam install right this moment. Probably be another 2 minutes before it's up. And we're assuming we need to disregard that. And then the RC, we knew it was in the procedure earlier. It's prepped, not quite up yet, but it's in position, so we're good with the RC.
If you're happy, we're happy, and copy the docking cam. Next, at the end of your midday meal, we've got a scheduled flight director crew conference. The vehicle looks great. We don't think we need that conference, and if you agree, we can cancel.
Okay, crew's good up here. We can go ahead and cancel that.
All right, and finally, we saw your intermediate targeting complete successfully, and solution looks good from here.
Okay, we concur, Stan. Appreciate it.
That's it for now. Enjoy your lunch.
We most certainly will enjoy this very rare lunch out in deep space. Okay, Houston, you can go ahead and check the docking tunnel, making sure you're seeing everything you expect in the camera.
Copy, we'll take a look.
We are live in the Artemis Mission Control Room here at Johnson Space Center in Houston, Texas, with a mission elapsed time of 5 days, 23 hours, and 45 minutes into the flight of Orion on Artemis II, the first flight of humans aboard the Orion spacecraft. We just heard some calls while the teams are planning for the upcoming return trajectory correction burn, and the crew has been given a go to get into their midday meal. Meanwhile, here in the flight control room, I am joined by Trey Perryman. He is the Orion Mission Evaluation Room lead. So thanks for joining us today.
Yeah, good afternoon, Leah.
Tell me a little bit about you and your role.
Sure. During this mission, I'm called the Orion MER lead, the Orion Mission Evaluation Room lead. And so this is a team of engineers, a large team of engineers who have a critical role in the success of this mission. We are responsible for really being the engineering source of knowledge base for the mission. So this is a large team comprised of the engineers who designed, built, assembled this spacecraft, and then processed this with our KSC team members before launch. During the mission itself, we are here in the Mission Control Center. And we provide that expertise to the operational teams, the flight ops team, the launch team, before we lift it off. And my role is to lead this organization, this team of engineers, and then during the mission, report out the findings, the observations we have to our leadership team, to the mission management team and others.
So what's the configuration like in the MER? Is it consoles like this? Are you staffed 24/7? Can you break that down?
Sure, yeah. So the MER itself is really a combination of different functions across the spacecraft.
Monitor off of battery until bedtime.
Copy. Acoustic monitor on batteries, and we have checked and are getting good data from the docking camera. Thanks for that work.
Trey knows the rules, that we always let the astronauts talk first.
That's very important. I grew up in, I was telling Leah, I grew up in this room here as a flight controller on the Space Shuttle program and ISS assembly missions, and so I definitely have learned that protocol. So bear with me as I explain this. But up in the MER, this is a collection of focus areas. So we have different, we call them consoles, just like we have in the flight control room here. And these are really representatives of different engineering functions or expertise. And so we have a console, for example, for the power system, for the propulsion systems, flight software, guidance, navigation, control. And so these people are all, they come together in this one place, and they're comprised of different organizations. So NASA, the ESA, the European Space Agency, and our contractors, Lockheed Martin and the Airbus company. So we have a blended team of engineers who participated in the development of this spacecraft, and now its execution.
Well, tell me a little bit about how the MER works with this front room, because I hear calls, on these back loops about checking with the MER on something. So how does what the team does there inform what the team is doing here?
Yeah, that's an excellent question. In the Artemis program, we are really a combination of many teams. And so the operations team, the flight control team here, and then the Orion MER are different teams, and they play a unique and separate role. So the operations team, just to start there, is responsible to execute the mission. And so they fly the spacecraft, they send commands, they work with the astronauts and plan their day and plan the activities on the spacecraft. For the MER team, we're really focused on truly the engineering depth of knowledge. And so we are following the vehicle systems, monitoring the performance of components, of integrated systems together, the whole spacecraft itself, really to understand how the vehicle is performing, understand it against what we were expecting pre-flight, and then to help when there are anomalous conditions. So sometimes there are things that have gone wrong, as others may have noted here for this mission, and it's the MER's role to help the ops team through that. So the operators here in the control center will respond to an issue. It'll be the MER's role to find resolution of that issue over time. So they're unique roles, and we talk and compatible, and so we talk with one another through the mission. So our flight controllers here and the MER consoles talk regularly, every day, all through the shifts, about what's going on in the spacecraft components. And then our team upstairs is led by MER managers, so they're responsible for one shift to the next in the MER. This MER supports round the clock, and just as the flight director does in this room. And so our MER managers and the flight directors coordinate as required.
Well, let's talk about preparation a little bit. So I know that we participate in sims here in the flight control team. How does the MER prepare for a mission like this? Right,
very similarly. So the MER team, we're different than flight controllers. And so where the flight controllers, this is their bread and butter, operations is what they do primarily. The engineers in the MER are also very good because they draw upon their day job of designing and understanding, really qualifying the system, testing, evaluating, improving. And so for the MER team, our training really begins with what we do outside of the mission, pre-flight, ahead of time, and in understanding this vehicle, defining what the vehicle will need to do during the missions. And so when it came to really put I think your question is really about how do we actually specifically prepare for this mission. We began in January of last year, and we formed the team and identified who would be on the team, and then participated in dozens of simulations with the launch team out at KSC, and then also here at mini sims with the flight ops team. And so exercising team communication within our own MER team, and also communicating with the flight controllers, communicating with the launch control team. A lot of the simulations we do stress scenarios, which are useful for learning about the systems, but also learning how do we communicate, how do we resolve in a timely manner, how do we understand the condition of the vehicle and make sure that it is ready to continue to fly and successfully return the crew home.
Fantastic. Well, let's talk a little bit about yesterday. So we had lunar flyby day. Yes. What was the energy like in the mission evaluation room?
It was a fun day. So, and a day, I think, full of emotions. I think for many who witnessed yesterday, probably around the world, we all shared similar emotions and feelings about the gravity and the momentous occasion that was. you know, when Jeremy was calling down and spoke about those craters, and naming those two specific craters, I don't think there was a dry eye in the room. I mean, silence. So most of the team upstairs, like here, are wearing headsets, but we had a lot of extra visitors. So we had speakers on, but you can just hear very clearly Jeremy coming through the speakers we had up there. Very impactful. And then as we approached Paralone, the altitude of closest approach to the lunar surface, lots of excitement. I mean, immense joy as we led up to the Earth set before we went into that eclipse period and loss of signal period. Before launch, the crew members came out and visited the MER and talked with us and gave us patches, those double-sided patches that they decided, where one side is a picture of the Earth with the moon in the distance, and then the other side is different with the moon and close up, and then the Earth in the distance. So we did what they had asked us to do, and so at the moment of Paralune, we all had a little ceremony of or activity of flipping the patches, and so immense joy, excitement. It was pretty fun. And then as we knew we would get signal back as Orion continued to fly on the other side of the moon, and we knew we would get comm back with the Earth, intense focus. Really wanted to make sure, what is that vehicle looking like once we got comm back with him.
It sounds like we were going through some similar things in both of these rooms.
I'm sure.
When the craters were named, it was a moment of silence in here as well. It was very, very touching. And we also have those double-sided patches, and we got to show those yesterday on the broadcast, and we had our own moment of getting to turn those around. So it was a very fun day here as well, and I'm glad to hear that you had that in the MER too. So now that we're through Lunar Flyby, we're officially on the journey home. How do you feel about the rest of this mission and coming down and coming to splashdown?
Yeah, this mission is not over until we get the crew back. So the MER team has extreme focus right now. There are a lot of things that the crew members are doing themselves in the cabin to prepare for this journey home, and we are also watching the spacecraft, and it's really mindful that we are.
Houston for smoke detector.
I'm looking at it right now, and it looks good. Stan, what's up?
It is showing us a bunch of noise and spikes. We're wondering if something is bumping against it.
We were just setting up for a photo in the cabin, but I do not think we have hit it, so that would be abnormal. Christina's checking it. There is one charging cable near it that she's re-anchoring now, but nothing is really in the way of that thing.
All right, copy, Reid. Actually, that's a helpful report. We might have been getting some interference with that cable. We'll keep an eye on it.
We just heard a call from the crew aboard Orion, from the Capcom Stan Love here to the crew aboard Orion about potential signal from the smoke detector, and it may have been interference due to a nearby cable, and the team's going to keep their eye on it, but no alarms here. Trey, we were talking about the journey home now that...
And integrity, we are no longer seeing that noise on the smoke detector, so we're suspecting interference from that cable.
Interesting. Okay, thank you.
Just what we were hoping to hear. We were talking about the MER, and now we're on our way home, and the mission is really not over. It's definitely not over until we have the crew back safely. So what's the focus like right there now?
Right. We have a couple of trajectory correction burns coming home, and so the MER team is looking at systems that would be involved in that and the performance of those burns to really make sure we're hitting the right entry interface conditions. I mean, that's really where, for this spacecraft, the rubber meets the road in terms of recovery and returning home. We need to hit that target. so that the rest of the spacecraft can go through the Earth's atmosphere, open parachutes, and finally successfully splash down. So the MER team is looking at that. We're worked through a handful of different different anomalous conditions on the spacecraft. I think the crew is doing very hard in the space, working through different things in the spacecraft and their own day, their own schedule. And so we're watching that, but really all eyes towards entry interface.
Well, we're looking forward to seeing them under good main parachutes and splashing down.
Absolutely.
And one last thing, I'm very honored to get to tell this story, but I want to make sure people know that this story goes so far beyond just this room and the crew. And do you have anybody that you want to give a shout out to?
Yeah, so the MER team upstairs in this building, it has we have dozens of people every shift, round the clock. But we have other locations. So we have people, I'd like to say hello to the people outside of this building that support the team that I'm responsible for. So we have dozens of people in Denver at a facility Lockheed Martin has. We have dozens of people outside of Amsterdam in the Netherlands, where the European Space Agency has a similar remote site. So for the people who are there, I'd like to say thank you, because we're drawing upon all of the expertise. And that Artemis expertise is really all over, I have a lot of different individuals that come to my mind, too many to mention here right now for a specific shout outs. But to be honest, there are moments in this mission that I will look back and realize the successes we had were really because of the many people and the necessity for us to work together and solve those problems together, which is, I think, largely what Artemis is about. It's really about going to the moon, but it's also about doing so together.
Absolutely. Couldn't have said it better. So the work of thousands of people, and now Artemis II going for all humanity.
That's right.
Thank you so much for joining us, Trey, telling us a little bit more about the MER. And I know you have to get back there, so I appreciate your time here today.
Well, thanks, Leah.
Integrity Houston, 2 items. Number 1 for 12.2.2509, orbit burn execution plus X flange heaters are on and prop avionics are configured.
Okay, we copy, Stan.
And unfortunately, we have seen the spikes return in the signal from the smoke detector. Can you check that the cable is still not near it, and also tell us what cable it was? If that was EMI off of that cable, we definitely need to document this.
Stan, thanks for keeping an eye on that. Nothing is near the smoke detector right now. The only cable that was an unconnected HDMI cable that goes from cameras, to the encoder. We are near it right now, like a couple heads are near it, but other than that, we are not seeing anything that would cause spikes of any kind.
All right, copy. Thanks for that information. We're still scratching our heads down here.
We're live in the Artemis Mission Control Room here at Johnson Space Center in Houston, Texas, and you are looking at a live view of Earth. That's coming from a camera on one of Orion's solar array wings, pointed toward its destination. After lunar flyby yesterday, we have officially begun our journey home, splashdown targeted in 3 days, 1 hour, and 8 minutes. We are now 6 days and 9 minutes into the flight of Artemis II, the first flight of humans aboard the Orion spacecraft. We heard some calls earlier about potential noise or pings on the smoke detector. There are no alarms going off, obviously, on the smoke detector, and the crew sees nothing out of the norm aboard the spacecraft. So teams on the ground are trying to figure out where that interference might be coming from. It's a little more of a quiet day for the crew after their extremely busy day yesterday during lunar flyby. They had the opportunity to speak live with the crew living and working on the International Space Station right now, and shortly thereafter conducted the post-lunar flyby conference with our science officer here on console, Kelsey Young. The crew called down some of their observations yesterday and answered the science team's questions while that was still fresh on their minds. The crew members have also gotten a chance to talk with their families today and have been slated to do some exercise. And they're targeted to execute the RTC-1 burn, that's Return Trajectory Correction 1, at about 7:03 p.m. Central Time. That's a small burn that will help fine-tune Orion's path on its way back home to Earth. Currently, the crew are enjoying their midday meals. On the menu today are some soups. We've got split pea soup, potato soup, turkey tetrazzini, beef patty, tortillas, spicy green beans, vegetarian chili, grilled chicken, tomatoes and eggplant, apples and spice, macaroni and cheese, and some mango salad, as was mentioned in that ISS ship-to-ship call earlier, and some more coffee. Speaking of coffee, there are 43 cups of coffee on the spacecraft to help power the Artemis II crew. I mentioned tortillas as well. There are 58 tortillas on the spacecraft. Tortillas are often used in place of bread when we're talking about Orion or the International Space Station.
Go ahead for Photo TV.
Hey, Stan, on PCD2, we threw about 10 images in there in imagery for downlink for Photo TV subfolder. If Photo TV could take a look and hopefully give us a thumbs up, and if not, give us feedback, that would be appreciated.
We will get those down and take a look and get back to you.
That call from Commander Reid Wiseman down to Capcom Stan Love here in Mission Control Houston about some photos that they are sending down. We continue to get photos from the crew aboard Orion, and you can see all the latest ones on NASA's social media. That is at NASA or at NASA Artemis, and you can also find those at images.nasa.gov. Talking a little bit more about the food on the spacecraft, and tortillas typically being preferred as the essentially bread of choice. Bread has a lot of crumbs, and when in space, those can float pretty much anywhere and get into the ECLS, the environmental control and life support systems. And you do not want anything clogging up your fans for those life support systems, so tortillas are often the preferred, essentially bread of choice. Again, this is a live view from the Orion spacecraft, and you can track Orion at any time by visiting nasa.gov/track-Artemis. That's our ARROW website, which stands for Artemis Real-Time Orbit website. It's a very useful tool telling you exactly how far Orion is away from Earth and the Moon. Currently, the spacecraft is 226,586 miles away from our blue planet, there on your screen. Again, this is Artemis Mission Control at Johnson Space Center in Houston, Texas. We are monitoring the flight of Orion, the first flight of humans aboard the spacecraft. You will see the Earth on your screen, and it will continue to grow bigger and bigger as we get closer to our return, now 3 days and 58 minutes away. Our splashdown was determined by the translunar injection burn that happened all the way back on flight day 2. We don't have a separate deorbit burn. That translunar injection burn set us up for a free return trajectory, harnessing the moon's gravity and Earth's gravitational pull to bring us back for that splashdown. This is Artemis Mission Control at Johnson Space Center in Houston, Texas. Next major milestone on the crew's timeline will be the RTC-3 burn. We are now just 1 hour away from ignition of that burn. This is a 1.4 foot per second burn. Again, that's relatively small, and so this is a trajectory correction burn, as is in the name. These are just small refinements for our trajectory that was set during the translunar injection burn back on flight day 2. Checking in from Artemis Mission Control here at Johnson Space Center in Houston. We are now a mission elapsed time of 6 days and 36 minutes since the launch of Artemis II. Our crew members, Reid Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, are living and working aboard the spacecraft as the first crew to fly aboard Orion. They're testing all spacecraft systems and conducting other demos to help prepare for future missions to the moon.
Integrity Houston, 2 minutes to starfield maneuvers, and we have a couple of other words for you.
Copy, starfield stand. Go ahead, your words.
All right, late call SM prop helium ISO valves are configured. The aux branch 1 will remain closed. There is no change to the burn plan or to the pad. However, right after the burn, we're going to change the active burn plan to the plan in slot 4, which is nominal PLS RTC last.
Okay, makes sense. We're expecting that stand. Sounds great.
Welcome back. We are still here. They are in space.
And Stan, while we have you, there's a new photo in PAO for downlink on PCD2.
Copy. We'll go look for the photo on PCD2.
Those communications coming from Commander Reid Wiseman aboard the Orion spacecraft about some photos that we hope to be able to show you soon. The crew has been great about providing us with beautiful imagery. You can find those images at images.nasa.gov. And we are standing by for the return trajectory correction 1 burn, now just 43 minutes away. Again, this is a small maneuver for the spacecraft, firing of those reaction control system thrusters.
Houston integrity, are we okay for secondary purge line?
Checking. And integrity, we are go for secondary line.
Great, thank you.
You're looking at a live view from the Orion spacecraft and a camera mounted on one of its solar array wings. As you can see, some of the light changing outside of the spacecraft. These cameras are exactly what we used to observe lunar flyby yesterday, and of course we got some beautiful images down from the crew inside the Orion spacecraft.
Integrity Starfield, maneuvers complete.
We copy, Stan. Thank you.
Live here in Mission Control Houston, where teams are continuing to monitor the flight of Orion, coming up on the return trajectory correction burn 1. This is, again, a very short burn. It'll be 1.4 feet per second. And that's coming up in about 31 minutes. Before then, the team here on the ground will have a final burn conference with the crew. If you've been watching throughout the day, you can tell this is a little more of a quiet day for the crew. We are preparing for this burn now coming up in 30 minutes, but the crew had an extremely busy day yesterday and therefore got some time off, especially scheduled for after this burn. The crew woke up at about 10:35 a.m. Central Time, got into their post-sleep period before moving into their daily planning conference, talking with teams on the ground.
In integrity, we see good targeting, go to burn the onboard. Also, MCC has pulled go for RTC-1. And a reminder, there's a 1-hour forward link LOS right about the time of the burn, so we can watch but not call or command during that period. And correction, we're still assess and go for the burn.
Okay, that sounds good, Stan. Then we'll plan on just closing out 12.2.2509 as per the burn plan, and we'll talk to you on the other side of that burn then, or after that loss of return, or loss of forward.
Roger. Stand by for final go. And integrity, MCC is go for the burn.
Okay, we copy, you're still go, and we're go up here.
Recapping a little bit of those communications between Capcom's Stan Love and the crew aboard the Orion spacecraft, specifically Canadian Space Agency astronaut Jeremy Hansen. Ground team confirmed that we are go for the RTC-1 burn, return trajectory correction 1, coming up in 27 minutes. That will be at 7:03 p.m. Central Time. Again, a very small fine-tuning of the spacecraft's trajectory ahead of splashdown, now 3 days and 17 minutes from now. You also heard Stan Love call about a forward link LOS. That's a loss of signal, and that means that the teams here on the ground won't be able to send signals or communications to Orion or the crew. However, we will still be getting communications and data from the spacecraft. We occasionally have these loss of signal periods. Yesterday we had our biggest milestone, loss of signal, which was to fly the Orion spacecraft behind the moon when they were unreachable from Earth for 40 minutes. But again, recapping the crew's day, they had their daily planning conference with the team, getting a read on any of the spacecraft systems and asking any questions before they started their workday. First thing on their schedule today was the ship-to-ship call with the International Space Station. It was wonderful to hear both voices of the space station crew and the crew aboard Orion talking to each other. We look forward to being able to share that audio paired with video from both crew members at a later date. After that ship-to-ship call, the crew got to talk with the science team here on the ground during the post-lunar flyby conference. This was scheduled specifically for this morning while the flyby was fresh in their memories to get to talk with the science team and answer any outstanding questions that that team had following yesterday's flyby. We've continued to release imagery from that flyby period, and they are absolutely remarkable. You can find those on NASA's social media or at images.nasa.gov. Since that post-lunar flyby, it's been a little bit more relaxed for the crew. Christina had some opportunistic science imaging when she was able to take pictures of the Earth and the Moon from the spacecraft's current point. All of the astronauts have also had scheduled time for a private family conference today. That's a PFC. The crew has also, some of the crew members have also completed their exercise for the day and their midday meal. After this RTC-1 burn, again, 7:03 p.m. Central Time, we will have
and integrity looking ahead to the forward link LOS. The ARS is configured for exercise, so Christina can begin during the LOS.
Okay, we understand that, and she will follow the procedure and say facades before she starts.
Thank you. Great words.
Before that crew call, just remarking that the astronauts that have not exercised yet today will do that later this afternoon. And not much else on the timeline for the crew today. Again, getting some well-deserved rest following their very busy lunar flyby day. Looking ahead to the crew's timeline tomorrow, flight day 8, some of the timeline does shift around as this is the first flight of humans on this spacecraft, and we are learning exactly what we need to test while on board. We have another opportunity to work with the OX suits, the Orion Crew Survival System suits. We had the crew suit up in those just a couple of days ago, and obviously this is a major part of the mission because the crew launches in these suits as well as splashes down in them. So figuring out how to put them on and take them off in space, especially in the event of any sort of a cabin depressurization in which these suits would become essentially a private spacecraft, allowing the crew to have a breathing environment for 6 days. It's very important to us to best understand how these suits work in that environment. The crew will also have their scheduled exercise tomorrow, and we are tracking a potential manual piloting demonstration. We saw this just a couple of days ago when a couple of the crew members were able to manually control the spacecraft, continuing to teach us about how Orion flies in space.
Integrity tank pressures are good for the burn.
Integrity copies.
Recent calls from the ground to the crew letting them know that we've had good systems checks aboard the spacecraft. Of course, we remain go for that upcoming RTC-1 burn, return trajectory correction 1. These are such small burns that sometimes they are canceled. We did see that on the way out. These were called outbound trajectory correction burns before we got to the moon, and we canceled the first 2 of those. They were just deemed unnecessary due to the current trajectory aboard Orion. We also see that sometimes when our crew members are flying to the International Space Station, the trajectory will be precise enough that they can forego some of those burns. However, we did opt into the last outbound trajectory correction burn, and we're opting into this return burn as well.
Integrity saws in position for the burn, all brakes set.
Okay, we show the same stim.
Capcom Stan Love calling to the crew that all of the solar array wings, or saws, are in the proper configuration for this return trajectory correction burn. Before we conduct a burn, or even when we conduct exercise, we place these saws, or solar array wings, in a locked position so that no loads imparted on them by the thrusters can damage them. So we are targeting that burn in 16 minutes, but ahead of that, this Artemis II mission is a new opportunity to study the moon, but teams are also conducting other scientific experiments, including on the crew themselves. Here's a little more about the science of the mission.
Artemis II is our return of humans to the moon, flying around the moon on board Orion. But along with that, we're doing a lot of great science.
One of the exciting things about the Artemis missions to the moon is that science is actually a fundamental pillar of why we explore, why we're going, what we're doing in Artemis.
I think it's incredibly exciting that not only are we testing the vehicle, but we're testing science on board. Science where the astronauts are conducting experiments, science riding along with the astronauts. We have astronauts looking outside the window and really observing the lunar surface.
It will help us understand the deep space environment. It will help us understand how that environment affects our astronauts, our systems, and life in general.
So deep space is a challenge for us because you have to leave Earth's protective magnetic field. Here in low Earth orbit, the crew members are protected from some of the harmful radiation. Going to the moon, they'll no longer be protected, so they'll have a higher radiation exposure.
Much like Artemis I, we have so many radiation sensors and detectors that are inside the capsule so that we can fully understand and appreciate the radiation environment for protecting our astronauts. In my hand here, I'm holding a tissue chip model. This is the exact design that's going to be flying alongside the astronauts. We'll be collecting samples from each of the crew members, and we can make these organ chips out of the astronauts themselves. So every crew member will have their own avatar on board, and then upon return, we can evaluate that deep space radiation environment and what that compares to the astronaut themselves. Not only are they going to help change the course of medicine for the astronauts, but revolutionizing that on Earth as well.
We're looking at sleep, we're looking at team dynamics, we're looking at how you interact with the environment. We're also looking at the immune system, so what are the biomarkers? We're using saliva as a method to study hormones and different things in your body that may change during a mission like this. And then finally, how do we function after microgravity, being close to the moon, then returning to Earth?
Which will ultimately help us achieve our goal of getting humans to Mars.
And then on top of that, we have an opportunity to look at the moon from deep space on the far side for the first time in over 50 years.
Having human eyeballs and brains back around the moon is going to unlock a new generation of lunar science discovery. The human eyeball is capable of taking in so much data in just a split second. They'll be able to tackle impact history, volcanic history. They'll be able to look at how the albedo, or kind of the shade and hue of the moon and the color of the moon, can tell us something about how that terrain evolved over time. We're integrating science in ways that have never been integrated into human exploration before. We have a front room mission control flight controller position called the Science Officer. We have a brand new science back room where it's basically our brain trust of lunar scientists and geologists supporting the crews of the future. And Artemis II will allow us to really test how this works so that future missions are really set up for success.
We'll also be deploying some CubeSats. They're small shoebox-sized spacecraft of their own. They're each provided by another country, one of our partners. As they conduct their research, they'll complement what we are doing at the moon with Orion.
It is so incredibly exciting to be a part of this mission.
It has been, really one of the privileges of a lifetime.
I can see the work I'm doing benefit crew members right now and benefit the crew members in the future. So it's incredibly exciting and it's very rewarding.
As this rocket launches humanity off of the Earth, we'll be setting the stage through our science to prepare humanity to leave Earth and explore the solar system.
Understood, Stan.
Live here in the Artemis Mission Control Room, we are 11 minutes away from the RTC-1, Return Trajectory Correction 1 burn. We did hear some cautions from the cruise systems about a propulsion system issue. The team is discussing whether or not this is an optocoupler issue or something in the prop system.
30 seconds to maneuver.
Okay, integrity copies.
Currently, the Orion spacecraft is maneuvering to its burn attitude. This view on your screen is a visualization of the Orion spacecraft and its current position. You can see those attitude maneuvers. Team here reporting that we are in attitude for the burn, now 8 minutes away.
Integrity in attitude for the burn. We may be about 7 degrees different from what was calculated ahead of time, but that's within our tolerance.
Okay, copy. And Houston integrity. We just want to report what we're seeing here to make sure you're seeing the same thing. So ox helium isolation valve 1 was closed and inhibited prior to the caution and warning. And then it seemed that when ox helium isolation 2 closed and fuel helium isolation valve 1 closed and were inhibited, that is when the caution and warning started.
All correct. Thank you. And integrity, we had a branch swap. We thought we had inhibited the fitter. Evidently not. We're still evaluating.
Integrity copies.
We are now 5 minutes, 28 seconds from the return trajectory correction 1 burn.
Terry to Houston for prop. After the burn, we'd like the valve reconfig per the procedure, and recall that's been edited so that you won't touch the branch 1 aux. We will have 2 PRUs to recover later. We'll do that after the forward link LOS.
Okay, understood. So we will execute the procedure as written with the delta about the aux helium isolation valve 1.
Good words, and the procedure guides you that way.
Thank you, Stan.
Now less than 4 minutes until the return trajectory correction 1 burn. The crew did receive some warnings, or cautions I should say, about something in the prop system, specifically the PRUs. These are the pressure regulator units, and those will need to be reset later today. We are going to go into a forward link LOS. That's a loss of signal where we can't send communications or commands to the crew. However, we will still get data and communications from the spacecraft. That forward link LOS will start shortly after the burn, now about 3 minutes away. And the team here in Mission Control Houston remains go for that burn. Now 2 minutes away from the return trajectory correction burn. Again, this is a small burn using the reaction control system thrusters on the Orion spacecraft. One minute away from the return trajectory correction burn. Standing by for the RTC-1 burn. We have ignition and 4 good engines and good control.
Integrity preliminary look is a good burn. Still assessing. 40 seconds to LOS.
Okay, Stan, we saw a good burn on board as well.
Roger.
Confirmation from the crew that they also saw a good return trajectory correction 1 burn coming at 7:03 p.m. Central Time. This view coming from the spacecraft, looking down at the European service module and the solar arrays. Again, we just conducted the RTC-1 burn. That's return trajectory correction 1. That came right on time at 7:03 p.m. Central Time, and then we entered a forward link LOS, or loss of signal. That means that we cannot send communications to the spacecraft right now, but we can still get data from them. Again, a very quiet day for the rest of the day for this crew. They will have some opportunity to exercise. There will be another private family conference. And that's about it before the crew steps into their private medical conference, or PMC, before they get to sleep tonight. We schedule these private medical conferences occasionally throughout a flight so we can have them check in with the teams here on the ground and report how they are feeling while in space.
Use and integrity RHC stow is complete, and we're proceeding through the prop valve reconfiguration with your comments in mind.
This is Artemis Mission Control. Again, we are in a temporary loss of signal forward link with the spacecraft, meaning we can't send communications or commands to them, but we still get their data. As you can see, we are now over 53,680 miles away from the moon. We are here as part of the Orbit 1 shift, and that's about 10,000 miles farther than we were upon arrival earlier today. This is Artemis Mission Control. We did get final confirmation of that return trajectory correction 1 burn being a successful burn, and it ended up being 1.6 feet per second delta V. We are in a forward link LOS, or loss of signal, and the crew aboard the Orion spacecraft is, Christina, Koch specifically, is going to get into some exercise. Again, this is a quiet day for the crew as they had a very busy day yesterday and have some busy days coming up as well.